will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Welcome back. So we are in our GitHub repo. So let's get into our EKS storage with RDS database section, which is 06 section. Okay. So the step 1 introduction just now we have completed, which is nothing but what are the problems with MySQL pod and then EBS CSA, and how are we going to solve them with AWS RDS database. So now we need to review the VPC, which is created as part of our EKS cluster. The reason for that is because inside that VPC, in the private subnet, we are going to create our respective RDS database. Okay. So let's go to EC2 and let's go here, and from we'll go to VPC, and if you see we have two VPCs available. One should be default and then one created as part of our EKS CTL EKS demo 1 VPC. So now as part of this VPC, it might have already created the subnets, right? So if you see here, so these are the subnets it has created. Okay, so it has created the two private subnets, in one is in US East 1A and then one is in US East 1B. So we are going to create the RDS database in these private subnets. Okay, so let's go ahead and then create them now. So where is this? Yeah. So we have reviewed and then understood that as part of this cluster, it created 4 subnets, 2 private and then 2 public, and our cluster nodes means like our EC2 worker nodes are currently running in public subnets, and the RDS database we are creating in the private subnet. So let's create a DB security group for us as a prerequisite one, which we will leverage when creating the security group. So let me go to EC2 here, and I will go to security groups, right? And I'll create a security group, and the name of the security group is this, and I can also copy this and I'll paste it. Allow access for RDS database on port 3306, and the VPC is EKS CTL EKS demo 1 cluster VPC. Okay, and I'm going to add the inbound rule saying that MySQL, right? So I'm going to allow access for MySQL 3306 from anywhere, even as it is in private subnet. Ideally we really don't need to worry. So even if we say access from anywhere. Okay, so I'll create the security group, and this is completed. So the next step is to prerequisite to create a DB subnet group in RDS, right? So let's go to RDS service. So search for RDS here and select the RDS relational database service. And once it is opened, so we are going to create a DB subnet group, okay, with US East 1A and then 1B. So we'll go here, and then you can see in the left navigation, you can see the subnet groups here. So I'm going to create a subnet group like this, and we'll also have description EKS RDS DB subnet group. Choose VPC. VPC is our EKS CTL EKS demo 1, and availability zones we are going to use 1A and then 1B, so that whatever the RDS database it gets created can be available in those locations. And in 1A and then 1B, what are our private things, right? Private subnets we need to select now. So let's go to VPC and identify which are our private subnet things. Okay, so we have 4 here. Let's go here and go to subnets, and private subnet, this one, so it is 64.0/19, so that is one. So I'll select 64.0. Okay, so that is one. And in 1B it is going to be 96.0/19. Okay, so I'm going to select 96. Okay, so 64 and 96 are private subnets here. So in our DB subnet group we created that, and then we are going to create it. Okay, so now our DB subnet group got created. So we are going to create the RDS database. Okay, so let's go back here and then go to databases and create a database, right? And we are going to create a standard create. So that's what we have selected here. And the engine is going to be MySQL. And it is going to be a MySQL community edition. And the version, whatever it is populated automatically, I'm using it. Okay, so we really don't need to worry about what version it populates here. Even in future, when you see it, it might be 5.7.2.2 or 5.8. Our application is going to work everywhere. Okay, so now the next thing is we are going to select free tier. Okay, so if you use production, you will have the high availability and fast consistent performance. And if it is free tier, you are going to use a single node for our RDS database testing. So we are going to use free tier for now. And the DB instance identifier. Okay, so we are going to say user mgmt DB. So that is what we are going to use the name. So this name, whatever you want, you can put it. So, and the master username we are going to use is DB admin. Okay, so now the DB admin will be my master username to connect to it. So we also need to update our user management deployment manifest there. We'll do it in our next steps. Earlier we have given whenever we have a MySQL pod running inside EKS cluster, we have used the root user there. So now we need to update that root user to DB admin. And password, we are going to use the same one, which is nothing but we are going to use DB password 11. Okay, so what is this? Why it is showing? So my Safari browser auto generated something here. I'm not going to use that. I'll say don't use, and I will use DB password 11. So whatever we have generated as a Kubernetes secret, right? So the same thing I'm going to use. So DB password 11. Good. So now instance size, I'm going to leave it as T2 micro, 1 CPU, 1 GB. That should be fine for us. And the general purpose storage and then all these things 20 GB. I'm going to leave these things as is here. And we are going to say availability and durability. We are going to leave it as is here. Okay, so if you want, once if we would have selected the production here, then obviously we would have got the automatic, this option would have been enabled here, and then multi-AZ deployment we have done. But this is for our testing purpose. We really don't need to worry about these things. Okay, so now what in VPC we are going to say EKS-CTL VPC, which we want to create this, and inside that VPC, this is the DB subnet group we have selected, EKS RDS DB subnet group. And we are creating in the private subnets. We really don't need to worry about publicly accessible. Default is no. And choose an existing security group. As a prerequisite one, we have created the VPC security group, means like DB security group. So let's go ahead and then select that. So which is nothing but EKS RDS DB SG. Okay, so what happened? Remove the default one. We only need EKS RDS DB SG. So that is selected here, and then default one we have removed. And availability zone, I want it to be created in US East 1A. And database port, I'm going to use 3306. Okay, so I'm going to use the password authentication, which is nothing but DB password 11, whatever we have created. Okay, so these are additional database options if you want to use. So initial database, whatever you want to create. So I can directly say user mgmt DB schema, it need to get created here. And all these things. So let's go here, and I really didn't worry much about other stuff here, but if you want the initial database, you can say user mgmt DB. So this schema is required for us to automatically create. This schema will help us to connect to this, means like whenever our user management application, Spring Boot application starts, it expects this database schema is available for us. Okay, so user mgmt DB, you can directly give it here if you want to, or you can leave it as is and then move on and then I have created one more step for us. So that is an interesting step. Okay, so the reason I created that way is from our Kubernetes kubectl, I should be able to connect to the RDS database and then run the commands for MySQL. Because it is in private subnet, you cannot connect via internet or from your desktop, right? But from our Kubernetes cluster using kubectl, you will be able to connect. So to use this step and then create the user MGMT schema from here, I really not using this configuration option to create a initial database name. So just for our learning, and then in future if you have any issues to connect to the database, RDS database, then you need to know the way how you need to connect it when it is in the private subnet, right? So for that purpose, I am not initializing or not creating an initial database user MGMT, which is required by our user management microservice. So we will leave it empty and then we'll create at this respective step 4. So for now, we'll move on and then create the database, right? So now if you want this password to be saved here in my this one, not now. Okay, so I really don't care. So it will take close to 10 minutes or something to create this database. So I will pause the video until then. Our database is available now. So if we click on this user MGMT DB, so you will find the endpoint here. So this is the endpoint we are going to configure in our external name service so that our workloads running on Kubernetes cluster will be able to connect to this RDS database. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In previous lecture, we have created our RDS database, right? So for our RDS database security group, if you see, it should have allow access, which we already provided it. We can cross check once if we want to. Okay, so we can go here and the security group is this one, and you should have allow access from everywhere. So that's good. So we have cross checked it. Now we are going to create a Kubernetes external name service manifest and then deploy it. So as usual, it will have API version, kind, metadata, and then spec. And the type of the service we are going to create is external name. And the external name value is going to be whatever the value we have got from RDS database endpoint information. Okay, so if you go to RDS here and inside the database, so this is the information we are going to use, the endpoint information. So let me go back here and go to Visual Studio Code, and it is service and API is V1, and under metadata name and MySQL service name is MySQL, and the spec, inside spec will have type and then external name. So first it is external name service and external name value. Okay, and external name value going to be whatever is present from our RDS database endpoint. Okay, so which is nothing but this one, right? So this is what we have copied. So this is good. So now we have created the MySQL external name service manifest. So let's go ahead and then create that now. So this is the one, deploy this manifest. So let's go to 06 EKS storage with RDS DB and then say kubectl apply -f kube manifest says 01 MySQL external name service. Right, so once it is created, so we can say kubectl get svc, the MySQL service got created now. So the next step is to connect to that service and then create the database user MGMT schema inside that. Okay, so kubectl run. So this is the kubectl client, whatever we are creating, MySQL client, and just provide the host name of our thing. Okay, so paste and -h and the whatever the host name we want to provide, we need to provide. So that we will take it from here and then provide it, right? Paste, and then still we have additional command here, which is nothing but password, username, and then password. Okay, so copy and then paste it. So let's see what happens. So it got connected. So which means it connected to our MySQL database, which is in the private subnets from our Kubernetes kubectl command line. So now we'll go ahead and then create the stuff whatever is required. So we'll see initial schemas, whatever is provided, which is default schema should be available. Information schema, InnoDB, MySQL, performance schema. So create a database user mgmt. Okay, right? So it got created. So now you can see show schemas, and you have the user mgmt got created. So now we can exit from here. Okay. Okay, so now we have exited. So now let's go back and then update the deployment file username from root to db admin. So if you see here, this is the user management microservice deployment, whatever we have brought it from our previous sections. And here you can see db username. So earlier it is root, now we need to change it to db admin. I already changed it for my previous testing. So in db password Kubernetes secret, we really didn't change anything here. It is going to be db password 11 only, which we have given for our MySQL pod, and then here also if we have any doubt about it. So base 64 decode, and then let's see what it is. Okay, it should be db password 11, right? It is db password 11, so we should be good. So now let's go back. So this is the one which we need to update if it is your previous manifest, whatever you have copied. And if you are using directly from here, from my course, and then respect to this folder, then we really don't need to worry. So now we have completed the update step also. So let's move on and then deploy all the manifests. Okay. So if you see here, 01 already created, which is unchanged, which is MySQL service. So remaining things got created, which is REST app service, microservice, and then MySQL DB password. Okay. So I'll say kubectl get pods, and it is coming up. It might take a while, so let's wait for it. And if you want, we can even see the logs of this. Okay. So tail the logs of this user management pod, and inside that container is only one container, right? So it started the application. Okay. So which means it connected to the database and then it started the application. If you want to do additional check also, we can do now. Why? Because we just created the schema. If you want, we can go there and then check whether it has created the tables inside that. Okay. So use user mgmt will connect to that respective database, and then I will say show tables, right? So users table is created, which means it is successful. My application got success. My user management application started successfully. I'll say exit, and I'll say kubectl get pods to see that one by one it is ready or not. So it is ready. So I'll say kubectl get nodes -o wide. Okay, so to get the public IP. So once we get the public IP, we know that our node port is going to be 31231 only. If you see here, 31231. So I'll take the public IP, copy. I'll go to the browser, new browser, http:// public IP of my worker node, and 31231 / user mgmt is the context, and health-status. Okay. So it should be available now. We can see it. It is up and running, right? And it's the same thing. So now we can go ahead and then delete the stuff and then clean up whatever we have created as part of this RDS section. So we are not deleting this RDS database now. Why? Because we are going to work on classic load balancers, network load balancers, and then elastic application load balancers, and then application load balancer related different features like context-based routing, SSL redirect, port 80 to 443 redirect, and then external DNS with Route 53. All those Kubernetes manifests we are going to write. If that is the case, So we should not delete this. We are going to leverage this, which means like how many cloud services we are going to use, that many we are going to use as part of this Kubernetes thing. So one thing important here is if it is not in use or after this section you are going to break and then you are going to see remaining lectures from tomorrow, then just go ahead and then stop it. And whenever you are creating this database also, please ensure that whenever you selected MySQL here and then you selected free tier here, okay, so if you really don't want any backups, so you can uncheck this option, okay, whenever you are creating the database, okay. So already you have created and now I am telling about it, you can delete and then recreate it so that your backup costs are saved for you, okay. So means like it is only a minor storage amount, but really don't worry. Or you can even go and then edit your database and then remove the backups also. So whatever the option is available for you, so you can say modify here and just to save, right, disable the automated. So backup retention of 0 will disable the automated backups and delete existing automated snapshots of this DB instance, okay. So you can enable this so that what happens is like if you really don't want any of the backups consuming your space, and then if this course takes longer days for you to complete, and RDS database should be available for you to learn your other load balancer stuff also. We are going to from here on take RDS as our one of the backend database for our user management microservice application. So you can say continue and then apply immediately and then modify the DB instance. So now let's go back here and then delete this stuff. kubectl delete -f and then kube manifest. So whatever we have created, we have deleted and then cleaned up. So with that we have completed the RDS database section. So in our next lecture we'll focus on classic and then network load balancers in 07. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to primarily look into classic load balancer implementation on Kubernetes. But before going to understand about classic load balancer implementation using Kubernetes, so let's see on a very high level what is elastic load balancing in AWS. So in AWS, we have three types of load balancers available for providing the high availability for our applications. So those are classic load balancers, network load balancers, and then application load balancers. So to see in detail about all these three things in a feature by feature comparison manner, we have this link available for us, and then instead of a slide with all these features, AWS has documented it super. So we can directly see on the AWS documentation page. So we can see here application load balancer, network load balancer, and then classic load balancer. So the protocols each one supports is application load balancer is a HTTP and HTTPS level only. And network load balancer is at TCP, UDP, and then TLS protocols it supports. And classic load balancer supports both TCP, HTTP, HTTPS, and SSL. One important thing we need to understand about classic load balancers is this is a legacy load balancer which is going to get deprecated anytime in the near future. But another important thing about this in Kubernetes format is like in relation with Kubernetes is whenever we create a service in Kubernetes, right, a service object in Kubernetes, and of type load balancer, the default load balancer it is going to create on AWS is classic load balancer. So that's the important thing we need to know. And in addition to that, we'll have platforms like as it is legacy, it also supports the EC2 classic environment and also latest VPC environments. So these are new ones which all supports directly the VPC environments, which is nothing but virtual private cloud. So like this, there will be tons of features available here, and most of the time the highest features supported load balancer is going to be application load balancer. If you see here, everything will be tick, 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 and then available for us. So with that said, we have a dedicated section for application load balancer, which is section 8, where we will be looking into creating an application load balancer from Kubernetes and then enabling the SSL for it, and then also enable the port 80 to 443 redirect. So like that we are going to implement step by step the entire application load balancer in our section 8. But currently in section 7, whatever we are dealing, we are going to create a classic load balancer using Kubernetes and verify the same thing on the AWS management console, how the load balancer got created in AWS management console. In the same way, we are going to create a network load balancer and then test it. So all these things means like to create a classic load balancer or network load balancer, we are going to write a service Kubernetes service manifest and then verify whether it got created here in EC2 load balancers section. So that's about the thing which we are going to implement. So moving on, so if you see earlier what we have done is like with RDS we have implemented the entire solution, but what we have done there is like we have used the node port service to test it. Okay, but now in a real production environments, usually we are not going to use node port service, right? Means like IP:port. We are going to DNS register our URL and then with URL we are going to access it. So if that is the case, and we also need to have a port 80 or 443 things, right? Instead of 31231 or some other random ports, we need 80 or 443, which are the default browser ports for us, right? So for all those things, let's start with using one of the load balancers for high availability and then start moving on with the next steps. Okay, so now with this design, we are going to add classic load balancer for our entire previous design, which is nothing but we have seen this design earlier, which is not here. User management node port service is there. We need to replace this with classic load balancer. So before going and implementing the classic load balancer, we need to understand one important thing here. That is nothing but the EC2 worker nodes, which is nothing but the node group. EKS node group is created in the public subnets here. So and the cluster control plane is also in the public subnets and EKS node group is also in the public subnets. So ideally, where in a 3-tier architecture design, where we deploy our workloads, means like our application code in the private subnets, right? So with that said, now we are going to create a cluster control plane, means like which will support the private node groups, means like the node groups created in the private subnets. So let's see that now, right? So in a AWS cloud, in a VPC, we have two availability zones. So we created a EKS cluster control plane. So what happens? So it also creates equivalent public and then private subnets in the availability zones where we have provided to create the cluster, right? So we selected during the cluster creation, our availability zones for our cluster is going to be 1A and then 1B. So it created public and private subnets in those availability zones. So next what happens is we are going to create a EKS private node group, which means earlier you have seen this instances worker nodes present in public subnet. So now they are present in private subnet here. So these EC2 instances will be created in the private subnet. So now how the communication is going to happen? Earlier it is in public subnet, it can directly connect to EKS cluster. But if it is in private subnet, it is going to leverage the NAT gateway to communicate it, provided if our API, cluster control planes API, Kubernetes API is having the public access. Even we can have it enabled internal, which is direct VPC access, wherein instead of going via NAT gateway, this connection can be directly to cluster control plane. Okay, when we do via VPC access. Okay, but for now we will use the default and then standardized option, which is go via NAT gateway. So now our EKS cluster control plane service, we are connecting, means like worker nodes, and then this cluster control plane is nothing but the master nodes, right? These are in communication using the NAT gateways. So the next thing is we are going to create our RDS database in the same private subnet, or you can create two more private subnets in two availability zones and then inside them also we can create. But what I have done is I have leveraged the same private subnet, whatever EKS cluster control plane created as part of cluster creation. So the same thing I have leveraged here. So now I have the RDS database here. The next thing is its equivalent external name service we are going to create in these worker nodes, means like we are going to create external name service and then provide the Amazon RDS DB's endpoint URL for that to send the traffic to this RDS DB. And next thing is we are going to deploy our user management application, and then it will connect to the databases via external name service. So now here comes the classic load balancer. So this user management classic load balancer service we will create in the public subnet, right? And in addition to that, what happens is like now whenever users try to access the application, user management application, they use the classic ALB DNS URL, right? So this should be CLB DNS URL. I will change it. So using the CLB DNS URL / user mgmt / health status, whenever we access it, it comes to the classic load balancer, and from classic load balancer the request gets distributed across different pods, right? So it will send to one pod the request, and then once from pod it need to identify its MySQL DB, right? So it will go to external name service, and then from external name service it is going to connect to RDS DB and then get the data. So if we have any users created, then those users we are going to access it. If no users got created, then we can go ahead and then create the user using the Postman project, whatever we have seen earlier. But on a high level, this is going to be the overall architecture which we are going to implement now. So to implement on a high level, what we are going to do is, currently our worker nodes are present in public subnet, so which we are going to delete them and then create our worker nodes in the private subnet, which is nothing but we are going to create a EKS private node group in private subnets. So as a step 1, we are going to do that now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's get into 07 classic and then network load balancers. So inside that, the first step is to create our EKS private node group. So let's go ahead and then do that. So we are going to delete the existing public node group and then create the new private node group, okay, in the private subnets, okay. So let's go ahead and then list our current node groups available in our EKS cluster. To do so, we need to provide the EKS-CTL get node group and on which cluster it is available, right? So EKS-CTL get node group and on which cluster? Our cluster name is EKS demo 1. So it will provide how many node groups available in our cluster. We have something called in a cluster EKS demo 1, we have EKS demo 1 NG public 1. Okay, so this public node group we are going to delete it now. So to delete it, EKS-CTL delete node group and the node group name and inside which cluster it need to be deleted. Okay, so let me copy this and then paste it. So that respective node group will get deleted. So why we are deleting it is we really don't need to run anything on these nodes, right? So we are going to create everything in our private subnets. So that's the reason we have initiated this. So now let's go ahead and then create the EKS node group in private subnets. So the key option we are going to provide in addition to the previous whatever we have done in our other step, right? So if you open this here, so in the step EKS create cluster using EKS-CTL, if you see here, we have created the node group here which is on the public subnets, right? So all these are same, okay, only additional one option we are going to give, which is nothing but node private networking. So when we add this additional tag to our command, so it will create the node, all the EKS nodes in the private subnets, okay. So that's what, all the worker nodes in the private subnet. So that's the reason we said node private networking at the end of this. And in addition to that, we also changed the name EKS demo NG private 1 instead of public 1. So let me copy this and then paste it, right? And then it is going to create our node in our worker nodes in the private subnet once we provide this command. So it's getting created. So it might take another 2 to 3 minutes to create this worker nodes. So I'll pause the video until then. So our node group creation in the private subnets got completed. So let's go ahead and then verify the stuff now. So where it is created and all those things. So verify if this node group is created in private subnets. So we can verify in two ways. One is kubectl get nodes -o void will provide the external IP address of the worker nodes. So far in the entire course, whatever we have implemented till now, so we used to get the external IP address using this command, and using that only with node port we used to test. So let's say clear and kubectl get nodes -o void. So if it is created in private subnet, it really will not have any public IP, right? So that's the reason external IP is none. Only we have the internal IP available for us. So this confirms that our Kubernetes node group has been created in the private subnets. But for additional verification, we can also do something like verify the associated subnet details for this respective node groups. Okay, so we can go here to the management console, right, and go to EKS, Elastic Kubernetes Service, and in EKS demo 1 cluster. So if we go to networking tab, right, no, if we go to compute, and if we go to our respective EKS demo 1 ng private one, right, so this is the new node group, it has been created, and we can click on any one of the subnets here. Okay, so I'll click on one subnet here, and if we go inside that subnet, right, so the subnets associated to it. Okay, so this is the subnet associated to it. You can clearly see that that subnet has the private US East 1A, so which is created in private subnet. So for additional confirmation, you can even see the route table, right? So if you see, if it is a public subnet, it will go the outbound traffic or inbound traffic, everything will be via internet gateway and not the NAT gateway. But if it is private, means like via private subnets, means it is going to go via route table, will have the NAT gateway, via NAT gateway, whatever it is created, right? So this is the NAT gateway via which outbound traffic from our worker nodes is going to go. So one thing we need to understand here is, so let me go back and let's get this up fully. Yeah, so now if you see these worker nodes, whatever is there, they will have the kubelet which will be communicating to the cluster control plane, which is nothing but EKS demo 1, right? So that happens via NAT gateway now. So that's what is the entire design. So this completes the creation of node group in the private subnets, right? So in our next lecture, we'll focus on implementing the classic load balancer. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to implement this entire thing. So which is nothing but RDS database is already created and then ready for us. So what we are going to do is we are going to deploy the MySQL external name service and our user management deployment, and also we are going to write a classic load balancer service Kubernetes manifest, and then deploy all these three things and then ensure that everything is working as expected for us when we access our application via browser. So let's go ahead and then do that now. So we will go back to our browser and we are going to 0702 classic load balancers CLB, right? And as a step 1, we are supposed to create our load balancer.yml, right? So let's go back to our Visual Studio Code, and if you see in 0702 in kube manifest, so we'll have the external name service which we have copied from our previous RDS database section. It is going to be same thing. And user management microservice also, no changes inside that after integrating with the RDS database. So nothing, we are going to copy the same. Secrets also same, it is the same. And even the load balancer service, right, which is nothing but previously it is a node port service, the same thing we have copied here. Okay, so now what we are going to do is that respective node port service, whatever we have created as part of RDS service, means like RDS database integration. So now we are going to change it to load balancer type. So what we need to do, earlier we used to create a node port service. So now we are going to create it as a load balancer type. Okay, our service as our Kubernetes service, whatever we are going to create is a load balancer. And we already know that default, whenever we create this manifest and deploy it in Kubernetes, it is going to create a classic load balancer by default. And one more important thing here is, because we are using the load balancer type, we really don't need to mention this node port here. Okay, so that one is removed and the type is load balancer is implemented. So done. Okay, so this default is going to be CLB. And now one more important thing here is port. Okay, so 8095 in browser also you can say CLB DNS URL colon 8095, or you can even use the listener port as 80. So which means like a browser default port, right? Means like you really don't need to provide any port there. So you can use 80. In addition to that, if you want to change the name of your service, right? So little bit like CLB user management REST app, something like this. Okay, CLB user management REST app, and if you want you can even add service, whatever you want. Okay, so I'll say CLB, which is nothing but classic load balancer user management REST app. So that's all. We have done only 3 changes. One is we removed the node port here from our node port service, and we ensured that the type is going to be load balancer, which means we removed the node port here and then added load balancer. And then we changed the port to browser default port. So whenever we access our load balancer will be created with a listener port 80, right? Our service port is nothing but our load balancer port here, right? So which means on browser you really don't need to give 8095 something like that. Okay, so that's about it. Now this is completed. We'll go to our next step here, which is nothing but deploy these manifests. Okay, so I'm going to edit this section little bit. So ideally this should be kube-manifests here. So I didn't edit that. Now I have edited. It should be good now. So now let's go ahead and then deploy it. Okay, so we'll go to 07, and inside 07 we are going to go to 0702, right? And inside that we are going to say kubectl apply -f kube manifest. So where we have all the files there. Okay, so now it is going to first create our MySQL service and also do the user management microservice deployment and its secrets thing, and also deploy the CLB user management REST app service. Okay, so now we can say get svc should create a load balancer, and it also provided the load balancer URL here, right? You can see, and the port is 80. Okay, so now it also created the external name service also, whatever we have implemented. So let me clear kubectl. I'll say get pods here. Okay, and it's waiting for to come up. So if you want, we can parallelly check the logs of our application. So it came up successfully, no issues with the database. So kubectl get svc, right? So this is the load balancer. Usually it will take some time to get the load balancer spinned up, created, and then available for us. So let's go here and go to EKS. Now we'll go to service EC2 service, and inside that we'll go to left navigation load balancers. Okay, so network and security load balancing, load balancers. So now you can see here the classic load balancer is getting created. You can see type is classic, right? And state still not available for us, so we can wait. So instances are registered, but they are out of service because of maybe our pod is still coming up. Once it comes up, it will take a while to register and then ready. So let's wait for a while. So it is in service now, so it is available for us. So health checks are passing. So we can copy the DNS name from here, whatever is provided, right? So this is the DNS name of our ALB. So we can directly use this, or we can even copy the DNS name from this section. Okay, and copy this and we can go to browser and say that DNS URL /user mgmt /health-status, right? So we can see it, user management service is up and running. Want to even test the entire flow till the RDS database, so we can even go to our Postman and then create a user and then test it. So first list the users, so there should not be any users available by default. So let me cancel this. So first we need to provide the environment here, right? So let's go to settings and then add a environment, and it should be URL, right? And we are going to say CLB, right? And we are going to say http:// the entire ALB DNS URL, right? And then add it, right? And close it and go to CLB environment, okay? And let me close this. Let's close everything here, and we'll go to list users once and then test it, okay? The environment we have selected is CLB, which is nothing but classic load balancer. So nothing, 200, no data available inside that. So let's go ahead and then create a user now, okay? So it is going to create a admin to user. So let's create it. So user created, and the error is related to notification service, we can ignore. And one more time, list services, and we should have the user available for us. So which completes the entire flow, which means from your browser you have accessed the load balancer, and then load balancer has forwarded the request to one of the pod here, and this pod has been sent to the MySQL external name service. And from external name service we went to RDSDB and then created that respective user. So entire flow we have tested. So in our next lecture we'll focus on network load balancer. So for now we'll go ahead and then delete all these things, okay? So I'll change this also to kube manifest, so not an issue. So let's go back here and kubectl delete -f and then kube manifest, and everything whatever we have created should get deleted now. So from Kubernetes you have created the classic load balancer in AWS, and then you are also deleting the classic load balancer in AWS. So we really didn't touch any management console, we didn't create anything here, okay? So everything is automatic for us. See, now everything is gone. So once we deleted, and our classic load balancer also got deleted. So this completes the classic load balancer demo, and then we'll see the network load balancer demo shortly. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create a network load balancer. So in previous lectures, we have created the classic load balancer. So now we are going to create a network load balancer manifest and then execute them or deploy them to create a network load balancer in AWS in our architecture. So only change means like the entire architecture is going to be same. Only change here is instead of classic load balancer service, we are going to create a network load balancer service. On a very high level, what is network load balancer service? We have seen earlier also, which is nothing but a TCP load balancer or a UDP load balancer, which doesn't need any HTTP traffic, okay, which like it will be communicating at the TCP level. So whatever it is, my application allows TCP or HTTP, anything is fine for it. So I will use the TCP load balancer here. In regular use cases or in general use cases, like TCP load balancer are used for load balancing or providing the high availability features for the applications which doesn't need HTTP, maybe like a SMTP server or some other stuff, right? So whoever needs plain TCP load balancing, so we can provide using network load balancer. So now let's go ahead and then create the stuff, okay? So we'll go to 0703 network load balancer NLB, and if you see here, so everything, entire manifest is going to be same as classic load balancer. Only one additional step will be there, which is nothing but we are going to add an annotation named NLB. So we are telling the Kubernetes, whenever you are creating this load balancer type service, also reference this annotation stating that use the network load balancer, which means whenever you are creating a load balancer, create NLB service, which is nothing but network load balancer service. So annotations are nothing but we are trying to tell them that tell the Kubernetes that we are giving the pointers that create the respective service based on whatever is provided inside it. Okay, so now we are providing and telling Kubernetes that create a NLB service here. Okay, so that it will create the NLB service, which is nothing but a load balancer. Okay, so now let's go back to our Visual Studio Code and 0703 network load balancer NLB, and here is the thing, I copied the entire stuff from CLB, and what we'll do is we'll change the name here to NLB, and let's add the annotations, right? Annotations, under metadata we are adding the annotation, and the annotation name is going to be NLB, right? So as usual, whatever is there, we have copied it. So now we have completed the network load balancer manifest. So rest all is going to be same. Type is load balancer. Selector for our pods is going to be user mgmt rest app, and port is going to be 80, and then target port is 8095. Okay, so now we will go back and then deploy this stuff. So let me come out of that, and then let me go to 0703. Okay, and kubectl apply -f kube manifest. So this should create as kubectl get svc, right? So now it is creating the NLB load balancer. So let's go back to our management console and then refresh it here. Okay, so it is getting created, and of type network, you can see it here. So it is creating a network load balancer now. So it will take a while to provision it. So once it is provisioned, we will look into it more. Good. Now our network load balancer is active now, and we can see the listener port, whatever we have configured here, which is nothing but port 80, is the same we have got it here. And we can even see the target groups, and inside target groups we can see both the targets are healthy, which means both the worker nodes are healthy, and then we communicate to our worker nodes with the 31984 to go inside and then access that respective pod. Okay, so now this looks good. So let's go ahead and then access our application. So we can say, we can copy this complete URL, copy, and then go to browser, and then http:// and user mgmt/health status, right? It should be up and running. So we can even check this way, or we can go to our Postman, and here also we'll have our health status URL. So this is CLB URL. If you want to test for NLB, so then provide the NLB and then provide the URL as the variable, and the value is http:// and this value. Okay, so same should be updated in current value, add it, right, and change the environment to NLB, and then go to health status and then test it, right? So where is this? This is not notification. We need to check user management. Yeah, this is the one, user management health status, URL/user management health status. So it should look this way, right? So let me send it. So it's up and running. So earlier we have created the admin to user. If we send it, ideally it should list that. Okay, so if you want, we can even create one more user, admin3, and then even test it. Okay, save, send. Okay, created, and then list the users, and we have the admin3 created. So everything is working fine here. So our next step is to go ahead and then delete the manifest, right? So we have tested everything, so we can delete it now. So kubectl delete -f and then kube manifest, right? So this completes our NLB demo, network load balancer demo. So in our next series of lectures in section 8, we are going to focus on application load balancer, which is the very important one where we are going to focus on ingress concepts also there. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of AWS EKS load balancer controller, Kubernetes ingress, application load balancer, and also external DNS. So considering all these 4 things, we are going to implement 14 demos. If you see here, as part of demo 1, we are going to install the AWS load balancer controller. And after that, we will learn the ingress basics as part of demo 2. And later, we will implement the ingress context path based routing as part of demo 3. And later, we will implement the ingress SSL and ingress SSL redirect as part of demo 4 and demo 5. So considering all these demos will be related to application load balancer, which means every demo whatever we are creating, we are going to implement these things using Kubernetes manifest on AWS application load balancer. And we are also going to install external DNS using demo 6. And later we will implement ingress plus external DNS and Kubernetes service plus external DNS as part of demo 7 and demo 8. Ingress plus external DNS in the sense, so whenever we deploy our ingress manifest, automatically the DNS registration happens in the AWS Route 53, whatever the DNS names defined in the ingress manifest. So that we are going to learn as part of demo 7. And as part of demo 8, not only with ingress, with regular Kubernetes service, which is of type load balancer or node port services. So there also ingress external DNS related annotations can be added to DNS register those service related DNS names inside the Route 53. So which means the Kubernetes service inside that you can add the external DNS annotation for your application, and that DNS name using external DNS can be DNS registered in the AWS Route 53. So both demos, ingress plus external DNS and Kubernetes service plus external DNS, we are going to implement. After that, we are also going to implement ingress name based virtual host routing. So we already implemented ingress context path based routing. So which is nothing but when the request comes to /app1, go to app1. Whenever the request comes to /app2, go to app2 related backend. So those are context path based routings. So name based virtual host routing is nothing but whenever you access your application with app1.somedomain.com, go to that respective app1 related backends. And when you access with app2.somedomain.com, the request should go to app2. So even that example we are going to implement using Kubernetes ingress manifest, and equivalent ALB rules will be created. And after that, we are also going to implement SSL discovery host and SSL discovery TLS. So without hard coding the AWS certificate manager, certificate ARN in your ingress, so you can use the options like SSL discovery host and SSL discovery TLS. So those things also we are going to learn in detail with practical demos. And after that, we are going to implement ingress groups. So with ingress groups, the large configuration of Kubernetes ingress manifest can be split into small Kubernetes manifests, and we can create multiple ingress resources and combine them to a single group with a priority order. So we are going to learn that in detail as part of demo 12. And after that, we are also going to learn about ingress target types, which is instance mode and then IP mode. So far, whatever the demos we have implemented is default is going to be instance mode, and we implemented it with instance mode. So here, as part of demo 13, we are going to learn about IP mode and implement that with IP mode. And finally, we are also going to implement the ingress internal ALB. And to test that, we are also going to deploy a curl pod and connect to curl pod and test it. So let's go ahead and then practically implement all these things now. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this section, we are going to understand about ALB ingress controller on a very high level. So before going to ALB ingress controller, we are going to look into AWS application load balancer. So let's see what is application load balancer and then what it supports, and how this application load balancer can be created from Kubernetes manifest using ALB ingress manifest using ALB ingress controller. So we are going to see all those things in our this respective section. Okay, so let's move on with what is application load balancer in AWS, right? So ALB is a super advanced next generation load balancer in AWS. So it supports tons of features. Let's see what are those to get a high level idea on how much it is capable of. Okay, so it supports path based routing, which is nothing but context path based routing for our applications. So single load balancer can be leveraged for using for multiple applications hosted on AWS based on context paths. Okay, in the same way it supports host based routing. So which means in addition to context path based routing, we can deploy multiple applications and then using different host names we can route to those respective applications back of this load balancer. Example, apps.kubencloud.com will go to applications, okay, and users.kubencloud.com can go to user management REST services. So something like that. Okay, and next is support for routing based on fields inside the request like HTTP headers, HTTP methods, query parameters, and source IP addresses. So by seeing these three features itself, we can understand that it's not only a load balancer, it is also a routing solution on the HTTP level. Okay, and supports for redirecting request from one URL to another. So more or less standard Apache web server or Nginx related features it has. Okay, supporting for returning a custom HTTP response to, and supporting for registering Lambda functions as targets. So anything deployed in AWS, one service always integrates with multiple other services. In the same way, multiple Lambda functions also we can register them to this respective load balancer targets. In the same way, it supports for load balancers to authenticate users of our applications through their corporate or social identities before routing requests. So this is the latest feature available, and then it is for providing the out-of-box authentication for our applications hosted on this respective load balancer with our corporate or social identities. So it also supports containerized applications, mainly AWS ECS out-of-the-box integrated with this respective application load balancer. It also supports monitoring the health of each service independently, as health checks are defined at the target group level. Okay, so that is also one important feature. It supports registering targets by IP addresses. So due to this support, we are able to leverage this very effectively in Fargate with EKS. Okay, so because of this respective feature. Okay, and it inside VPC or outside VPC also it can do this stuff. Okay, using the IP address. And all in all, ALB is latest and greatest load balancer with many good features. So this is about what application load balancer is capable of and what it can do. So now, if this type of load balancers, if we can use it as a ingress service for us from Kubernetes, so we are going to have a leverage of all these features for our applications hosted on Kubernetes. So that's the beauty of AWS here. Okay, so which means like AWS application load balancer can be provisioned for our Kubernetes using Kubernetes ingress manifest. Okay, so let's move on. So let's see what is this ALB IC. ALB IC is nothing but ALB ingress controller, right? So ALB IC triggers the creation of an application load balancer and the necessary support AWS resources whenever an ingress resource is created in the EKS cluster. Okay, with the annotation name kubernetes.io ingress.class is equal to ALB. Okay, so the ALB ingress controller supports two traffic modes, instance mode and then IP mode. We also seen that application load balancer supports both the traffic modes, instance and IP. So the same things are available in ALB ingress controller also. Okay, let's see what are those in detail. And so this is one more documentation link for this ALB ingress controller. So you can review this link and then understand annotations inside that and everything whenever you are going through it. And when you are going in the advanced sections, you will understand more and then more about it. Okay, so now let's see the instance mode. So in instance mode, ingress controller registers nodes within your cluster as targets for the ALB. So which is nothing but, nodes are nothing but our worker nodes in our EKS cluster will be registered to the targets inside the application load balancer. So traffic reaching the ALB is routed to node port for your service and the proxy to the prods. So which means like whatever the node port services we are going to create in front of our applications, means like in front of our application deployments. So first ALB routes to those node port services, and that node port service is routing to our pods. Okay, so this is the default traffic mode available in our ALB ingress manifest. Okay, and you really don't need to define or specify that implement instance mode. By default it is applicable for us, but we can also explicitly specify it like this with target type as instance annotation in our ingress manifest if we want it. And we have the IP mode. So in IP mode, it register pods as targets for the ALB. Here if you see, it registered the EKS worker nodes as targets for our ALB target types. Okay, but here it registers the pods as targets for the ALB. So traffic reaching the ALB is directly routed to our pods for our service. So now here if you want to use IP, then you can use the target type as IP. So now why these two instance modes and then how it is useful for us from AWS EKS perspective, that's the core thing here, right? So when you are using worker nodes, means like managed node groups in your EKS cluster, by default you can use instance mode. Or if you want to use IP mode, still you have an option of using the IP mode. But when you are using only forget only profile, which means in your cluster you really don't have any other node groups, managed node groups like EC2 instances, you are just only using forget profiles. At that point of time, you need to use and if you want to use application load balancer, then you need to use only IP mode. Why? Because forget nodes doesn't support the node port service. Why? Because we really don't have control on forget related nodes, whatever it has created in the background, because that is a serverless concept, right? So that's about the reason you need to use IP mode. So whenever you are using forget, for those things, if you need ingress manifest, you can use IP mode. And whenever you are using managed node groups, you can use either instance mode or IP mode. So that's about these traffic modes. So now moving on, so let's see how ALB ingress works. So this diagram I directly took it from their website, and we will see what it is and then from step-by-step process how it looks like, and the link for this diagram is available here in detail. Okay, so now you see this is a Kubernetes cluster. Okay, and these are AWS resources. So we already said that whenever we provision our ingress manifest on the Kubernetes cluster, it is going to create a AWS resources. So what are those AWS resources is what we are going to see now, right? So in the step 1, the controller watches for, which is nothing but the Kubernetes controller watches for ingress events from API server, and when it finds ingress resources that satisfies the requirements, it begins the creation of these AWS resources. So what are those AWS resources? You can see number 2, which is application load balancer. So application load balancer is created in AWS for the new ingress resource provisioned in the Kubernetes cluster. Okay, but one thing here is this application load balancer will have a version of ELB v2. Okay, so whenever you see, we have two types of resources in elastic load balancers in AWS, and this application load balancer, whatever it is getting created, is ELB v2. So that's one important note you need to remember. Okay, why? Because whenever you are giving IAM permissions and all those stuff, you need to ensure that ELB v2 also included in those stuff. Okay, and the next thing is target groups. Okay, so now the point number 3 is target groups are created in AWS for each unique Kubernetes service described in ingress resource. Okay, so whatever the application related node port services you have defined in your manifest, so those related stuff has been created, and with that including those node port services, it is also going to create whatever the pods you have defined also, right? So now another important thing in your ingress manifest is listeners, right? So whatever the listeners you specify for your application load balancer, those gets created here, which is 80 or 443, whatever you define. So those listeners also will get created in your application load balancer. So finally, rules, right? So as we said that application load balancer supports context path based routing, so which is nothing but /star/product/accounts. Okay, so /star should go to one target group, /product should go to one target group, and then /account should go to one target group. So all these things are supported in our respective application load balancer, which we are provisioning you as a Kubernetes manifest. Okay, so now another thing here is like if you want to delete, right? So if you want to delete all these things, just delete our Kubernetes ingress manifest here, means like ingress resource, whatever we have provisioned, delete it, and then all these things will get deleted. So that's about the ingress on a very high level.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. As part of this section, we are going to install the AWS Load Balancer controller on AWS EKS cluster. And this is the core controller which helps us in creating the ingress services in Kubernetes cluster. So let's understand more about this in detail. So from Kubernetes ingress perspective, earlier AWS used to have AWS ALB ingress controller, and that is renamed and redesigned now as AWS Load Balancer controller. And earlier it used to create only AWS application load balancer related resources on AWS from EKS cluster. So when you deploy a ingress manifest, then it used to create a application load balancer on AWS. But now, as part of this AWS load balancer controller, it can create AWS application load balancers and network load balancers. So for creating the application load balancers, we are going to use the Kubernetes object named ingress resource. And for creating the network load balancer, we are going to use the Kubernetes object of type service, and also we are going to ensure that it is annotated for NLB. So we are going to add an annotation stating the network load balancer so that it can create the network load balancer for us. And when coming to the earlier version, which is AWS ALB ingress controller, so it doesn't support latest ingress API version, which is networking.k8s.io/v1. So from Kubernetes version 1.22 onwards. So in addition to that, this ALB ingress controller will not have any developmental releases planned, and soon it will also get deprecated. So with that said, we need to use the latest and greatest available from ingress perspective on AWS EKS cluster, which is AWS Load Balancer controller. And this supports latest and greatest from ingress perspective. So this is the ingress API which the latest load balancer controller supports. Now, the next thing here is how this load balancer controller, what are the objects involved from Kubernetes perspective for this load balancer controller. So let's see that in a visual manner. So if you see here in the EKS cluster, we have something called kube system namespace. And you can see in AWS cloud, other AWS services will be created here, and the core EKS cluster related resources, and inside that whatever it is going to get created as part of this load balancer controller or which is involved with that, we are going to depict them inside this kube system namespace because they are going to get created in this namespace. So to start with, the very important point here is AWS load balancer controller related service account in Kubernetes. And we'll create this service account, and also we'll create a IAM policy and then IAM role, and this IAM role will be annotated inside this service account. So this IAM role ARN will be annotated inside this load balancer controller service account. And why we are doing that, what it is going to provide us in detail when we are implementing practically, we'll know more in detail how we are going to do that. So on a visual manner, So these are the objects involved. You will have a IAM policy, you will have a IAM role, and that IAM role is annotated with a Kubernetes service account of type load balancer controller. So a load balancer controller service account will have an annotation of IAM role associated with it. And next thing here is, so whenever you deploy your load balancer controller, so it will create a deployment which eventually creates the pods related to this load balancer controller. And in addition to that, it will also create a load balancer controller webhook cluster IP service. And it will also create a AWS load balancer TLS related secret. So these are the things which are involved from Kubernetes perspective. In kube system namespace, so it will create a service account, it will create a load balancer controller deployment, it will create a load balancer controller webhook cluster IP service, and it will also create a AWS load balancer TLS service. So now this service account, whatever we have created, is associated with this deployment, which means it is also associated with the pods. So whenever this load balancer controller will get the ability, means like this load balancer controller gets the ability to create the application load balancers or network load balancers from EKS cluster in AWS cloud. So let's see that. So if you see here, in every EKS cluster or any Kubernetes cluster, we know that we'll have the Kubernetes API server. So as a Kubernetes administrator, so what I am going to do is, I'm going to, using the kubectl CLI, I'm going to deploy the ingress K8s manifest. And this load balancer controller will watch for the ingress events on this Kubernetes API server. And whenever it finds this ingress K8s manifest is deployed, so this load balancer controller will take that manifest and go ahead and then create the application load balancer for us. So from AWS services perspective, you can see that as a application load balancer. And in Kubernetes, you can see that as a ingress resource. So this is what is going to happen whenever we deploy a simple ingress service manifest. Another important thing which we need to know here is this AWS load balancer controller deployment. So which means inside this deployment, we have the load balancer controller pods. So those are nothing but workloads in our EKS cluster. And those workloads are able to create a AWS service named AWS application load balancer from EKS cluster itself, right? So how it happened is based on the permissions whatever we have given for this load balancer controller. So we have created an IAM policy which has the permissions to create application load balancer related resources or update the resources or delete the resources related to application load balancer. And that IAM policy is associated with this IAM role. And this IAM role is annotated. This IAM role ARN is annotated with the AWS load balancer controller service account. And this service account is used by this load balancer controller deployment related pods. So due to that, from EKS cluster itself, we are able to create the AWS application load balancer whenever we have deployed the ingress K8s manifest. So this completes the introductory part of AWS load balancer controller. And in our next lecture, we are going to practically install it and then understand it in a better way. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. Let's go back to our GitHub repository now. So we are in AWS Stack Simplify / AWS EKS Kubernetes Masterclass internal repository, which is a private repository of mine. And whenever I do the course updates, so I will add the new section here and then update the sections in detail here, all the documentation related to that. And then when I am publishing, once everything related to that section is completed, so I will publish the videos on Udemy and also ensure that that equivalent section related Git changes also will be added here. So this is the public repository where you have the access, which is AWS EKS Kubernetes Masterclass. And currently inside this, you have only 08 ELB. So there is nothing related to 08 new ELB. But now, once this entire section recording is completed, so I will ensure that this respective section related all the changes are also added here, and then you will get access to them. So for now, the recording will happen on this internal repository, and we'll move on to the section 0801 load balancer controller installer. So this is the first thing we are going to do as part of this mega section. And here, so as part of step 00 introduction, we already understood what is load balancer controller, and then how it is going to have the objects inside Kubernetes, and then how it is going to create the application load balancer and all those things. So this is primarily on a high level. If you see it, we are going to create a IAM policy and make a note of that policy ARN, and then we are also going to create a IAM role and associate this IAM policy to this IAM role, and also we'll create a Kubernetes service account and bound this role and then service account together by annotating this service account with this role ARN. That is what we have seen in the picture here. So we'll create a IAM policy, and that is associated to the IAM role here, and this IAM role related ARN will be annotated in the Kubernetes service account here. So let's come back here, and in addition to that, we are also going to install the AWS load balancer controller using the Helm 3 CLI, and also understand about the new concept introduced inside this AWS load balancer controller. So is ingress class concept, and we are going to understand that, and also whatever the ingress controller we are going to install, we are going to make that as the default one. So we'll see all those things in detail when we are implementing these steps, right? So for now, we'll move on to the prerequisite steps here. So we have 3 prerequisites which we are going to implement now. So the first prerequisite is ensure that you have the EKS-CTL and then kubectl command line utility installed. So as part of the prerequisite section of this course, already they were installed, but we will cross check once, right? So we'll say EKS-CTL and version. So as on today, this is the latest version, but whenever you are doing it, it might be a different version too. And also we'll see the kubectl, and we'll say version and -- short, right? So it will provide the both the client version and also the server version. So the client version I'm using is v1.22.4 and the server version is 1.21.5. And if you see the note here, you must use a kubectl version that is within one minor version difference of your Amazon EKS cluster control plane. For example, if you are using the 1.20 kubectl client, so you can use the Kubernetes cluster of version 1.19, 1.20 and then 1.21. So this means that as our client version is 1.22, our server version supported here are 1.21, 1.22 and also 1.23. So now let's come back here and move to the next prerequisite. Next prerequisite is create your EKS cluster and worker nodes if not created. So we already created the EKS cluster as part of section 0102 and also as part of section 0701, which is nothing but we have created as part of this respective section a private node group. So if you see in 01, right, in section 0102 we have created the EKS cluster, and also we have created a and associated a IAM OIDC provider. And after that, as part of section 0701 we have created a EKS private node group. So both things are completed now, which means we should already have the EKS cluster and EKS node groups in our private subnets. But it is an additional cross check whether those were present or not. And if those were not present, then you can go ahead and then directly execute this command and this command and this command, these 3 commands to create them immediately. And as those were already created, so now we'll go back to our EC2, which is our AWS management console, and verify that we have the 2 private node instances running in a node group, and we can go to EKS Elastic Kubernetes Service and also verify the same things here on a very high level, right? So we'll go to EKS cluster, and EKS demo 1 cluster is up and running, whose Kubernetes version is 1.21 as on today. And if you see here, So let's wait for it. So 2 nodes are running there, and the current workloads you can see core DNS, AWS node, and then kube proxy. And the configuration information we can see here in detail. So this is what we have and then ready for us, so that we can go ahead and then directly install the AWS load balancer controller. So once the prerequisite 2 verification of these things were completed, so we'll go back here and also verify the same things using EKSCTL commands. So EKSCTL, and you will say get cluster, and you will find that EKS demo 1 cluster is up and running. See, EKS demo 1, and it is created using EKSCTL CLI. And we can get the node groups for this respective EKS demo 1 cluster. So let me copy this command and run it here and see the node group associated with this respective EKS demo 1 cluster. So you can see EKS demo 1 ng private 1 is the node group name, so which is already created, and it has currently 2 nodes running. And verify if any IAM service accounts present inside this EKS cluster. So let me see that too. So EKSCTL get IAM service account and provide the cluster name. So it will say that there are no IAM service accounts found inside this EKS cluster. Okay, fine. And another important thing here is, if you have not configured your kubectl kubeconfig, so whenever the EKS cluster is created, it will automatically get created, the kubeconfig, which is located in $home/.kube/config. So this will have the information. So I'll say cat, and this will have the information about connecting to our EKS cluster using kubectl, all the authentication information. And if by any chance whenever you run the command kubectl get nodes and you are not getting any output from this local desktop CLI, you are not able to connect to your remote EKS cluster instances in AWS cloud, and you are not getting this type of output, so then you can go ahead and then run this command AWS EKS, and in which region your cluster is created, and you can say update kubeconfig and provide the name of your cluster here. So my name of my cluster is EKS demo 1, which you can get using EKSCTL get cluster to get the cluster name, and then update your cluster name here and run this command. So what I'm going to do is, so I will empty my kubeconfig here, right? So I'll say .cube and config file. In .cube folder I have the config file, and that I have cleared it. And if I say cat for that file, nothing is there. So now I will run this command, so that again it will reconfigure, or it has added the content there, and you can see all this is added. So before that, what I'm going to do is, so first I'll clear that, right? And then run the kubectl get nodes and then see what happens, right? So let me run the get nodes, and it says that connection to the server was refused because there is no configuration information for kubectl to connect to your AWS EKS cluster. So it has no information about to which EKS cluster this kubectl command need to connect and get the nodes information. So we'll run this command, which is AWS EKS region US East 1 update kubeconfig name EKS demo 1. And now we'll run the kubectl get nodes, and we'll get the information because our local config file has the information, connectivity information to our remote EKS cluster running on our AWS cloud. So this is good. And these are the prerequisites we need to cross check, which is you have your EKS cluster up and running, and you are able to connect it to using kubectl get nodes, so that your kubectl CLI is configured perfectly with that. So that's what we are supposed to verify, all these prerequisites. So in our next lecture, we are going to move on with creating the IAM policy. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. As part of step 2 and then step 3, we are going to create the IAM policy, IAM role, and also create a load balancer controller service account in Kubernetes and annotate that respective service account with this respective IAM role. So let's go back to our GitHub repository, and as part of step 2, we are going to create a IAM policy. So here, whatever we are going to create, we are going to take the latest version. So we'll go to our directory 08 new ELB application load balancers. So let's go to the terminal here and clear this. And we are in AWS EKS Kubernetes Masterclass internal. In my case, in your case, it is going to be AWS EKS Kubernetes Masterclass. And we'll go inside 08 new ELB application load balancers, and inside that we are going inside 0801 load balancer controller install. And inside this, if you see here, I already have the files IAM policy latest and IAM policy v231.json. So what I'm going to do is, whatever I have existing one, I'm going to remove this IAM policy latest one. And using this curl-o and IAM policy latest.json, and I'm going to download this policy from this location. So let me go here and copy this entire line. Copy. And if you see here, already my IAM policy latest file was already removed as part of rm command. So I'll run this command curl-o IAM policy latest JSON. So it has downloaded the latest file here. So if I say lslrta, so you can find the IAM policy latest file. So you can review that directly in our Visual Studio Code here and go to that 08 new ELB application load balancers, and inside 0801 load balancer controller install. So if you open this IAM latest policy.json, so you can find here in detail the policy related permissions, right? So all these are the things it is required for us. So there are a lot of permissions required for us, and all these are outlined here out of the box from AWS perspective. So now if we come back here, if you want to use any specific version, so the file name you need to create it is with that specific version, and you need to find this file with that specific version. So if you in Kubernetes 6, the repository name is AWS load balancer controller. So I'll go to github.com/ and I'll go to that load balancer controller, and if we come back here and in main docs install, right? So if we go to inside this folder, you will have something called docs folder, and inside docs folder in install folder, right? So in install folder you can find the IAM policy.json, which is the latest one, right? And you can use that one, or you can go for a specific version which is related to v2.3.1 or v2.3.2 etc. directly by specifying that version number here, and accordingly you can download that version. So we are going to use always latest, so that's the reason I have provided the latest means like the root repository related, main repository, main branch related information here. So you can see here, so main docs install IAM policy.json, which is referring to the latest file here, right? So now let's come back here, and we have successfully downloaded that respective file in this folder AWS 0801 load balancer controller install. And now we are going to do is, we are going to create a IAM policy, and policy name we are going to provide is AWS load balancer controller IAM policy, and the policy document we are going to reference from file : / and our file name which is in that respective current working directory. So we are going to create a policy using the AWS CLI command, AWS IAM create policy. So let me copy this and paste it here, and this should create the IAM policy for us. So it has created the IAM policy, and this is the ARN it has created for us. So we need to make a note of this ARN because we are going to reference that in upcoming sections. So for me, this is my AWS account ID, and remaining things are going to be same for you also. Your account ID usually will differ, but rest all is going to be same. So anyway, I'm going to copy this and come back here, and I'll say file, new file, and just save this ARN here for a while. Now let's come back, and we have successfully created the IAM policy. So let's in AWS services go to IAM service and search for this policy. So this is the policy we have created. So let me copy this policy name and then go to policies and search for that policy. And you will find this policy, which is a customer managed policy, and inside that all these are the information whatever it is going to provide, means like the access we are going to get as part of this policy, right? So now let's come back here, and if there are any errors also, we really don't need to worry, but just make a note of the policy ARN. That's good. So now in the next step, we are going to create a IAM role for the AWS load balancer controller and attach the role to the Kubernetes service account. So for this, we are going to use the EKS-CTL, right? So using EKS-CTL, we can do that. EKS-CTL directly have a command called create IAM service account. So which means it will create a service account in Kubernetes and also create a IAM role in AWS IAM service and associate the policy whatever we have created to that IAM role and take that IAM role's ARN and then annotate it in the Kubernetes service account. So all this with a single EKS-CTL command, we are going to do that. And we really don't need to worry about manually implementing all these things. So applicable only with EKS-CTL managed clusters. And our cluster we have created with EKS-CTL, and we are going to do successfully. How we are going to do it, we are going to see now. So this command line will create a AWS IAM role, yes, and associate the IAM policy whatever we have created, and also will create a Kubernetes service account in K8s cluster and also annotate this Kubernetes service account with the IAM role ARN. So now let's come back here and understand about that command. So before understanding about that command, so first verify in kubesystem namespace any service account with name AWS load balancer controller is present or not. So you can say here, come back here and say clear and kubectl get SCA. SCA is the alias name for service account, and say -n and kubesystem. In namespace kubesystem, we are verifying, we are listing all the service accounts, and on the top we will verify it will come in the alphabetical order, and on the top we will verify if there is anything with AWS load balancer controller. So with AWS, you can see AWS cloud provider and AWS node, but nothing else is provided here. So anyway, if you want, you can provide the exact name and then also search. So we will search with this name and AWS load balancer controller, and it is saying that no service accounts with that name are found currently. Now let's come back here and understand this command, which is EKS-CTL create IAM service account. So for this command, we need to provide the cluster name, our EKS cluster name, which is EKS demo1, and this service account in which namespace we need to provide, our Kubernetes service account, right? So in the namespace kubesystem we need to create, and name of my service account is going to be AWS load balancer controller, and the policy we are going to attach. Why? Because this create IAM service account is nothing but with IAM it is going to create a IAM role, and service account it is going to create a Kubernetes service account. So which means for this IAM role you are going to attach your policy ARN. So whatever the policy you have created in the previous step, so its ARN we need to provide here, right? And override existing service accounts is an additional tag, and if you want you can say approve, right? So this is the command we need to provide so that it will get created. So in my case, the cluster name is EKS demo1, and namespace it need to create for everyone, it is going to be kubesystem, and for you only if your cluster name is different, put it here. And name is AWS load balancer controller, which is my service account name, and attach policy ARN. So ARN, whatever we have made a note as part of previous step, this is the one, right? So the same thing you need to provide here. For me it is not going to change because it's the same account ID, AWS account ID. In your case, this account ID changes, right? Or whatever the note you have made for your IAM policy, so the same thing you can replace here. And finally you can take this command and run it. So let's come back here and run the command EKS-CTL create IAM service account. So let's wait for this command to execute, and it need to create. So it is going to create a CloudFormation stack for this. So we are going to see that. See, so creating IAM role for service account, and in kube system namespace it has created the AWS load balancer controller service account, right? So it has created the service account, and it is also deploying the stack EKS-CTL EKS demo 1 add-on IAM service account kube system load balancer controller. So this is the CloudFormation stack name. So it is deploying the CloudFormation stack, and inside that we'll have all the automation to create all these things and then associate it with the Kubernetes service account. So let's wait for this thing to get created. So we can see here created service account kube system / AWS load balancer controller. So let's come back here and verify using EKS-CTL CLI. So let's start with, we'll do multiple verifications. So let's do one after the other. So we'll say EKS-CTL get IAM service account and provide your cluster name, right? So ---- cluster equal to EKS demo 1. And if you remember earlier when we have run this command, we have got no IAM service accounts. But after running the previous command, it should have created one service account for us, right? So in the kube system namespace, the service account name is AWS load balancer controller, and it is associated with the role ARN whatever is created in AWS IAM service. So the role name is going to be EKS-CTL EKS demo 1 add-on IAM service account kube role 1, and then some dynamic name generated here, right? And now, so let's come back here and verify the CloudFormation template EKS-CTL created and IAM role. So let's go here and go to CloudFormation service, or you can go to services and search, right? So I'll open a new window here. I'll say, I don't know, suffer some, yeah, I got it. So let's go to the CloudFormation service here and let's verify the same thing. So we have the EKS-CTL EKS demo 1 add-on IAM service account. So this is the stack name for us. So let's open it, and once we open it, right, go inside the resources tab and click on the link physical ID to open the IAM role. So inside this, if you go to the resources tab, so you can find only one resource is present here. This is the resource which is nothing but a IAM role. The type is a AWS IAM role. So if you click on this, and if you want, you can open in the new tab. It will open the IAM role created for us, right? So this is the IAM role created, and it is associated with the policy whatever we have created, AWS load balancer controller IAM policy. It is associated with that, and you'll have the trust relations related to STS assume role with web identity and all these things. And now let's come back here, and this is the ARN of this role, ARN and then so and so, right? So now let's come back here and verify KITS service account using kubectl. Mainly you need to verify the annotation, right? So first we will get the service account, right, whether it is created or not. So we'll list all the things and verify whether it is present there or not. So you can see here AWS load balancer controller is present there. So clear, and we will run the command get that respective service account, right? And we should see that that service account is present and which is created 3 minutes before, right? And now describe that service account, kubectl describe service account AWS load balancer controller and -n kube system. So when we describe that service account, so we should see the annotations tab mainly. So let's see here, name of the service account is AWS load balancer controller, and namespace is kube system, and labels you can see app Kubernetes IO managed by EKS-CTL, and in the annotations you can see eks.amazonaws.com/role ARN, and this is the role ARN it has been annotated with. So now let's come back here and search for that role ARN here, and you can see this is the same thing here. So that's the important thing. So now you can see that newly created role ARN is added in the annotations confirming that AWS IAM role bound to Kubernetes service account, right? So this completes the creation of service account, IAM policy, IAM role, and annotating that IAM role ARN inside this Kubernetes service account. So in our next lecture, we are going to go ahead and then install the load balancer controller using Helm. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. As part of step 4, we are going to install the AWS load balancer controller using Helm. So let's come back to our PowerPoint presentation. And if you see here, already we have completed the part where we have created IAM policy, IAM role, and then service account, and then annotating that service account with IAM role. So now whatever we are seeing in this box, which is load balancer controller deployment, its equivalent secret, and also its cluster IP service, webhook cluster IP service. So these things we are going to deploy now, and using Helm we are going to do that. So let's come back here, and if you don't have Helm installed on your local desktop, so you can install the Helm using these commands, right? So brew install Helm if it is Mac OS, and if you want to use different operating system, so you can see here using Helm with Amazon EKS, and you can see here if it is Mac OS, use this command and brew install Helm. And if you are using Windows, so you can say Choco install Kubernetes Helm using Chocolatey. Or if you are using Linux, so you can directly download the respective binary, and then using gethelm.sh script you can install it. So now let's come back here and install it using brew install Helm, because we are using the Mac OS here, right? So I'll say brew install, and then I will say Helm, and it will download the Helm and then install for us. So let's wait for it to install. So we can see here Helm was successfully installed. So maybe it is 3.8.0 version. So let's see what exactly it is. So I'll say Helm, and then I'll say version, and we see that v3.8.0 is installed for us, right? So now as part of step 0402, install AWS load balancer controller. So before installing that using Helm, we need to understand about two important notes here. So the one important note here is, if you are deploying the load balancer controller to Amazon EC2 nodes that have restricted access to Amazon Instance Metadata Service, which is IMDS service, or if you are deploying these load balancer controller to Fargate, then add the following flags. So using the Helm, tell the package that you are using the region code so and so, and then VPC ID where you are going to deploy it. So these two things it is asking us to set in our Helm command here. So if you are going to use with on restricted EC2 nodes where you don't have access to IMDS service, or if you are using Fargate. So instead of worrying about this note, so I made a standardization that in our command we are anyway going to use this, right? And next thing is, if you are deploying to any region other than US West 2, then add the following flag to the command that you run, which is image repository, replacing account and region code with the values for your region listed in Amazon EKS add-on container image addresses. So this is nothing but if you are using in different regions other than US West 2, so you need to provide your ECR endpoint, which is nothing but Elastic Container Registry endpoint from that respective region, so that it can download the AWS load balancer controller from that respective region only. So example, if currently our EKS cluster is in US East 1. So if you see this, get region code and then account info from here. So let me open this, let me close this, and you can see here. So these are the information. So for US East 1, this is the endpoint, right? So that is what we need to provide. So this is the account information you need to provide here, and region code you need to provide here. So this is the value you need to get. So this is the account, and US East 1 is the region code for US East 1 location. So I have provided the link here for getting the region code and account info. So get those information and provide the account ID and then region code here, and rest all is going to be same, which is Amazon, AWS, load balancer controller, Amazon, AWS.com. So from here everything is going to be same for you also. So based on the region whatever you are using, provide that region here, which is US East 1 or US East 2 or anything, and also account ID you can get from this respective link whatever is provided here. So US East 1, so this is the value. So we'll see that when we replace down there. Okay, so now the first thing is add the EKS charts repository. So Helm repo add this EKS charts repository. So let me copy this and come back here and clear and add the command. So EKS already exists with the same configuration because I might have run earlier also, right? So it has added, and I'll run the command Helm repo update. So it is trying to get the updates for Ingress, Nginx, EKS, Jetstack, Stable, Bitnami, whatever is available in my existing local repo. It is trying to update all those things. So now let's come back here, and as part of this command we are going to install the AWS load balancer controller. So let's see this command breakdown and then understand in detail. So Helm install and AWS load balancer controller. So from repo EKS/AWS load balancer controller, and this need to be installed on -n cube system namespace, and provide your set. These are the set commands where you will provide the values for your respective package whatever you are going to deploy. So now set cluster name. So our cluster name is going to be EKS demo 1, and service account create. So during the Helm install itself you want to create the service account AWS load balancer controller? No. Why? Because it was already created earlier, and then now we don't need to create it. As part of previous steps we have already done that. So which means service account create is false. And what is the service account name we have created, which is AWS load balancer controller, which we have done as part of previous steps. So that is good. And region and VPC ID we need to set. So region code is US East 1. So you can see here, right? And VPC ID, so we are going to get now where our AWS EKS related VPC created for this cluster. And image repository, as we said, we need to get that from the region code and account ID in which your EKS cluster is created, which is 602.401 some 43452. So this is the account ID, and US East 1 is the region. So the same thing you can find it here. So now let me take this complete command and copy this command and come back here, and here let's paste this command and ensure that all the things are same for us. EKS demo 1 is the cluster name, and service account name is AWS-load-balancer-controller, and region where our EKS cluster is there is US East 1. So we only need to change the VPC ID. So this one also we have verified. US East 1 is the region, and account ID also matched. So now let's come back here and go to VPC, and in VPC go to that respective EKS demo 1 related VPC. So VPCs, and I should have default, and another one is EKS CTL EKS demo 1 cluster VPC, and this is the VPC ID. So let me copy this, or let me go here and copy from here and provide the VPC ID. So now let's copy this command and run it, right? So let's come back here and clear and run the command now. And once the command successfully completes, so we are going to see the output as like this: name AWS load balancer controller, and last deployed, and in which namespace it is deployed, status is deployed, revision is 1, and test suite none, and what it has installed is AWS load balancer controller installed. So let's wait for it to complete. So we can see here our AWS load balancer controller is successfully installed. So in our next lecture we are going to go ahead and verify what it has installed in a step-by-step manner. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 0403, we are going to verify that our load balancer controller is installed and also its equivalent webhook service is also got created. So let's start with whether the controller is installed or not. So we'll say kubectl-n kubesystem and get the deployments in our EKS cluster, right? So in kubesystem namespace, so we'll say kubectl-n kubesystem and get, and we can say deploy. So what all deployments available in kubesystem namespace, it is going to list for us. So you can see AWS load balancer controller, which was created 2 minutes before, right? So now if you want to also see in detail, right, if you want to describe the deployment and review it, so we can describe it, right? So this is the name of the deployment, right? So copy and paste, and instead of get command we'll use the describe command here, right? So I'll say describe, and you should see that the entire information about this is going to be provided in detail. See, name of the deployment is AWS load balancer controller. In namespace kubesystem it was created, and these are some of the labels of it, and the version it has installed as on today latest is v2.3.1. so it has installed the 2.3.1 and it has done using, so labels are the very important thing. So how it has installed also you will know. So it is managed by Helm here, right? So instance name is AWS load balancer controller, and name also you can see AWS load balancer controller, and it is managed by Helm, and version also you are going to see 2.3.1, and Helm chart version you can see 1.3.3. this is the Helm chart version, and this is the EKS load balancer controller version is v2.3.1. so both are different. And now annotations, you can see deployment and meta Helm, some additional things whatever they have defined here, right? And another important thing you can see here is in the selector labels you can see app Kubernetes IO instance and also app Kubernetes IO name, and both have the AWS load balancer controller. So, and in addition to that, replicas, it has created 2 desired replicas, and strategy type, deployment strategy type it is using is rolling updates, and rolling update strategy also it is saying 25% max unavailable and 25% max surge. So, and this is the pod template, and if you see here, this is the very important point where you can see service account it is going to be associated with is AWS load balancer controller. And containers it has downloaded from the image repository whatever you have set, right? And ports it is using is 9443 and then 8080, right? And the cluster name is EKS demo1 whatever the arguments you have provided. Ingress class ALB, AWS region code is this one, AWS VPC ID is whatever you have provided. It also internally have the liveness probe whatever they have defined inside the package, and it has the volumes, and it has some certificate mounted to it whose name is AWS load balancer TLS. So this one just remember it. Why? Because if you see here AWS load balancer TLS, so that is what is mounted here. So this is the secret which is mounted as volumes here. Why? Because this respective load balancer controller listens on port 9443. So the communication to this load balancer controller is going to be on SSL, and it needs a TLS certificate associated with that, and that TLS certificate is associated here as volumes inside that using a secret, which means when you go and then verify that secret we'll find that one also. And you can see the events, normal, scaling, replica set, everything looks good. There is no errors or anything from events perspective. So this is about the deployment, right? And now we'll also verify the service here, which is webhook service. So kubectl-n kubesystem, and then instead of deployment, so I'll say clear, and instead of deploy, right? So we are going to say SVC. So we'll get the services in the kubesystem namespace, and you will see kubedns is one service, and AWS load balancer webhook service is one more service, and which is listening on port 443, right? And here you have seen the port 9443. So now we'll see the important things here. So this is 9443, and the selector labels inside this, right? The selector labels inside this is also you have seen here, right? The selector labels is instance AWS load balancer controller and name and AWS load balancer controller. So these are the selector match labels should be available inside the service labels, right? Service selector, so that traffic coming to this 443 port need to be sent to that 9443 port. Those also we need to verify for our additional understanding only. So whatever we are discussing is for our additional understanding and dissecting each of the objects and then seeing the internals of it. So let's come back here and see, verify labels in service and selector labels in deployment, right? So this is the webhook service which you are going to output using YAML, right? So what is this? So get SVC and load balancer webhook service with YAML, and inside this you go to selector and you see these two are the values inside the service selector, right? App Kubernetes IO instance and app Kubernetes IO name. And now verify the selector labels in our AWS load balancer controller deployment, right? And you'll find here also, come back here and you'll find the selector match labels, and you can see the same thing. Whatever you are seeing in selector match labels of the deployment, same you are seeing in the service here. So that very clearly tells us that whatever the traffic coming to the webhook service on 443, it is sending to our deployment, AWS load balancer controller deployment. But let's also verify this one more time on which ports it is sending, right? So that's also very important. See, so the port it is using is 443, which is the front end port for this respective cluster IP service is 443, and the target port it is sending is webhook server port. So this webhook server port is nothing but 9443 port. So let's come back here, right, and verify that, right? So these are the container ports, and in container ports you can see container port 9443 whose name is webhook server, right? And the other 8080 port for this load balancer controller is a metric server port. So this is very important. So for the webhook service is listening, the cluster IP service is listening on 443, and whatever the traffic comes to that webhook service, it is going to send to AWS load balancer controller pods, whatever for the deployment, whatever the pods created for those pods on port 9443, right? Means like this container AWS load balancer controller container is listening on 9443. So good. So this clears out one important thing, which is webhook service and also the AWS load balancer controller, how the communication is happening in between them also we got a complete picture. So in our next lecture we are going to verify additional logs and additional stuff. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, let's verify the load balancer controller logs. So we'll list the pods from the kube system namespace and we will verify the pods. So let's come back here and clear this and say kubectl and -n kube system namespace and get pods. And we have two pods running here related to load balancer controller, and those will be listed here. AWS load balancer controller 2 pods, and we can copy this pod name and say kubectl -n kube system and logs -f and provide the pod name here, and we can see the logs of that respective pod, and all seems to be shown as info, so which very clearly says that we don't have any issues. But if we have any issues or any errors it has been showing, so we can see in detail, right? So but currently it is only a info things which we really don't need to worry. And if we want to see for other pod also, so the same command applies for us, which is provide the kubectl -n kube system logs -f and the pod name, the second pod name. And now till here everything is completed related to load balancer controller, right? But for additional verification and then for additional understanding, step 0405 and 0406 are defined, and these are completely optional, and those who are highlighted with internals to understand more about it. So if you want to move on, skip this and then move on to next step or next video, you can move on. Or if you want to see about what is present internally, we can also see these things. So this is about AWS Load Balancer Controller Kubernetes Service Account internals. So this is the service account. So we will list that out in a YAML format. So let me clear this and let's wait for the service account to be displayed in YAML format. So API version is v1, kind is service account, and annotation, we know that our role ARN is outlined here, and this is managed by EKS CTL because we created this using EKS CTL IAM service account command, create IAM service account command. And now if you see here, name is AWS Load Balancer Controller, this service account name and namespace. Additionally, it has something called secrets. So API version, kind, metadata and secrets, right? So inside this secrets, you have something called AWS Load Balancer Controller token. So this is the important thing which we need to be worried about. So get secret and get the value from there, and then -o YAML. So I'll say kubectl -n kubesystem, right? And I'll say get secret, and this is the secret name. So we need to take it from here, copy, and we will provide -o YAML so that we'll get the secret in a YAML format, right? So let's run that, and you can see you have lot of information inside this secret. So secret, and you have the CSAT and also the token. So the token, what is this token? So that's the important thing here. So if you want, so you can use SSL checker cert decoder to decode the cert. First thing is we'll go to base64 decode, right? So we'll first deal with ca.cert, whatever is present inside this secret. So this is ca.cert and this is the value. So let me copy it and paste it here and then decode. So you got the certificate information here, and this certification information, so we will decode one more time using SSL checker cert decoder. So we'll go to that browser and take the base64 decoded value from here and go to this certificate decoder and decode it, right? And you'll find here, so this is issued on so and so date and expires on so and so date, and common name is Kubernetes and common name is Kubernetes. So this is a standard CSAT present inside this. So this is CN is equal to Kubernetes. So you can see the entire information here. So that is fine. So that is not the big thing here. So inside the secret, you have something called token. That is the important thing which we need to see. So first things first is we'll close these things, and one more time we'll open the base64 decoder, and also we'll open the jwt.io and put them aside and go back to our secret here, right? And inside secret, in the token, whatever is there in the token field, you are going to copy that value. So whenever you have outputted your secret in a YAML format, you got all this information, right? So you are taking this copy of this token and you are going to do a base64 decode and take that information, right? And go here and put it in the JWT encoded field, and then you'll get the decoding of that respective JWT token. So you can see here Kubernetes service account, namespace in kube system, and secret name is so and so, and all the information metadata about it. It is used by AWS Load Balancer Controller. So why I am showing this JWT, right? So this Load Balancer Controller, right, is creating this AWS application load balancer whenever the ingress manifest, right, here is deployed, and when the K8s API server gets that information, this load balancer controller watches for ingress events, takes that, and then creates this AWS load balancer controller. So but what is the authentication mechanism between this EKS cluster and AWS services? So if you want to call any AWS API, right, any AWS API, here this load balancer controller is going to call the application load balancer APIs and then create that, respective load balancer controller. To call that API, it needs to have the authentication mechanism, right? So that authentication mechanism, how it is defined in between these things, is this respective JWT token. So on a very high level, if you want to understand the APIs, the AWS service related APIs are like service APIs you can call, and the identity provider here is going to be your EKS cluster, which is added as identity providers in your IAM, right? So as part of 0102 section itself, so we have added that. So if you go here and let me go here, right, and go to the AWS EKS Kubernetes Masterclass and go to the section 01 and go to 0102 here. And if you see the step here, create and associate IAM OIDC provider for our EKS cluster, right? So let's understand that in a high level. We are not going super deep here, but let's try to understand in a high level that this respective EKS cluster is added as a identity provider for the IAM service here. See, so whatever we have done, whatever we have run this command, right, EKS utils associate IAM OIDC provider. So at that point of time, our EKS cluster is added here as a identity provider. So which means the identities present inside our EKS cluster will be able to access the AWS services based on the role assigned to the identity inside Kubernetes cluster. And inside Kubernetes cluster, the identity is nothing but the AWS load balancer controller service account. So if you come back here, so the identity inside the EKS cluster is AWS load balancer controller service account, and this is annotated with the IAM role here, which has the permissions defined in this IAM policy. Based on those IAM policies, this service account, whatever is created, this load balancer controller will use, and whatever the token generated, right, using the token, it can authenticate against the services whatever is allowed as part of this IAM policy, and then create, update and delete those application load balancers. So this much linking is present inside this internally. So we can go still deep and then see how this IAM OIDC provider related pictures and all those things, but for now it becomes super advanced and then we get confused with what we are going to learn about the ingress. But I just want to ensure that in the internals of these things, so how this AWS load balancer controller deployment related pods is able to create this AWS application load balancer. Without any authentication, it's not possible, right? So it need to have some authentication mechanism. So that authentication mechanism is nothing but here whatever the token you are seeing. So using this token, it will be able to authenticate to those respective APIs and then create the application load balancer for us. So now let's come back here, and where are we? So this is the one, right? So we have seen these things, and if you see in the deployment also we have seen the service account, and in pods also we will find the service account, right? So if you go there and you'll find something called in the volumes also, you'll find the AWS IAM token. All these things you can see in detail if you run this command, right? So if you say kubectl get pods, already for the deployment you have seen the service account name AWS load balancer controller. But for the load balancer controller pod spec, if you review, you will understand more and more here. So we can take these things and say kube system, and this is the pod name we want, right? So copy, and this is the pod name, right? So copy this pod name and -o YAML, and then you'll get the complete pod specification here, and inside that spec.volumes.name. So if you go and then verify the volumes here, right, in the you will find something called this respective pod spec volumes. So you are going to find this one, service account token, audience is sts amazon aws.com, and if the path is going to be token, and it is going to be the name of the token is going to be AWS IAM token. So let's find those things. So we'll copy this to our something like our any of the file here and then search it. So let me copy and come back to the Visual Studio Code here, remove these things, and now remove the first line here, whatever we have added, and come down and remove the last line, Kalyan MacBook Pro, and search for AWS-IAM-token, right? And you will find inside the pods, pod spec volumes, AWS IAM token, and which is using the token here, and this path is token. So now let's search for those things. So you can see in the volume mounts, you will find the mount path AWS IAM token, and in our EC2 instances, in where run secrets, in so and so location, in service account, you will find this IAM token. And in addition to that, we'll also find token here, token, and we need to find here AWS. This is the environment file, web identity token file, and in service account, this is the path, token path here, value, right? So this path we are picking here in detail. So let's come back here. So spec volume name, we have verified this, and we'll go to volume mounts, and we have verified this, and in web identity token also you have find. So all these things, if we put them together, you will understand how the values are mounted to your pod inside load balancer controller, so that the application present inside that load balancer controller, which is load balancer controller application, is able to authenticate against AWS APIs. We can understand in detail, but these are only for our internals understanding how things are mounted and all those things. So in addition to that, you have something called verify TLS certs for AWS load balancer controller. So these are the TLS certs which we have seen earlier. So whatever this token, whatever you have seen, is directly related to your load balancer controller, right? So which means, like, for your load balancer controller related service account, the secret mounted to it, that one we have seen as part of step 0405, right? But when you go to step 0406, you will find something called verify TLS certs for AWS load balancer controller. So this is the one we are discussing now, AWS load balancer TLS. So this is the secret. So we have the 9443 port, which is a SSL port running here. So for that, the certificates you are going to take from this AWS load balancer TLS secrets. So you can go here and then get the output of this kubectl-n kube system, get that secret, which is AWS load balancer TLS, and you will find the TLS key and then TLS certificate. So we'll take the certificate and then decode it and then understand in detail. So let me copy it here and go here and remove this and paste it here and then decode. So no, let me remove this. I'll just say base64 decode. Let me close these things, and this is the certificate, and I'll say decode, and you got the certificate here, copy, and I'll say SSL checker cert decoder and decode this certificate, and you will find something here. The common name of this certificate is AWS load balancer controller. So the webhook service, right, is listening on 443, and load balancer controller is listening on 9443, and these needs these certificates, right? And the SAN certificate names for these things: AWS load balancer webhook service.kubesystem and AWS load balancer webhook service.kubesystem.svc. So these are the additional SAN names available for this respective certificate. So that's it. So this is another additional information which we need to understand about port 443 and then port 9443 for service and pods for the AWS load balancer controller. So if we open it and then see it in detail, if you want to go to that load balancer controller pod and go to the volume mounts and verify the mount path for serving certs there, and also verify the volumes, you will get the additional understanding about those pods. We really don't need to worry or go in this deep for this respective things, but for additional understanding, it is always good to know more, right? So that's the reason this 0405 is always optional for you, but I have put them for additional understanding. So I'll see you in the next lecture. Until then, bye bye. Thank you. So before going to next lecture, so this is step 0407, which will help us in uninstalling the AWS load balancer controller. Helm uninstall AWS load balancer controller from namespace kube system. So this is optional, we are not going to use it, but just for additional reference I have put it here. So I'll see you in the next lecture and discuss about the ingress class concept. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. Step 0407, uninstall AWS load balancer controller using Helm command. So this command is put here for information purpose only. So we should not execute this command. So this command will uninstall the load balancer controller whatever you have installed as part of previous step. So this is just to know that how to uninstall our load balancer controller using Helm uninstall command. So for that purpose, for information purpose only, this step is put here. Welcome back. As part of step 05, we are going to understand about the ingress class concept in ingress controllers. So if we go back to our PowerPoint presentation here, and let's understand the problem scenario here and where the ingress class comes into the picture. So if we have multiple ingress controllers running in our Kubernetes cluster, how to identify to which ingress controller our ingress resource or service should be associated to. So if you take your Kubernetes cluster, you have EKS ALB related load balancer ingress controller installed on your Kubernetes cluster, and also you are running the Nginx ingress controller, and you are also running the AKS application gateway ingress controller. So assume like this, multiple ingress controllers are running in our Kubernetes cluster, and you have deployed your ingress resource using kubectl, right, or ingress service, and that ingress service should be associated to which ingress controller. So that there comes the concept called Kubernetes object type or Kubernetes object of kind ingress class. And not only these three ingress controllers, so if you see here, there are many ingress controllers available in the market as on today from Kubernetes perspective. So to identify and associate your respective Kubernetes ingress service to a ingress controller, we use the concept called ingress class. So this is the high level definition of the ingress class we are going to define, so that it is going to associate it to our ALB ingress controller. So if you see here, standard Kubernetes YAML manifest format, API version, kind, metadata, and then spec. And API version for ingresses, we are going to use networking.k8s.io/v1. So earlier in the ALB 1.1 version, we are using a different version which is not supported in the latest Kubernetes versions. And now the supported version is going to be this one, the API version, networking.k8s.io/v1. In fact, this is the reason why we are redoing this entire use case here. In addition to also the new version of AWS load balancer controller also introduced. And you can see here, the kind is ingress class, and metadata, we have the name and annotations, and in name we have provided the name as my AWS ingress class, and annotations will come back to it later. And in the spec, this is the important part, you have the controller and you are defining the controller as ingress.k8s.aws/alb. So here use this ingress class, right? So whatever the ingress class you are deploying, so this is tied to your controller, which is nothing but your AWS ALB ingress controller. And whenever in the ingress service you use this name, ingress class name, whatever it is, my AWS ingress class, so which means that ingress service will be associated to this respective controller, which is AWS ALB ingress controller. So now let's come back to this annotation, ingress class.kubernetes.io/is default class and then true. So what exactly this does? So let's see in the next slide about that. So you have a ingress class, right? And you have a ingress resource. So we are going to do a ingress resource by live template writing in upcoming sections, but this is just to understand. Ingress resource is nothing but it's like you are going to create the application load balancer using the Kubernetes manifest. So on a high level, I will explain it here, and in upcoming sections, in the next section, which is Ingress Basics, we are going to do the live template writing for this respective resource. Here the point we are trying to understand is about the is default class equal to true or not. So this is the API version networking k8s.io/v1 and kind is ingress. So you can see here this is the ingress class and this is the ingress, and metadata and name you can see ingress nginx app1. So this is the ingress service you are going to create, and we'll leave the labels, it's a standard one. So we'll go to annotations, and you can see here ALB ingress kubernetes.io, and load balancer name you are giving app1 ingress, and also scheme you are saying that this ingress service should be created at the internet facing. So which means this creates the application load balancer in AWS as a internet facing load balancer. So here comes the API version, kind, metadata, and then spec. In spec, before going to this ingress class name, also review this default backend. So this default backend has a service and whose name is app1 nginx node port service, and this node port service will be with listening on port 80. So which means this application load balancer will have a default backend which will send the traffic to the Kubernetes service of type node port, and inside this node port you will have a selector labels which will be pointing to your deployment, Kubernetes deployment, where you will have the app1 nginx deployment. The functioning of ingress service or resource is not the core concept here. Important thing here is, so let's understand this. So you see the name of your ingress class is my AWS ingress class, and inside this ingress resource you are saying the ingress class name is my AWS ingress class. So if ingress class is not defined as is default class equal to true, then in ingress resource, right, we need to define the spec.ingress class name, whatever you want to specify, so that this resource will be directly associated with the ingress controller, which is nothing but AWS ALB ingress controller. So now here comes the point. So if we enable these two lines, annotations, and then say this as the default ingress, right? So which means you are saying AWS ALB controller as the default ingress in your Kubernetes cluster. So at that point of time, this value, which is ingress class name, whatever you are defining here, you really don't need to define, you can comment it. So how many number of ingress resources or services you are going to deploy, all will be associated with the ingress controller, which is defined as the default in your Kubernetes cluster. So this completes the high level introduction about ingress class, and in our next lecture we are going to practically implement this. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 06, we are going to review the ingress class Kubernetes manifest, which is present in 0801 load balancer controller install, and inside that you have the kube manifest folder, and inside that you have the 01 ingress class resource.yaml. So let's go to our Visual Studio Code here and go to 08 new ELB application load balancers, and inside that 0801 load balancer controller install, and inside that you'll find something called kube manifest folder, and there you will find the 01 ingress class resource.yaml. And we already discussed about this in the presentation also, API version, kind, metadata, and then spec. And here the API version is going to be networking.k8s.io/v1, and kind is ingress class, and name of my ingress class is my AWS ingress class, and in spec you will have something called controller, and you will define your controller name as, or you will define the controller, this respective ingress class you are going to tie with is the AWS ALB ingress controller, which is nothing but our AWS load balancer controller, you can say. And you also define the annotation ingress class.kubernetes.io/is default class true, so that any ingress services deployed inside this Kubernetes cluster will be associated with the AWS load balancer controller, whatever you have installed in the previous steps. So that's another important thing to know. So now let's come back here and deploy this ingress resource. So we'll say kubectl apply hyphen kube manifest, so that anything present inside this kube manifest folder will be deployed. So let's come back to our terminal here. We are in 0801 load balancer controller install, and we'll say kubectl apply -f and kube manifest / and this should create the ingress class for us. So let's wait for the ingress class to get created. So we can see ingress class got created with name my AWS ingress class. So now we are going to get the ingress class and also describe the ingress class. So kubectl get ingress class, and we should see that my AWS ingress class got created successfully here 16 seconds before. And we'll also say describe ingress class, and its name is my AWS ingress class. Kubectl describe ingress class and my AWS ingress class, and you can see name and annotation whatever you have specified, and controller whatever it has, and events as a nothing here. So this completes the creation of or installation of or setup of AWS load balancer controller on EKS cluster, and also creating the ingress class for and making it as the default ingress class, a default ingress controller for our Kubernetes using the ingress class concept. So I'll see you in the next lecture or in the next section with ingress basics. Until then, bye bye. Thank you. Welcome back. As part of this section, we are going to learn about Kubernetes ingress basics. The first thing we need to know about ingress is what all key items involved inside the ingress service manifest, right? So the one important thing is ingress annotations. Ingress annotations are nothing but the load balancer settings which we are going to provision using this ingress service. And another important thing is inside the ingress spec, the first item which we need to define is ingress class name to which this ingress service need to be associated to or belongs to. By default, if you already created a ingress class and said that is default equal to true, so then we really don't need to define ingress class name inside our ingress service manifest. If not, we need to definitely define this. And in ingress spec, additionally you can define ingress routing rules and also default backends. So all these things we are going to practically implement and then see in various scenarios from ingress perspective. Additionally, there will be an annotation reference, and there will be close to 30 plus ingress annotations as on today available for our Kubernetes AWS load balancer related ingress. So these are the settings here. So ALB ingress Kubernetes IO load balancer name, group name, tags, IP address, and then your load balancer type, which is nothing but scheme, internal load balancer or internet facing load balancer, and where your load balancer need to be deployed to, means like which subnets. And if you want to specifically associate instead of default security groups any additional security groups, so you can use this and then provide the security group ID. So like this, there will be huge amount of annotations available for us which can be defined as settings for your load balancer inside the Kubernetes service manifest. So now let's come back here, and we discussed the key items involved here and also reviewed on a very high level what all annotations we are going to have. And for complete 30 annotations, if you want to review, so review this reference link and you'll get the complete picture on what all these are and why they will be used for. And let's come back here, and we are going to do two demos as part of this section. One is ingress service with a default backend, and the other is ingress service with ingress rules, so that we get the complete hand on how to define the default backend and also how to define a simple ingress rules. So that's the reason we have split it into two demos, so that we get the complete clarity on understanding and implementing those two use cases. And let's understand the network design for the default backend. So in AWS cloud, we have created the EKS cluster, and which as part of that, when we have created this EKS cluster using EKS CTL, so it also created a VPC and also created a public and private subnets and also a NAT gateway, and from private subnet the outbound communication goes via NAT gateway to our EKS cluster control plane. And additionally, if you see here, we have also created a EKS worker nodes. We have created 2 worker nodes in the private subnets. We call it as a private node group, and we deployed our simple application Nginx app1 deployment in our private node group, and which will create the pods for us. And now this respective deployment will be fronted with a Nginx app1 node port service, and this node port service, right, will be associated to the ingress resource, right? So you will deploy a ingress resource, and inside the ingress resource default backend you are going to associate this node port service. And whenever user accesses your DNS URL, ALB DNS URL /app1/index.html, and it is going to get the request to this application load balancer, and inside the default backend you have the reference to your node port service which is in your Kubernetes cluster, and from there it will go to your respective pod. And if you see here, you can see in the ingress spec, from spec only I have copied here, and ingress class name you have defined whatever the ingress class you have defined, that my AWS ingress class. So which means this respective ingress service whatever you are going to deploy is going to be associated to your ingress controller, which is AWS ALB ingress controller. And you can see we have defined the default backend and service, and the name of the service is app1 Nginx node port service. So which means the request coming to this ingress service or this application load balancer goes to the default backend, which is nothing but this node port service, and from there request will be routed to the application pod. And now this is with the default backend. Now let's see with the ingress rules. So whenever you define the ingress rules, so it is going to look like this. So earlier you have seen the default backend. Here you will, in the spec you will find something called rules, and in HTTP and in paths, and in path you said slash. Anything with slash go to app1 Nginx and node port service, which means anything with slash star, anything under the root context, it will go to the Nginx node port service, and this node port service will forward it to the your Nginx app1. So this is what is the high level thing which we are going to implement with our 2 demos. And in addition to that, we also need to understand something called how AWS load balancer controller works on a high level, right? So this is the picture. I have brought it from this reference link available for us, and we are going to discuss about this and understand multiple things here. So if you see here, these are the AWS resources, and here you can see this is the Kubernetes cluster, and this is the Kubernetes API server, and you already deployed your ALB ingress controller, and you see you have the Kubernetes API server, and also you can see the worker nodes here. You have 3 nodes here, and if you see here we have 3 apps A, B, C. You can see here, right? So we have pod A, pod A, pod A, pod B, pod B, pod B, and pod C, pod C. So each application has 3 pods here. Pod C related third pod is not depicted here, but let's consider you have 3 worker nodes and 3 pods per app here. And now these 3 pods has a ALB context path based routing implemented, which means this pod A, right? So pod A, whenever you have the /* root context, then the request will go to pod A, and when you have the /products, request will go to pod B, and when you have /accounts, whenever in your URL, right? So abc.com/accounts, the request will go to pod C, which is nothing but your application C. So that's about the application which is implemented or deployed here. So let's assume that way. Now let's go to the next level, which is node port service here, right? So for every application you will have its own node port service, right? So pod A you have the node port service, pod B you have the node port service. In same way, for pod C, you don't have the node port service. So we'll discuss this later. But for now, so for pod A, this is the node port service, and whenever the request comes to /star, so it will go to that respective target group in the load balancer, application load balancer, and from there it will go to the node port service A, and it will serve to the pod A related, means like it will get the content from pod A and display to the user. And same way for /products, you have the target group service B, which goes to your node port service B, and from pod B the request will be served to the user, right? Now these two, whatever you are seeing, the pod A and then pod B is using, means like these applications are using the traffic mode instance type. So which means the traffic mode instance type is nothing but you are going to use the node port service, which means these nodes are registered to your target group in the load balancer, and those nodes related node port service will be used to send the traffic to your pod. But when coming to traffic mode IP, right, so which is the third application, which is application C, where the rule is /accounts. So here directly in this target group, this pod related IP is present. So when you go to your load balancer and verify for this target group, which is pod A, pod B, you will find that your nodes are registered there. But here you will find directly the pod IP is associated with it. And this target group C, right, which is mode of type IP, traffic mode of type IP, is primarily used for Fargate related workloads. On a high level, we need to understand about that. Now, so let's understand this. You have deployed 3 applications and 3 deployments, and those related pods created, and 3 node port services created. And here comes the important thing. Whenever you deploy the ingress service, so this ingress controller will check for the API server, any ingress services were deployed for me, and if deployed, it will take and then it will check for the API server and then deploy that ingress service for us. And that ingress service will create a application load balancer with listener type as HTTP or HTTPS, and also create all these rules for us, and also create the target groups for us. So that's about the high level about how all this going to work. We are going to see this traffic mode IP implementation in detail during the Fargate demos also, and in these ingress demos we are going to anyway see the objects like target groups, how the node ports are registered there, and all those things in detail in a practical implementation. So there we get the clarity about this picture in detail. So not only in this basic demo, but we'll have the context path based demo and also host header based demo. At every point we are going to discuss about this traffic mode instance and then IP. So we don't need to worry about that. We have only seen the picture, we didn't see the real implementation. So we are going to see in each and every demo, and we'll understand there in detail. So I'll see you in the next lecture. Until then, bye bye. Welcome back. Let's go back to our GitHub repository, and we are in 0802 ALB ingress basics. And as part of step 1, we already understood about what we are going to implement as part of this section. So now we are in step 2, where we are going to review the app1 deployment Kubernetes manifest. So we need to go to 01kube manifest default backend folder. So if we go back to our Visual Studio Code here in 0802 and in ALB ingress basics, so you will have the demo 1, which is 01kube manifest default backend, and you will have the demo 2, which is 02kube manifest rules. So if we go inside this, we'll find something called 01 nginx app1 deployment and then node port service. So this is our standard deployment and node port service. So we will review on a high level and then move on to the next step. So if you see here, API version is apps v1 and kind is deployment, and metadata is app1 nginx deployment, right? And in the spec you have replicas. We are going to create one pod, and in selector match labels you have provided the label as app equal to app1 nginx. The same we are going to use in our node port service. We'll see that later. And in template, you have the metadata label app1 nginx, and in deployment spec, and inside that template, and in template you will have the pod specification, and you have the containers, and inside that containers, the first container you have defined inside this pod is app1 nginx, and you are bringing the container from stack simplify / cube nginx app1 1.0.0. and ports, we are going to use the container port as 80. So this is the deployment manifest, and here is the node port service. And in node port service, you can see API version is v1 and kind is service, and in metadata you will find app1 nginx node port service is the name of this service. And in spec, right, so let's ignore these labels and annotations for now. So let's come back to the service spec, and you are saying that service type as node port, and selector label you can see app1 nginx, the same whatever you have seen in the selector match labels of your deployment. So which means any traffic coming to this app1 nginx node port service will be sent to the pods with this app1 nginx match labels related pods, right? So which means it will send to this pods created by this respective deployment. So now let's come back here and see the ports. The service port is port 80, and the target port, which is nothing but your port of your pod, is also port 80, or you can say the container port is 80. So now let's come back, and we have successfully reviewed our nginx app1 deployment and node port service. In our next lecture, we are going to go ahead and then do a live template writing for our ALB ingress, right, manifest, which is 02 ALB ingress basic.yaml. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 4, we are going to review or do a live template writing for our ingress cube manifest with default backend option. So we need to go into the file 01 default backend folder, and inside that 02 ALB ingress basic.yaml. So let's go back here to our Visual Studio Code, and we are in 0802 ALB ingress basics, and inside that the folder is 01 cube manifest default backend, and 01 nginx app1 deployment and node port service related Kubernetes manifest code we already reviewed in the previous lecture. So now we will enter into 02 ALB ingress basic.yaml. So the standard template here, API version, kind, metadata, and then spec. So for latest ingress, right, so for the latest ingress resources, so we need to use the API version as networking.k8s.io/v1, and the kind, whatever the kind Kubernetes object we are going to create here is ingress, and in the metadata we are going to provide the name of my ingress service, and my ingress service name is ingress-nginx app1, and I am also going to define a labels here, and I am going to say it as app equal to app1 nginx. So this is purely optional. We really don't need to even define the label for my service here. So now let's come back here, and in the metadata itself we will have something called annotations. If we go back to our presentation here, so in the ingress manifest the key items are ingress annotations, and in ingress spec ingress class name definition, and in ingress spec defining either ingress routing rules or default backend. So now we are at this point where we are defining the load balancer settings, which is nothing but defining the ingress annotations. So I will say annotations, and we'll start with the first annotation. So let's go back here and go to the annotations documentation, and you will find something called ALB ingress load balancer name. So we'll provide the load balancer name here, and if you want to understand more about it, so open it in the new tab and you'll go there exactly. Specify the custom name to use for the load balancer name. So name longer than 32 characters will be treated as an error. So once defined on a single ingress, it impacts every ingress within the ingress group. So the ingress group is a different concept which we will see in upcoming sections, but for now we are going to just define a simple name for our load balancer, right? So let's come back here and define it as app1 ingress, right? So this is the first setting of my annotations related to my load balancer. And another important thing is ingress core setting. We call this as the ingress core setting because so this ingress service should be a internal ingress service or a external ingress service, which means this should be private load balancer or public load balancer. So that setting can be defined using something called, in annotation you will find the scheme here, right? So go to the scheme here and specifies whether your load balancer will be internet facing or internal, right? So let me copy this and define the scheme here, and it is going to be internet facing. So I'll say internet facing. You can also search for internet facing. See, ALB ingress Kubernetes IO scheme internal or internet facing. So INTERNET, internet facing. So this is good. And there will be one more annotation which we need to discuss in detail, but first we'll define the health check settings. So we have defined the load balancer name, scheme, and we can also define the health check settings for our application load balancer here. So let's go here and go to the health check here, and you'll find the health check setting related all annotations here. The first one is protocol, health check protocol you want to use, and I'll put it as HTTP protocol I am using. I can say this as health check setting, and this I can say as ingress core setting, and this one I can say as load balancer name, right? And the first setting for health check is completed, and next one we are going to define is traffic port, right? Set the on which port it need to do the health check. It is going to be traffic port. And another setting is health check path, right? And my health check path is going to be, so let me put this here, and is going to be app1/index.html, where my application related files are present, right? Index.html of my Nginx is present in the app1 folder, so I'll use that. And next one, right? So let me enter and let me come back here, and next one is going to be health check interval seconds, and I can give that as 15 seconds, and let me put that. And I'll also provide the health check timeout, right? I can provide that as something around 5 and in seconds. And we can also provide the success codes and then healthy thresholds and all those things. So we can provide a single value or we can provide multi-value, right? 200, 201, 200 to 300, like this we can provide those things. And I'll also provide the threshold count, and also I'll provide the unhealthy threshold count. So this completes the health check setting definitions for my respective ingress resource. I have defined the load balancer name and where this load balancer should be placed, internal or internet facing, and also health check settings here. So now let's come back here and review one more thing here, right? So this is the app1 index.html. So this ingress is nothing but a combination of multiple applications you can send that traffic to. That's the core definition, right? So which means an application load balancer created for doing or using a single load balancer, you can send traffic to multiple applications with different schemes, like using context path based or host header based and all those things. In cases like now you have only one application here, so that's the reason you can define this as a global app1 index.html. But in this ingress you are using the context path based routing, how we have discussed about accounts, products and root context, and at that point of time in each application there might not be a /app1 and then index.html related things available for health check. So at that point of time we need to move these things, this respective thing, right, directly to your node port service, so that becomes a service level one. See, so now if you see here, need to add health check path annotation in service level if you are planning to use multiple targets in a load balancer. Multiple targets are nothing but you are using multiple rules to define and then add multiple things here. Means like you are sending the traffic from a single ingress service to multiple applications. At that point of time you move your health check path of your respective thing from global ingress setting to your service level, node port service level thing, you need to move there. So now let's come back here and then come back to the spec. So we have completed the annotations part here, and now we need to define the ingress class name. So let's define the ingress class name here. And I'll say ingress class name, and in ingress class name we are going to get the ingress class name from our 0801 cube manifest and get this value from here. So let's come back and provide this. And the next thing is we also need to provide the default backend here, and in default backend we need to provide the service information, and in service the name of the service we need to provide, and name of the service we can get from our 01 nginx, and here is the name of the node port service we need to define here, right? And we also need to define the port, and we'll say the number as 80. So this completes the definition of your ingress service. And another important thing to discuss here is, so let's come back here and go to the ingress class documentation, and you'll discuss about a deprecated annotation, one important annotation. So you can say ALB, or I can say Kubernetes.io / ingress.class. So this is the earlier annotation which we used to use, and it is widely implemented across all the ingress resources or ingress controllers. So let's come back here. See, deprecated Kubernetes.io ingress.class annotation. So before the ingress class resource and ingress class name field were added in Kubernetes 1.18, so ingress classes were specified with this name, right? So the newer is ingress class name field, whatever we have added here, right? So let's come back here, and this is the one. So already you have defined it as a default controller, means like your ingress AWS ALB controller, you have defined it as a default controller with this respective setting. So which means you really don't need to even define this also. Why? Because you already have a default controller which is ingress controller in your Kubernetes cluster, and then you don't need to specify the ingress class name here. But just for notation and to understand for us, I have defined it here, and let's come back here. So the newer ingress class name field on ingresses is a replacement for that respective annotation, which is kubernetes.io / ingress.class, but is not a direct equivalent. While the annotation was generally used to reference the name of ingress controllers that should implement the ingress, the field is a reference to an ingress class resource that contains additional ingress configurations, including the name of the ingress controller. In simple terms, in very, very simple terms, so this is now a optional thing whether we want to use it or not. So if we use it or if you don't use it, there is no harm for us as on today. But why do we need to use a deprecated annotation in our latest ingress manifest? So that's the reason I didn't define any ingress class, right, in kubernetes.io / ingress.class here, right? We are directly using the ingress class name and referencing to the ingress class whatever we have created in our load balancer install related section. So this completes the review and our live template writing of our Ingress resource with the default backend. So in our next lecture, we are going to deploy this and then test it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In previous step, we have successfully created the Ingress manifest with the default backend option. So now we are going to go ahead and then deploy that and then test it. So let's go back to our terminal here and go to 08 new and 0801 and not 01. So we'll go to 0802 and inside 0802 ALB Ingress basics. So we'll run the command kubectl apply -f and 01 kube manifest default backend. So this should create the Nginx deployment for us, and also it should create the node port service, and also it should create the Ingress service for us. So now we can see all three things were created: deployment, service, and then Ingress. So let's go ahead and then verify the deployment and pods first, and then we will move on to the Ingress. So I'll clear kubectl get Ingress. Why I came to Ingress? So we'll first do the deployment, right? Verify the kubectl get deploy. So all these things are created in the default namespace. That's the reason we really don't need to mention -n kube system or -n default namespace. So both are same. So you can say default and it should be the same thing. So you can see app1 Nginx deployment is ready, one by one is ready. So we'll say get pods, and we should see that app1 Nginx deployment and that respective pod got created successfully, and then it is running. So now we'll also see kubectl get svc, and then it will list the app1 Nginx node port service for us, right? You can see 80:32291 is the node port service, node port of our respective service. So now the next thing here is we need to say kubectl get Ingress. So this should list the Ingress service for us, whatever we have created, which is Ingress Nginx app1, and this belongs to the class my AWS Ingress class, and here is the address app1 Ingress. This is the name of my load balancer, whatever we have provided here. See, app1 Ingress hyphen some dynamic id dot us east1 dot elb dot amazon aws.com, right? So now let's come back here to our load balancers. So in EC2, right? So go to services, and in EC2, so let's go to load balancers, and in load balancers, so you should find that app1 Ingress. The name of my load balancer is app1 Ingress, and its DNS name is app1 Ingress hyphen so and so so and so, and its state is currently active. And you can see in the description lot of information about that load balancer. So the listeners, it has created the HTTP 80 listener by default, and also if you see inside it, right, so it should have the default backend. So this is the default backend, requests otherwise not routed. So it is added as a default backend, and it is going to some target group here. So we'll go and then verify the target group now. So let's come back here and go to target groups here, right? And in target groups, you will find here K8s default app1 Nginx. So this is something the older one. So I'll just remove this. So this is unassociated one, user management one. See, none associated. I'll just delete it. So this is coming from previous demos. So I'll remove that. And now if you see here, K8s default app1 Nginx is there, and its port 32291. This is the node port. So let's come back here and verify the same thing. See, in kubectl get svc, your app1 Nginx node port is 32291. Same is also added here, which means your node port service, your node is registered here with that respective port. So and protocol is HTTP, and target type is instance. So if you remember, we have discussed about the traffic mode, right, which is nothing but instance and then IP traffic modes. So here by default, right? So by default, if you don't define any traffic mode, so then the target type is going to be instance. And if you define it, you can define the target type as instance or IP. So let's go to annotations here, and I'll say IP, or I can search for target type. Yeah, you can see here ALB ingress Kubernetes IO target -type instance or IP. And if you see here, instance mode will route traffic to all EC2 instances within the cluster on node port opened for your service, right? So service must be of type node port or load balancer to use the instance mode. And IP mode will route traffic directly to that respective pod IP. And another important thing to note here is, so let's go to that target type. And then come here, and you see at the top, right? So this is the default. So what is the default for that is instance. So which means by default, whether you define this target -type as instance or not, by default it will take the instance, and explicitly you need to define for IP if you want to need IP, right? So that's about the target type. So now let's go inside that, right? And see, this is the target type instance and protocol version, all these things are good, and this is associated to the load balancer app1 ingress, that is good. And total targets, 2 targets and healthy, right? So you can see both instances registered successfully here. So we have 2 nodes, and then both nodes registered successfully here. Irrespective of whether that pod is present in which node, it doesn't need that, right? Why? Because your node port service is spanned across all the nodes. So that means whether you have the pod in which node is not a consideration here. So if in your private node group in Kubernetes, if you have 50 nodes, all 50 nodes will be added here. So that's about the instance mode, traffic instance mode related thing. We can also see here the health status is healthy, and we can also go inside the monitoring and go to health checks and review the settings. So protocol you have provided HTTP, and path you have provided as /app1index.html, and traffic port you have provided, and all these things. Interval, if you remember, we have provided the 15 seconds. See, 15 seconds. So all those things, whatever we have provided in the annotations for the health check settings, so all these things are available here. So now let's go back here and also go back to our GitHub. Here, describe ingress controller. So just review and understand more about it. So let's copy here and go here. kubectl describe ingress, and ingress name is ingress-nginx app1. And if you see here, right, in the ingress, name, namespace, address, and in the default backend, you see default backend is the value it is provided here, which means in host there is no paths, only the default backend related information is provided here. So just make a note of these things, and then go ahead and then review these things in the next demo, how it comes. Why? Because in the next demo you will use the rules, and there it will say /* go to this. So like that you are going to see. So currently you have the default backend here, but in the next demo we are going to see this differently. So for that purpose only I am showing the differences, which means whatever the rules you have defined in the ingress, so those things using the kubectl describe ingress command, you can review them directly here, whether they were successfully created in a right way or not. In the annotations also you can see in detail, and also you can see there are no error events here, successfully reconciled. So now let's come back, and we have also verified the target groups and all those things. So now let's go ahead and then access the things. So let's come back here and say kubectl get ingress, and you will get the name. This is the address. This is same as the DNS name of your load balancer. So let's come back here and go to the load balancers, and in the description section search for whatever you have copied here. Both are same. So you can give this, and the root context page is Nginx default one should be displayed, and our core page which we need to test is app1/index.html, and here you will see welcome to Stack Simplify related page, application name app1, right? So this completes the demonstration of Ingress using the default backend. So if you want to review the logs of your respective pod, or if you want to review the logs of your load balancer controller also, you can review all those things. So now we'll go ahead and clean up whatever we have created, and if you want we can also review once the kubectl get pods -n kube system, and if by any chance if your ingress is not working at that point of time, it is always good to go to that respective load balancer controller pods and also verify. So I'll say kube system and logs -f. Mine is working, so we really don't need to go here, but I'm just trying to show you, right? And see in both the pods if you are seeing any errors or anything, right? So here there is nothing related to that, all are info only, just for our additional things. So now let me clear this, and I'll say kubectl delete -f and 01, which is kube manifest default backend, so that we are removing the deployment service and ingress service whatever we have created, right? So now this should also delete the load balancer whatever we have created here. So let's come here and refresh, right? See the load balancer whatever app1 ingress we have created is gone now. So let me close these things, and your deployment and service also cleaned up. So if I say kubectl get all from default namespace, only the default Kubernetes service and also the whatever the ingress class we have created, those should be displayed. See service Kubernetes default cluster IP service for our Kubernetes is displayed here, so nothing is present here. Or you can say get pods or get svc or get ingress, everything is cleaned up whatever we have created. So in our next lecture we are going to focus on demo 2, where we are going to define the routing rules. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 7, we are going to define the ingress manifest with ingress rules. So before going there, we need to understand ingress path types in detail. So if we go here, we have 3 types of path types available for us from ingress perspective. So one is implementation specific, and second is exact path type match, and the third one is prefix match. So implementation specific path type is nothing but for that respective controller. So with this path type, matching is up to the controller implementing the ingress class. So example, we are using the AWS ALB related ingress controller, and in this implementation if we have any specific path types defined related to AWS, so we can use with implementation specific, and by default it is going to be implementation specific if we don't define the path type argument in our respective rules. So implementation can treat this as a separate path type or treat it identically to either prefix or even the exact path types. And exact is nothing but it need to match exact URL path with case sensitivity, and prefix is nothing but matches based on a URL path, prefix split by /. Matching is case sensitive and done on a path element by element basis. So if we take the examples, we'll get the clarity on prefix and then exact. And implementation specific will be by default, but as we said here, so it might consider it as either prefix or exact based on the implementation that controller is implemented. So we are going to use prefix. Why? Because which is loosely coupled and easily we can use it. So let's take the examples here and understand more about it, the differences between the prefix and the exact, and then how it is going to work. So example, in prefix, right, you have defined in your Kubernetes manifest, right, as /. So in the request path, whenever you are accessing via browser, all paths are allowed. That's the reason it says matches yes, which means this is true. It works. So whenever you define slash with path type as prefix, all paths are allowed. And the next thing is exact. So whenever you provide the path type as exact, so before going and implementing these things, so let's see this here, right? So in the rules, HTTP paths, you can see path, whatever the path you define, and the path type is prefix or exact. So like this you are going to define the stuff. So let me copy this, right, and come back to our ingress manifest, right? So where is it? In 0-to-cube manifest rules, and in ALB ingress basic, so API version, kind, metadata, annotation, all are same as previous ingress manifest, right, till spec and ingress class name. So only thing now we are defining here is rules. Under rules we are defining the HTTP rules, and under that you have the paths, and the path we are going to use is a root, right, which means all paths should be allowed, and path type is prefix. And backend, in backend the service name we need to provide is, so we'll go to here, and this is same as again 0101, which is Nginx App 1 deployment and node port service. It is absolutely same. So I'll bring that from there and come back here and provide the name here, and number is 80, right? So once we have defined this, so now let's go back here and understand more about these things. So you said slash so that all paths are allowed, so which means whenever you access with slash app1 slash index.html, it is going to work for us without any issue. So now let's come back here, and if you provide the, if you define here in the path, right, slash foo, right, and if you access it with slash foo from your browser, right, so http:// some stack simplify.com/foo, and you also defined here the foo, so then it is going to work. And when you define it as exact, right, in the same way whenever you define it as exact, and when you access it when you define it as foo, and when you access it as bar, and it is going to fail. So that's the thing. So like this we need to understand, this is the request path, which is nothing but from the browser whatever you are accessing, and this is like whatever you are defining here, and the kind is nothing but the path type you are defining. So for us, I'll roll back this one to this one, and I will remove this. Okay, and now let's see, same thing for exact slash foo, and then you will access with adding the trailing slash. Again it is going to fail because exact is exact, that's all, and exact slash foo slash if you access and with only slash foo from the request path which is from the browser, then it is also going to fail. So which means exact is only for critical specific implementations which you know thoroughly, right? But most of the time prefix is loosely coupled and you will be able to easily use it, right? If you see, slash foo works for slash foo, and also with trailing slash also it works, and here also with prefix with trailing slash if you put it, and in your path if you define slash foo slash with the trailing slash, still it is going to work with and without when you access it via browser. And prefix with slash AAA slash BBB, and if you try to access with additional B here, it is not going to work. Why? Because it is not going to add any string additions here. It is like slash AABB, and it should be slash AABB, that's all, right? But if you provide slash AAA slash BBB, and also if you request via browser also slash AAA slash BBB, it is going to work. So like this you can define, you can see all these things how it is going to be, all the samples provided here. So these are generic ingress things, prefix whatever you see, and for exact also. So you can define these things, and accordingly most of the things are covered here, so you can use it and then implement your rules. So now let's come back here, remove this, and the path is slash prefix backend and everything is good. So now let's go back to our GitHub, right, and then run the kubectl apply now. So let's come back here, and we are in 0802 ALB ingress basics, And if you see here, we should have something called 01 and then 02 related folders, right? 01 and 02. So I'll say kubectl apply -f 02 kube manifest rules, right? So this should create the Nginx deployment and Nginx service and Nginx ingress service, right? So now we can go ahead and then see kubectl pods, and our app1 Nginx pod is created. And if we run the svc, it should provide us the app1 Nginx node port service, which is with 30134 is the node port service. And we'll also run the kubectl get ingress, and you can see ingress Nginx 1 is created, and this is the URL for that. And let's go here to load balancers, refresh, right? And you can see the name of it is app1 ingress rules. So why? Because I have given the name for this as ingress rules. This is a ingress rules demo. So the load balancer name I have given as app1 ingress rules, right? And here are the listeners, and it is in the state as provisioning. If you go to target group and open that, right? So you can find both the worker nodes were registered here with port 30134. So whatever we have defined here, right? So 30134, whatever it has automatically generated for this node port service. So now let's wait for this load balancer to come to active state so that we can go ahead and then test it. So we can see here our load balancer is in active state. So we can open here and we can see there is no default backend for us, right? And we can see path is /star, and for that /star goes to our app1 Nginx default target group, and inside the target group we have our respective node port service related things registered, right? So both nodes were registered with 30134, right? So now let's see, both are healthy. So now let's come back here and take this, copy and run this, right? And you should see that we should get the welcome to Nginx root context page. Why? Because we said /star, and I'll also say /app1/index.html, and my app1 should be accessible now. So let me close these things, right? So now what we are going to do is we are going to also verify kubectl describe ingress, and ingress name is ingress Nginx app1, and we'll see the rules here how it is defined, right? So let's wait for it. See, the default backend is default backend HTTP, nothing is there here in the default backend. And in the rules you can see for the / this is the node port service it is pointed to. So this is the difference between the previous default backend one. There you have seen the node port service here, and now you are seeing the node port service here for the app1 Nginx. So this is good. Now what we are going to do is we'll do a small test. Even I didn't document that step here, but we will do that, right? So let's come back here, and in 0802, right, we will change this to /app1. So we have learned about that prefix things a lot here, if you remember, right? So let me open this documentation, ingress path types, and we have defined /app1, which means earlier whatever we are accessing here. So let's come back here, and this should go away, which means whatever the root context, under the root context, whatever we are accessing, this welcome to Nginx page. So after this change, it should go away. So let's see. So we are saying that only anything with /app1, then only go to app1 Nginx node port service. So which means under the root context, whatever is there, it should fail, right? So now we have saved this, and if you come back here, right, and see /foo with prefix, right, it will allow for /foo and anything with /foo/star, right? So that is the importance of prefix. So let me run this change now. So I'll come back, kubectl apply -f and then 02 kube manifest rules, and this change should take place. And now if I say kubectl describe ingress nginx app1, so you should see the rules here, which is /app1. And if you go back here to rules here and refresh them, right, or if you go here, so it should say /app1 or /app1/*. So now let's come back here, kubectl get ingress, right, and copy this, right, and go to the browser and try it. So this is coming from the cache. So let me go here. See, it is failing in the incognito window. And if I say /app1, and it should app1/index.html, so this should work. So very clearly tested the use case which we have discussed here, which is this one, path /foo. So /foo and then /foo/ will be allowed when your path type is of kind prefix. So let me roll back this change here so that you can test it later, right? So with default one. So now let's come back here and go ahead and then clean up. So I'll come back here and clean up. kubectl delete -f02 kubemanifest rules. So this should remove the deployment service and also the ingress service, which is the application load balancer, whatever it has created. So let's wait for all the resources to get deleted. So one important thing to note here is verify whether your ingress is deleted successfully or not. Why? Because application load balancer is costly, and by any chance if it didn't get deleted properly, then it is going to charge us heavily, right? So for that purpose, verify with get ingress command here, kubectl get ingress, and also go here and also say refresh in your load balancer section, and also verify there are no load balancers, so that we'll not have any unexpected charges for us. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. In this section, we are going to implement Kubernetes ingress context path based routing in application load balancer. So let's see the network design for this entire implementation. So we already created a VPC, and inside a VPC we have public and private subnets. We already created a EKS cluster control plane and also EKS private node group in the private subnets. In addition to that, we also installed the ingress controller. So now we are going to deploy 3 apps. So for those 3 apps, we are going to have those 3 deployment manifests and node port service manifests. So those are nothing but app1 node port service and app1 deployment, app2 node port service and app2 deployment, and app3 node port service and app3 deployment. And we are also going to define an ingress service with context path based routing rules. So wherein we are going to define a rules like /app1 goes to app1 node port service, which eventually goes to the app1 pod, and /app2 context path goes to app2 node port service, which eventually goes to the app2 pod, and anything with root context goes to app3 pod via app3 node port service. So as a user, whenever I access my application with ALB DNS URL / with root context, so the request will go to app3 pod via node port service and ingress service, and the rule is /. And when you access your URL with /app1, so it comes to your ingress service and it checks for the rule /app1 and it routes to app1 node port service. From there it will reach the app1 pod, and same applies to the app2. So whenever user accesses with /app2 as the context path in the browser, request comes to the ingress service and validates its rule for /app2. The configured service is going to be app2 node port service. So it will go there, and from there it will go to app2 pod. So this is what is going to happen whenever we implement the context path based routing. So far we have seen the network design for ingress context path based routing using the AWS resources. So you can see EKS cluster control plane, public subnets, private subnets, worker nodes, all these things. Also see the same architecture in a different way using the Kubernetes objects, how it is going to work inside the Kubernetes cluster, right? So you have in AWS cloud, you have created the AWS EKS cluster, and in EKS cluster in the kube system namespace you have installed the ingress controller. So ingress controller related deployment, which eventually creates the ingress controller pods, and also you have the ingress webhook service. So now whenever as a Kubernetes admin using kubectl client, whenever you deploy the Kubernetes objects, right? So in those objects, whenever you deploy ingress service related Kubernetes object or a resource, so this ingress controller keeps watching the K8s API server, which is EKS cluster API server, for finding any ingress service is deployed. And if it finds any ingress service is deployed, immediately it is going to create the ingress service for us. And this ingress service is nothing but whenever this ingress service is created, its equivalent AWS application load balancer is created in the AWS cloud. And this ingress service already has context path based routing rules inside that, and those also will be defined inside this ingress service, and equivalent routing rules also will get created in the AWS application load balancer, right? Now, one important thing is, so using the K8s admin using kubectl client only, you will also deploy the node port services and also deployments for your Nginx app1, app2 and then app3. And whenever user accesses with the /app1 context, so the request will go to app1 Nginx app1 pod. So via ingress service and the rules, it will cross check the rules and it will go to that app1 service if the context path is app1, and go to that node port service, and from there it will go to the pod. Same applies for app2 and same applies for the root con. Another important thing which we need to be aware of is AWS application load balancer and ingress service are not two different objects. In other lines, so it is like AWS application load balancer is not proxying its request to ingress service. So both are combinedly a single object. So for depiction purpose, in EKS cluster you call it as ingress service, and in AWS cloud you call it as AWS application load balancer. So whenever as a Kubernetes admin, whenever you provide the ingress service Kubernetes manifest for K8s API server, when this ingress controller watches and creates the ingress service, so this ingress service is nothing but it creates equivalent AWS application load balancer object. That's all. So which means users, whenever they access anything /app1/index.html or anything, so this entire thing is a single object, and from here the request goes to the your respective node port service, and from there it will go to your respective application pod. But anything under this red boundary is called a single object. So this clarifies that there is no proxy between AWS application load balancer and ingress service. Next. So this completes the introductory part of EKS ALB ingress context path based routing. In our next lecture, we are going to go ahead and then practically implement the same use. I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. Let's go back to our GitHub repository, and we are in section 0803 ALB ingress context path based routing. So as part of introductory section, we already discussed about the network architecture, what we are going to implement, and also the rules we are going to define for app1, app2 and then app3. So as part of this process, we are also going to move our health check path annotation at the service level, which is nothing but inside the node port service. So why we need to do that is because in the ingress service, we can define a health check path if it is common for all the services or all the applications whatever you are load balancing. So but per application you have different health check path, then that respective application health check path URL should be configured inside that respective node port service. So in that line we are going to move the health check path related annotation to the node port service of that respective application, app1, app2 and then app3. And let's go back to our step 2 here, which is review Nginx app1, app2 and app3 deployment and then service. Service is nothing but the node port service. So let's go to our Visual Studio Code here, and we are in section 0803 ALB ingress context path based routing, and we are in 08 new ELB application load balancers, and inside that 0803, and in kube manifest folder we have 01, 02 and then 03 files. So 01 Nginx app1 deployment and node port service, 02 Nginx app2 deployment and node port service, and 03 Nginx app3 deployment and node port service. And in app1 deployment and node port service, so the standard deployment pattern and standard node port service related manifest will be there here. Only differences, right? Only differences we are going to have here primarily are related to Kubernetes deployment, which is container image name, and for Kubernetes node port service the health check URL path. So let's come back here, and this is the app1 Nginx deployment, and replicas we are going to create one pod here, and the selector match labels you have the app1 Nginx as the label here, app equal to app1 Nginx. So the same thing need to be defined in your node port service related selector app1 Nginx. So now when you come to here in the image, right, in the pod template spec, right, so stack simplify / kube Nginx app1 will be your app1 related Nginx image. And when you go to the node port service here, the health check path for app1 is /app1 index.html. So this is the thing. So this is the one which we need to move to those respective node port services. So need to add health check path annotation at service level if we are planning to use multiple targets in a load balancer. So accordingly we have ensured that for the app1 Nginx we have added the health check path in our node port service. So now if we go back to 02 Nginx deployment, so here also you will see this is kube Nginx app2 will be my image here, and health check path also it is /app2 index.html, and remaining things which is nothing but this is a app2 Nginx, so its label selector match label will be app2 Nginx, and its selector in the node port service also going to be app2 Nginx, right? So now let's go back to our 03 Nginx app3 deployment, and if you see here the image name is kube Nginx. So this is a root context. Here there is no specific context like /app1 or /app2 inside this Nginx image. So it has a root context, and in the root context you are going to have the index.html. So now let me also change this to app3. So everywhere you should see app3. So selector match labels app3 Nginx, and here also in the node port service also you'll see selector and the label is app and app3 Nginx. And another important thing we need to cross check here is the health check path. So here we are going to check the root context /index.html as my health check path for my app3 application. So these three are the applications we are going to deploy, and using ingress service, right, we are going to do the context path based routing. So now let's come back here, and this completes the review of step 2. In our next lecture we are going to review step 3, which is create ALB ingress context path based routing Kubernetes manifest. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's go to the file 04 ALB ingress context path based routing.yaml, and let's define the ingress service here. So let's go back to our Visual Studio Code here, and we are in 04 ALB ingress context path based routing. So this template we have took from the 0802 ALB ingress basics. So where we have written 02 ALB ingress basic with rules. We have copied that and we have changed it the way we need it. So the first thing what we need to change here is, let's go back here to context path based routing, and the name of my service, ingress CPR demo, context path based routing demo. And also the load balancer name we are going to give here is CPR ingress. And now let's come down here and change these rules as per our needs, right? So the first things first is, we are going to implement 3 apps, app 1, app 2 and then app 3. So we'll put this as 3 times the paths. And the first path is app 1. So for app 1, it need to go to app 1 nginx node port service. So if we want to verify the name of our node port service, go to 01 nginx app 1 deployment, and this should be app 1 nginx node port service. So let me close this, come back here and put the same thing here, right? And now the second one is app 2. And for app 2, the service name is going to be app2 nginx node port service. So go to 02 and get the name from here and come back here and put that. And for the root context, right, it is going to be app 3. So let's go to 03 nginx app 3 and get the name of the node port service, app 3 nginx node port service, right? So let me put this here. So now you can see that for whenever the request comes with /app1, it goes to app1 nginx node port service. From there it will go to app1 related pods. And when request comes with /app2 in the context path, URL /app2, so then it goes to app2 nginx node port service, and from there it will go to that respective pod. And same applies for app3 nginx node port service. Anything other than app1 or app2 context, anything comes, so it goes to app3 nginx node port service. So let's come back here and move on to the next step. Next step is to deploy all the manifests and test it. So let's go back to our terminal here, go into 08 new, right, which is 08 new ELB application load balancers, and inside that we are going inside 0803, which is ALB ingress context path based routing. And if you see here, we should have the kube manifest folder, and if you go inside and verify that, you should find 01, 02, 03 and then 04. 04 is ALB ingress context path based routing YAML. So let's come out of this and then be inside 0803, right, and say kubectl apply -f and then kube manifest. So this should deploy 3 applications related deployments, node port services, and also create a ingress service for us. So you can see app1 nginx deployment and app1 nginx node port service is completed, and app2 nginx deployment and node port service is created. And same line, app3 nginx deployment and app3 nginx node port service. And finally, it also created the ingress CPR demo related ingress service. So now let's come back here and verify the application pods and then node port services. So kubectl get pods should provide us the app1, app2 and then app3 related nginx pods created here, and one by one they are ready and then running, no issues. And we'll also verify the kubectl get svc, so which is services, and it should display as the node port services, app1, app2 and then app3. And now let's come back here and verify the ingress load balancer related service. So we'll say kubectl get ingress, and this should display the CPR ingress CPR demo related ingress service, and it is using the ingress class my AWS ingress class, and this is the address it has created, the load balancer DNS name with port 80. So let's go back here, and if we want, we can also review the rules inside this respective ingress service. So we need to say kubectl, right, describe ingress, and this is the ingress service name, ingress CPR demo. and let's see the rules whatever we have implemented in our ingress service manifest were created as expected or not. So you can see here /app1 goes to app1 Nginx node port service on port 80, and /app2 context path goes to app2 Nginx node port service, and / goes to app3 Nginx node port service. And we didn't define any default backend, so it's nothing here, right? So now let's come back here, and you can see successfully reconciled, and there are no error events also here. And these are the annotations, whatever we have specified, those were displayed here. So now let's come back here and verify the load balancer controller logs, right? So you can go here, kubectl-n kubesystem get pods will provide us the load balancer controller, and if we want to review the logs also, we can review these things, kubectl-n kubesystem, right? And you can say logs -f, and for both the pods you can verify the logs if there are any errors in those things because of the ingress service whatever you have deployed. So we really don't need to do this, but it's for our additional learning. You can see here registering the targets and so on. So you can see all the logs in detail and understand little bit more. Ideally not needed. So I'll remove this and I'll say clear, and we'll go to verifying our application load balancer on AWS management console. So let's come back here, and in EC2 let's go to load balancers. And in load balancer, CPR ingress related load balancer is created, and in basic configuration, so you can find the DNS name. So this DNS name should match whatever we got here, which is kubectl get ingress, right? Ingress and 110.43.11.640, 110.43.11.640. So this is good, and state of the ingress service or the application load balancer is active, which means we can access in the browser and test it. So we'll go to that a little bit later. First we'll go to the listeners, and we can see the port 80 listener is there, and under this listener we'll see the what all rules it has been defined. So you'll go here and you'll find something like /app1, and whose priority is topmost. The way how you define the priority is the /app1 will be the first priority, and you can see it is going to some forwarding to some app1 Nginx related target group, and /app2 or /app2/* should go to app2 Nginx target group, and /* goes to app3 Nginx target group, right? So now let's come back here and go to the target groups, right? And you should find 3 target groups, app1, app2, and then app3, and all are using the node port service, which is nothing but whatever we have defined there. So let's open one of the target group and verify that app1 Nginx target group, right? So total it has 2 targets, which means why? Because we have 2 worker nodes running. So those 2 worker nodes were registered here with those respective node port services, and then respective node port service, and you can see both from both of the nodes it is healthy, the pod is healthy for us. And now if you see here, the health check path should be /app1 index.html, and you can see it is healthy, right? Even though you have created only one pod, but the node port service is span across all the nodes. So which means in the worker nodes, whenever you are using the node port service, right? So it is span across all the worker nodes. In a worker node group, you have created 10 nodes. So those 10 nodes will be registered here with that respective node port service related port, which means even though you have created only one pod and it is running in any one of the worker node, but the concept here is node port service will be, or the service Kubernetes service will be spanned across all the nodes. In that line you can see here all those nodes will be registered here. Now let's come back and verify app2 related one and its health check path. Those also healthy, both nodes registered, and you can come back here and app2 index.html is the path for that, and it is working as expected. And this is the app3 Nginx, which will be with root context /index.html, and it is also healthy. So why we are verifying the health check paths here very specifically is, so whatever we have defined at the service level annotation, right? Here health check path, has been populated here successfully or not in the ALB application load balancer, we are cross checking. So why? Because we said that we have defined the context path based routing related ingress service, but we didn't define the health check path here, but we defined at the service level here. Whether it came here successfully or not, we are cross checking, and it came successfully here. And we can see for all the 3 paths whatever we defined in the node port service annotations, so same is populated here. So now let's come back, right? So we verified the target groups, health check paths and everything. So now finally we will go ahead and then access the application. So how we are going to access it? So we can take the DNS name from here, from the load balancer description here, or we can go here and copy this address. And for app1 it is going to be, we are going to say /app1/index.html, and you can see it should be coming online now. So welcome to Stack Simplify, and application name is app1, and app1 is in light green color. So now we'll go to /app2 and index.html, and this should show us app2 related things, and you can see this is in different color. And now finally we'll also access the root context /index.html, right? So whenever we access the root, so it should be the default app, which is welcome to Stack Simplify Kubernetes fundamentals demo. Application version is v1. So this is app1, so this is app2 under the app2 context, and this is the default app3 one with the root context /index.html, and you can see all 3 are of 3 different colors. So the requests are going to 3 different apps for us. And if you want to further also verify, so you can go to kubectl get pods, and for each pod, right, kubectl logs -f, and then you can go to those pods and then verify the logs. Let's wait for it, and you can see /app1 index.html, the health check path also using the same thing. So that's the reason you can see the 192.168.91.189, all these things are coming from our load balancer. Right here you can see this is app1. So whenever you check the logs for your app1 related pod, so it is saying 200 for app1 index.html. And if you see for kubectl get pods, and if you check for app2 kubectl logs -f and app2 pod, you should see the health check for app2 running there. So the logs for app2 index.html, and it is also 200. And also we will say one more here, kubectl get pods, right? And we will also see for our app3, which is, it should have the health check path for root context. So let's say logs -f, and this is the app3 nginx pods. Come back here and verify this, and it should have /index.html. Get /index.html, and it is coming from the ELB health checker. So this is the thing, and you can see one more here. This is not ELB health checker. So whenever we have accessed from the browser, so Intel Mac OS X 1015, which is my Mac OS, there it has accessed, and it is the public IP of my mission 124.123.166.3, right? So this is the thing. So this completes the use case, which is implement the context path based routing using ingress service and then test it, right? So in our next lecture, we are going to test the context path based routing order. How important is the defining the order for our context path based routing. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 6, we are going to test the order in context path based routing. So let me close all these things, 3 apps here, and let's come back to our GitHub repository and go back to our Visual Studio Code, and in 04 ALB ingress context path based routing. So you will find something here called in path based routing, order is very important. So if we are going to use /star, which is the root context at the end, or root context, right? /star, or you can also say this as root context. try to use it at the end of all the rules. So that is very important. So if we don't define root context at the end, and then if we define that as the first one, right? So what happens? We are going to see now, right? So we have moved the root context on the top, and after that we have defined app1 and then app2. So now what we are going to do is we'll go to the terminal and we'll say kubectl apply -f kube manifest. So we have changed the ingress service and slightly reordered the context path based routing. Root context we have moved to the top, and we are redeploying the kube manifest for ingress service. So no changes for app1 nginx deployment or node port service. Same for app1, app2 and app3. But for ingress CPR demo, so there is a change, so it has reconfigured it. So now let's come back here and go to CPR ingress and go to the listeners here and open the rules. So earlier you have seen /app1 and app2 are the 1, 2, and this one is going to be the third one, but now this is the first one. So now let's see what happens, right? So let's go back here and access it. So you can access it here, and what happens is for app1 and app2 the request will fail, but for root context it is going to pass. So let's see what happens, and after that we will discuss more. So I'll say kubectl get ingress and copy the address here and go here and say /app1/index.html. This is coming from the cache, browser cache. So I'll say here incognito and I'll provide this and /app1/index.html. So it is saying that 404 not found. What exactly is that, right? /app2/index.html and 404 not found, and will access the root context, and it should work. See, the root context one, which is the app3 one, it worked as expected, but for app1 and app2 it didn't work. So what is happening here is, so let me go back here, and what is happening is any request coming with any context path including /, it is going to only app3 nginx. Why? Because this is the priority one rule defined here. So it never goes to the app1 nginx related target group or app2 related target groups. Always the first rule with root context takes the priority, and it matches here. So / comes, it will go to app3. /app1 also is part of /* only, right? So it goes to app3, and /app2 also part of /*, right? It goes to app3 nginx related target group. And in app3 nginx related pod we don't have anything with context app1 and then app2. So that's the reason. So from this respective app3 nginx pod we are getting the 404 error like this. So that is what happened. So now let's go back to our Visual Studio Code and change the thing here, right? Roll back whatever we have implemented now and come back and paste it back. So this is one thing for important discussion. What is that? In path-based routing, order is very important. If you are going to use root context, try to use it at the end of all rules. That is one thing. And another important thing we need to discuss here. So with this, we have completed what we have implemented, right? So roll back the change, it is completed, and if you want you can clean up whatever you have created. So cleanup is very important. kubectl delete -f kube manifest. So why? Because it is creating a application load balancer for us, and application load balancer costs a lot if we don't clean up properly. So now we have successfully deleted all our app1, app2, app3 nginx related deployments and node port services, and also our ingress CPR demo. So which means if you go back here and refresh, so you should not find any ingress service. But another important thing we need to discuss here is, instead of root context also, if you want, you can also enable directly the default backend. So you can comment this part or remove this part and uncomment this part. So default backend is nothing but anything with root context or anything with any other context other than /app1 and /app2 goes to the default backend. Same as root context only, right? So you can also use default backend if you want to use it. So this completes the ingress context path based routing demo. In our next lecture, we are going to focus on another ingress concept. So I'll see you in the next lecture. Until then, bye bye. Welcome back. In this section, we are going to implement the Kubernetes ingress SSL use case. So let's understand the tasks involved as part of this ALB ingress SSL use case. And before going to tasks, we also need to know that we are also going to introduce two more services as part of this use case, which is AWS Route 53 and AWS Certificate Manager. So as part of task 1, we are going to register a new domain in AWS Route 53. So this is just to learn how to register a domain in our AWS Route 53. And as part of task 2, we are going to create a SSL certificate in AWS Certificate Manager. And as part of task 3, we are going to update the SSL annotations in the ingress service and deploy those Kubernetes manifests and then test it using task 4. So let's also understand the network design for this. So whatever we are seeing currently is a network design we have used and seen already in the context path based routing use case or demo. So now we are also going to add AWS Route 53 related service here and also ensure that we register a new domain inside this Route 53 service. And we are also going to create a SSL certificate in the Certificate Manager service. And we are also going to update our ingress service with SSL related annotations. And finally, we are also going to DNS register our application load balancer DNS name with a custom DNS name with SSL, something like ssldemo.stacksimplify.com in the Route 53 as a record. And whenever we access HTTP URLs, all three applications, app 1, app 2 and then app 3 should be accessible for us. And we will be also able to access using HTTPS ssldemo.stacksimplify.com for all the three applications with their respective context path. And in next demo, in addition to this, we are also going to implement a SSL redirect. So whenever you access these HTTP URLs also, it will directly redirect to HTTP URLs. But that is in the next demo. In this demo, we will see the URLs in an independent model where you can access the application with both HTTP and also HTTPS URLs. Now, to register a domain in AWS Route 53, already stacksimplify.com is a registered domain which we are using for all our websites. So that said, to implement or demonstrate this use case, we are going to use a new domain named kubeoncloud.com. So this completes the introductory part of ingress SSL use case. In our next lecture, we'll go ahead and then practically implement this. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to register a domain in Route 53. So we are going to buy the domain kubeoncloud.com. So let's go to AWS Management Console, and on the console home, search for Route 53. And in Route 53, we'll go for the registered domains. And then we are going to register a domain, and the domain name is going to be kubeoncloud.com. Okay, so it took something else here. Remove R here. Yeah, check it. Okay. And we got it, kubeoncloud.com. So everything looks good. kubeoncloud.com, right? So add to cart and go down. And if you see here, you can click on continue. And these are the personal information. We can leave it. And you can see privacy protection enabled for my domain, enabled. And then I'll click on continue. And if I go here, do you want to automatically renew your domain? Yes, I want to renew it. And the terms and conditions, I'm going to accept it and then click on complete the order. So our order got submitted successfully. It might take close to 3 days to complete it usually, but once we verify our payment, usually it might be faster, in a day or even lesser than that. So we'll go to domains and my other domain is in action required for verified payment. I will leave it. Once this also comes into that same status, we will verify for this one, okay, kubeoncloud. So I got the action required for kubeoncloud. So I'll go there at the end, and then I'll do the verify payment for the latest one, okay, 1219. I'll go there. So one I accidentally sent it, so I really don't want to pay for the other one. So now if you see 48302601 and then 2877. So 2877 is the latest. I'm going to say verify and then pay, right? So I'm going to pay it now. So let's wait for the payment to happen. Okay, I provided the OTP and this should be done now. So we have completed the payments. If we go for bills, orders, and then invoices, so one should be like that only, and then one should be already paid. Okay, so let's wait for some time, or go to registered domains here and then pending requests. Okay, so it will take an hour to update the status. So let's wait for an hour to see what happens. So once we have completed the verify and pay, so we can see that for kubeoncloud, we can see domain registration is in progress. So let's wait for everything to be completed now. So within an hour, I have seen that my request has been moved from pending request to registered domains. So hardly within less than 2 hours, entire process will be completed for us for the register a domain. And only one thing is we need to verify our payment thoroughly. That's about it. So now I have the kubeoncloud domain available for me, kubeoncloud.com, and then its registrant is verified, and we can see all the details about it. If you want to extend this domain for another 9 to 10 years, if you want, you can do that now. Okay, and auto renew is anyway enabled, so every year it will automatically gets auto renewed. So now one important thing here is if we click on manage DNS, it will take us to the hosted zone. So the public hosted zone for kubeoncloud.com is already by default created. Okay, so now here we will be able to DNS register our domains. Okay, so whatever the subdomains we want to register, or whatever the main domains we want to register, we can create a record set here and then says that users.kubeoncloud.com and then provide the IP address or the ALB DNS name, ELB DNS name, all these things here to DNS register it. Okay, so this is about the registered domains section, which is nothing but our step 2, register a domain in Route 53. In our next lecture, we'll focus on creating a SSL certificate in Certificate Manager. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's go back to our GitHub repository, and we are entering into the section 0804 ALB ingress SSL. So as part of step 2, we already registered a new domain named kubeoncloud.com. But for all our examples or demos, we are going to use our standard domain stacksimplify.com here. This is just to learn how to register a domain in Route 53. So now we'll go to step 3, which is creating a SSL certificate in Certificate Manager. So let's go to AWS Management Console and go to Certificate Manager Service. And in Certificate Manager Service, we are going to create a new certificate, and we are also going to call this certificate as a wildcard certificate, which means with any domain subdomain name, this respective certificate should work, which means we are going to give or generate a certificate named star.stacksimplify.com or star.yourdomain.com, so which is called a wildcard certificate. So we'll click on request and request a public certificate, and we'll click on next and provide the fully qualified domain name here. So I'm going to provide it as star.stacksimplify.com, right? So this is called wildcard certificate, wherein all the subdomains are supported here, which means SSL demo 101.stacksimplify.com, abc.stacksimplify.com. So whatever may be my subdomain name, so everything will be supported here for the SSL certificate, which means we'll not, whenever you are using this SSL certificate and using any subdomain name, we are not going to get any SSL certificate pop-up error on the browser. So, and we have provided the qualified domain name here, star.stacksimplify.com, and we need to select the validation method. So we are going to use the DNS validation method, and we'll click on request, right? And you can see here, let's wait for it. So you can see this is the respective certificate it has created, and it is saying pending validation. So let's go to that respective certificate here, and we can see it. We need to create a records in Route 53 for the DNS validation to complete. So we need to complete the DNS validation step. So we'll click a records in Route 53 here. So pending validation. So we'll click on create records in Route 53, and it is going to automatically add the records in Route 53. So create records. Records successfully added in Route 53. So let's click on the certificate ID and verify the same. So we can see here domains, and it is success, and it has created a CNAME record with these names. So we can go to Route 53 service, right, and go to hosted zone stacksimplify.com, right. So let's go to hosted zones here. Where is it? Here. And in hosted zones, we'll go to stacksimplify.com, and in stacksimplify.com, so let's search for the CNAME record with this value. So copy, and see, we can find the same thing here. It successfully created that CNAME record in our hosted zone, which means our DNS validation is successful, and this respective certificate status is issued. So this completes the creation of SSL certificate. In our next lecture, we are going to work on Ingress SSL related annotations. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of this step, we are going to add annotations related to SSL in our 04 ALB ingress SSL.yaml file. So let's go to our Visual Studio Code and go into the section which is 0804 ALB ingress SSL, and 01, 02, 03 are same as our previous section which is 0803 ALB ingress context path based routing. And in ALB ingress SSL also, we will change the name of my ingress service which is ingress SSL demo, and we'll also change the load balancer name which is SSL ingress, and we will add additional 3 annotations. So the first annotation is we are going to add the listen ports. So we are going to add the listen ports 443 and then 80. So let's go back and see in kube manifest and in ingress context path based routing, do you see any of the listen ports related annotation? We didn't have any listen port related annotation. So which means by default port 80 listen port will get created. So now whenever we are explicitly defining them, right, so we define both HTTP 80 and 443 listeners here in the listen ports. Why? Because SSL listens on default 443. So now the next thing is certificate ARN. So update the certificate ARN here. So we need to tie the SSL certificate whatever we have created just now. So in your case, the certificate is going to be the certificate you have created in your AWS account. So let's come back here, and this is the certificate we have created, star.stacksimplify.com, and its ARN is here. So let me copy that and provide that certificate ARN, and you can see this is SSL policy. We really don't need to specify this. By default whatever is available in AWS as part of today's standards, so that will be taken automatically. But if we want to explicitly add any specific SSL policy, so we can get that policy name and then add it here. And if you go to the annotation reference for this, so you will find something called SSL in the table of contents, and there you will find the SSL related additional annotations available here for your reference. So we already used the certificate ARN, and we can also use the SSL policy if we want to use it. So these two are the core things related to SSL, but in addition to that we also used the listen ports under SSL just for our what we call to ensure that all the things are at one place. So even though that is not a SSL related annotation, but there you have updated the SSL port. So that's the reason we have grouped them and then put them together here in this respective ingress service file. So we can put it anywhere, but for just to understand that as part of this ingress SSL demo only, we added this annotation and we added this listen port. So that will be clear for us. So now let's go back here, and we have reviewed the ingress annotation. And we know that already 01, 02, 03 related Kubernetes manifests are from our previous demo, which is context path based routing. As part of step 05, deploy all the manifests and then test them. So let's go back to our terminal here, and we will enter into the section 08 new ELB application load balancers, and inside that 0804, which is ALB ingress SSL. And if we verify here ls-lrt and kube manifest, so we should find the file 01, 02, 03 and then 04, which is ALB ingress SSL. So I'll say kubectl apply -f kube manifest. So this should create the app1, app2, app3 related deployments and node port services. In addition to that, it will also create the ingress SSL demo related ingress service. So let's say kubectl get pods should list the 3 pods created for us for app1, app2 and then app3. And we'll also see their node port services. kubectl get svc app1, app2 and then app3 related node port services also created. Finally, we'll also see the kubectl get ingress. The ingress service related to SSL demo is created now. So let's go back here and verify the same thing in our AWS management console. So let's go here and go to EC2 and go back to load balancers. So let me close this and go to load balancers. And in load balancers, we can see SSL ingress and some number, and this DNS name we can see here. Same you will find the here whenever you run the command kubectl get ingress. And in the listeners, you should see both 80 and 443 listeners created. So click on these rules for 80, right? And you will find /app1/app2. And we also used it here instead of root context. If you see here, another difference is we directly used the default backend for app3. So in ingress context path based routing, so we have given the option like either you can use a default backend or you can use this path, right? But now what we have done here is directly we didn't use the root context path, we just used it as a default backend. So exploring or giving additional option for us to use either a root context or a default backend. So there you have used root context. So here you have used default backend. So now you have seen the rules for your port 80 related listener. Also see the rules for port 443, right? So the same rules will be applicable for you for port 443 also. /app1/app2 and default backend is going to be app3 nginx. And if you want to review the target groups, those are going to be same as how we have reviewed in our ingress context path based routing demo. So you can see here. So all the health check paths and everything should be app1 for app1, app2 for app2, and for root context it is going to be /index.html. Another important thing which we need to verify here is the certificate associated with the 443 listener. So if we click on this view certificates here, right? So it has associated the certificate named star.stacksimplify.com. And if you want to verify that, you can click on this ACM here and it will take us to the certificates list, and you can come back here and only the star.stacksimplify.com certificate is this one, whatever we have just now created. So that said that for the 443 related listen port, we have successfully associated the SSL certificate what we have created in our certificate manager service. So how we have associated it? We have associated using the, let's go back here and see, certificate ARN related annotation and providing the ARN of our certificate. So in your case, whenever you are implementing in this ingress service, your change is going to be adding your certificate ARN here. Rest all is going to be as is. So now let's come back here, and we have successfully verified these things. And now another thing we need to do is add the DNS in Route 53. So we are in the Route 53 and we are in the stacksimplify.com and create a record here. And in the record, we'll go back here, right? And we'll provide the name of our record set as ssldemo101.stacksimplify.com, and we'll select the alias and alias target as our ALB DNS name. So let's come back here and I will provide ssldemo some number, and then record type is a alias, right? And alias to load balancer, we should find it here, application or classic load balancer. And in which region we have this? In US East 1 region. And find the load balancer name, dual stack.ssl ingress some 85992160.8. So you can find the same thing here if you go to load balancers. So go to EC2 and go to load balancer, and you should find the DNS name here, and in that you can see 85992160.8. The same thing auto populated here, dual stack.ssl ingress 85992160.8. So I'll click on create the record. So now we have created a record named ssldemo101.stacksimplify.com. So let's come back here and first do the ns lookup test, and after that access the URL. So let's say ns lookup ssldemo101.stacksimplify.com. So if our DNS is successful, so it should resolve to the IP addresses here. So you can see the IP addresses some 18.233.56.149 and something like this. Also, if you want to do the ns lookup of your DNS name of your load balancer, auto generated one, so you can also try that, right? And both the values will be same. Only thing is here you are using the custom domain name instead of this auto generated name, so or your personal domain name you can say. So now let me clear this and go back to the browser and access app1, app2, app3 using HTTP URLs. So let me close this and close this, and here we are accessing SSL demo 1 with HTTP URL. You can see it is not secure, right? And now the next thing is we'll also access the second one, which is app2, and this also with not secure with HTTP URL you have accessed, and one more you are going to access, which is the app3, which is the root context, right? So this also successful, right? So now we'll close these things and we'll access the SSL URLs. So you can see here SSL, with SSL you can see the lock symbol here, and if you want you can go to connection is secure here and certificate is valid, and you can see the certificate it is using is star.stacksimplify.com, which is called the wildcard certificate. Any subdomain is accepted here, SSL demo ABC, SSL demo 102, 201, anything, right? So this is good. So app 1 is accessible now. So we'll go back here and access the app 2 now, and app 2 also should be successful. And finally we'll also test the app 3 here, right? And app 3 also accessible via SSL URL. This completes the Ingress SSL use case demo. In our next lectures we are going to focus on SSL redirect demo. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this demo we are going to implement the Kubernetes Ingress SSL redirect use case. So this network diagram is from our previous section, which is SSL Ingress, and as part of this section we are going to add the annotations related to SSL redirect in the Ingress service, and then whenever we redeploy this Kubernetes manifest, so it is going to do a HTTP to HTTPS redirect for all the URLs. So which means all the applications deployed using this ingress service will be only accessible using HTTPS URLs. And whenever you access with HTTP, automatically it will redirect to HTTPS. So let's go back to our GitHub repository and enter into the section 0805 ALB ingress SSL redirect. So if you see the kube manifest, so those are going to be same as the previous section, copy of the previous section, which is ingress SSL. Only thing is we are going to add an annotation related to SSL redirect. So let me copy this SSL redirect related annotation and go to Visual Studio Code, and we are in section 0805 ALB ingress SSL redirect, and in kube manifest section 04 ALB ingress SSL redirect. So you can find here the name of my ingress service is same thing, which is ingress SSL demo. So if you go here and say kubectl get ingress, so you'll find the ingress SSL demo related ingress service only. So as part of previous demo, we really didn't clean up anything. We are continuing to from 0803 demo to 0804 demo, which is 04 demo to 05 demo, which is ingress SSL to ingress SSL redirect. See, the ingress service is already created and it is present there. So for this ingress service, we are going to just add one more annotation, which is nothing but SSL redirect setting. So in this redirect setting, so to which port it need to redirect, we are provided here, which is 443, right? So port 80 will redirect to 443 here. So now let's come back here and come out of 0804 and go to 0805, which is ALB ingress SSL redirect section. So there only you have added this change, which is SSL redirect annotation. So now you'll say kubectl apply -f kube manifest, and there should not be any changes for your app1, app2, app3 related deployment and node port services. So you can see all 6 should be unchanged, but your ingress SSL demo should be in the configured state, which means the ingress annotation, whatever you have added related to redirect, should be applied now. So now let's come back here and go to the load balancer and refresh it and go to listeners. And if you go to this respective port 80 listeners, right? So inside that you should not find any app1, app2, app3 related or default backend related rules now. So you should have only one thing which says that redirect to 443 port. So this is because of whatever you have added the annotation here. And if you remove this annotation, all 3 default rules app1, app2, app3 will be there, how you have seen in the SSL use case demo, right? So now let's come back here and test the same thing, right? So let's access the HTTP URLs, and those should directly redirect to HTTPS. So in this, if any caching is there, maybe we'll go to the new incognito mode and access it. And if you see here, I am accessing the SSL URL and it automatically redirected to the SSL. I accessed the HTTP URL and it redirected to the HTTPS URL, and you can find the certificate here. And in same way, we will go back here, right, and take the app2 URL and come here and access it. If you see here, I am accessing the HTTP URL and it should redirect to HTTPS. You can see here connection is secure and certificate is valid. Same applies for the app3, which is root context. We have accessed HTTP URL and it redirected successfully to HTTPS, and you can see connection is secure and certificate is valid. So this completes the SSL redirect related demo. So we'll go ahead and then clean up these things. So I'll go back here and say kubectl delete -f kube manifest. And once this is deleted, we are also going to cross check whether our load balancer is successfully destroyed or not. So all the deployments and node port services were deleted, and ingress related service also deleted. So let's refresh here, and it is gone. This is good. So now also go to the Route 53 related service and go to the SSL hosted zone and go to stacksimplify.com. In your case, it will be yourdomain.com, and remove the SSL demo 1 related DNS record, whatever we have created, right? So I'll delete the record SSL demo 101.stacksimplify.com, right? So this completes the cleanup part. In our next section, we are going to focus on very important topic, which is external DNS for Kubernetes on AWS cloud. So I'll see you in the next section. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. In this section, we are going to install the external DNS. So before going and installing the external DNS or understanding what all components involved from external DNS perspective, let's understand why do we need this external DNS. In previous SSL demo section, we added AWS Route 53 DNS records manually. So we went into the Route 53 service inside hosted zones. For that respective domain stacksimplify.com, we have added a DNS record SSL demo 101.stacksimplify.com. But with external DNS, we can automatically add it for a Kubernetes ingress service or a Kubernetes service by defining it as a annotation. So if we add this annotation external dns.alpha.kubernetes.io/hostname and your DNS name, something like DNS test901 or DNS.dnsabc. or myapplication.stacksimplify.com. So if you add these things, then automatically those records will be added in the AWS Route 53 service inside the hosted zone as a DNS record. And in addition to that, you can create, update, delete these DNS records from external DNS itself. So let's see what all components involved in the external DNS related controller. So in AWS cloud, we already have the EKS cluster created. So for external DNS, in the default namespace, we are going to create a external DNS service account, and this service account, right, will be associated with a IAM role. So why we need to create this IAM role, and what is the things present in the IAM policy about permissions that IAM policy is going to have. So we are going to create a IAM policy wherein in that IAM policy it will have the permissions for the AWS Route 53 resource for create, update, and then delete records inside that. And that IAM policy will be associated with this IAM role. And that IAM role will be annotated in this respective service account in Kubernetes, which is nothing but external DNS service account. And then we will also have the external DNS related deployments, cluster role bindings, all related objects deployed inside this default namespace. So this external DNS deployment will create the external DNS pod for us. And whenever as a Kubernetes admin, if we deploy ingress service or a regular Kubernetes service with the annotation whatever we have specified related to external DNS, so then external DNS goes to the Kubernetes API server and retrieves a list of resources like services or ingresses from the Kubernetes API server to determine a desired list of DNS records that need to be created or updated or deleted from the AWS Route 53. So which means this external DNS pod will communicate with this API server and get a list of the ingress or regular services and search for the annotation related to external DNS with the DNS names. And if it finds those DNS names inside those services or ingress services, so then it will go ahead and then create or update or delete those DNS records in the AWS Route 53 related service. So this completes the introductory part of external DNS. So in our next lecture, we'll go ahead and then practically implement this demo. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's go back to our GitHub repository and enter into the section 0806 deploy external DNS on EKS. And as part of step 01 introduction, we already know what we are going to implement as part of this external DNS. So let's go to our step 2 here, which is create IAM policy. So this IAM policy will allow external DNS pod to add, remove DNS entries or record sets in hosted zone in AWS Route 53 service. So let's go to AWS Management Console and go to IAM service and go to policies here and click on create a policy and go to the JSON tab, and in the visual editor add this policy, right? So whatever the policy here it is there, add it and then name the policy as allow external updates and then create that policy. So click on policies and create a policy and go to the JSON tab. And so let me remove this and go here and add this entire thing. Copy and paste it, right? And go to the visual editor tab, and you can see here it will be like Route 53. In Route 53, change resource record sets is one thing inside the hosted zone, any hosted zone, and in Route 53 you have something called list hosted zones and list resource record sets. So these are the permissions we have given currently. So let me minimize this and click on next, and no tags. So we'll provide the name here. So the name here is allow external DNS updates and allow access to Route 53 resources for external DNS is the description, and click on create the policy. So once the policy is created, we'll move on to the next step, right? So we'll make a note of the policy ARN. So in your case, it is going to be different because your AWS account ID will be present here. Maybe the name might be same, but your AWS account ID will be different here. So this is the one, allow external DNS updates. And from here, you can take the ARN and then make a note of it. So this is the ARN we need to make a note of. And now in step 03, we are going to create a IAM role, Kubernetes service account, and associate that IAM policy. All these things, right? Creating a IAM role and annotate that IAM role inside this Kubernetes service account, and also associate IAM policy to IAM role. So all these things can be done using one command in EKS CLI, right? So that is called EKS create IAM service account. So using this, so this IAM is nothing but creating a IAM role, and in this part service account is nothing but Kubernetes service account. So IAM service account, what it does is, so it will create a Kubernetes service account named external DNS, and also it creates a AWS IAM role and also associates them by annotating a role ARN in service account. So this external DNS service account will be annotated with the IAM role it is going to create. And in addition to that, the allow external DNS updates IAM policy, whatever we have created in step 2, so that one will be associated to the IAM role it is going to create. Accordingly, you can see here EKS create IAM service account, a name of the service account you need to provide, and in which namespace in the Kubernetes this service account should be created. So for us it is going to be in the default namespace, right? So the default namespace and the cluster, right? The name of your EKS cluster, and also the policy, IAM policy that need to be attached, IAM policy ARN, whatever we have made a note here, and we are going to approve and override any existing service accounts with the same name, right? So this is the command. You can replace the name. External DNS will be the name of my service account, and namespace it is going to be default namespace, and cluster it is going to be EKS demo 1, and IAM policy ARN, right? So whatever you have took the note in step 2, in your case this is going to change, and this mainly your AWS account ID will change here. So we'll place that allow external DNS updates policy related ARN, and rest approve and override existing service account. These two are same. So let me copy this and go here and provide this command, and this should create the Kubernetes service account, and also it need to create a IAM role for us, right? So it's getting created. Existing Kubernetes will be updated as override existing service accounts was set. So let's wait for it. It is going to create a CloudFormation stack for us. So this is completely EKS CTL is automated with, means like the CLI is triggering to create a CloudFormation stack for us with the details whatever we have provided. So let's wait for the service account to get created, and after that we can search for kubectl get, and then SCA is nothing but service account, external DNS, and you should find that external DNS in our default namespace. So it is created now. So we'll say kubectl get SCA. It will list the service accounts present in your local default namespace. So let's wait for it. So you can see external DNS related service account created 11 seconds before, right? So let me say kubectl describe SCA, and then you will say external -DNS, right? So you are describing that external DNS related service account, and you'll in the annotations you can find eks.amazonaws.com/role-ARN, and it has a IAM role ARN. So this IAM role is created and associated with this external DNS. So now let's come back here, right, and verify. Go to the CloudFormation stack and verify. So let's go to services and go to CloudFormation, and in CloudFormation we'll find this equivalent stack. So we'll find it here, EKS CTL EKS demo 1 add-on IAM service account within in the default namespace whose name is external DNS. So let's open it, and if you see here in the resources, right, in the resources section, so let me close this, you can see the physical ID. This is the IAM service account it has created, so which is nothing but IAM role it has created. So if we click on this physical ID, right, it will take us to the IAM role it has created. See, this is the IAM role it created, and this is the IAM role ARN, and we need to make a note of this role ARN. Note of this IAM role ARN in this approach, or we can also get the IAM role using EKS-CTL get IAM service account, and the cluster name is EKS demo 1. So using this command also we can get the IAM role ARN. So let's run this command, EKS-CTL get IAM service account, and in cluster EKS demo 1. So it should provide us 2 IAM service accounts. One we have created for AWS load balancer controller, and one which we recently created which is external DNS. And from here also we can make a note of this role ARN. So why do we need to make a note of this role ARN is, in the next step whenever we are updating the external DNS related manifest, so there we need to provide this role ARN, so that external DNS pod will use the reference for this role ARN from that respective manifest. So now let's come back here, and in our next step we are going to move to step 04 to discuss about or review the external DNS Kubernetes manifest. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step we are going to update the external DNS Kubernetes manifest. So let's go to our Visual Studio Code here, and we are in 0806 deploy external DNS on EKS, and we have the Kubernetes kube manifest folder, and inside that we have 01 deploy external DNS.yaml, and this is the external DNS related Kubernetes manifest, and inside this we are going to update the IAM role here, whatever the role ARN we have created, so we can update it. So let's go back here, and so this is the role ARN, right? So let me copy it and come back here and add it here. And now the next thing, right? So let's come back here And if you see change one line number 9, IAM role update is completed, and we'll go to line number 56, 55 and 56 and then comment them. We used EKS to create the IAM role and attached the allow external DNS updates policy. So we didn't use KIAM or kube2IAM. So we didn't need to add these 2 lines. So these things are not required here in line 55 and then 56, right? So let's come back here. Where is it? So these things are commented here because we are not using any KIAM or kube2IAM tools here. And now in this, right, so if you see here, this is the deployment specification. So if you go top, so this is the service account related Kubernetes manifest, and these are related to cluster role and then cluster role bindings related external DNS things. And now here you will find the external DNS deployment related Kubernetes manifest, and inside that in the pod template specification you are using the service account name as external DNS, and containers you are using k8s gcr.io. So whatever the latest external DNS pod version available, so we are taking today, which is as on today v0.10.2 is the latest. So we are using this, and in future if it changes, so you can change the version here accordingly. And in addition to that, as part of change 3, if you come back here to the documentation, right, so line 65 and 67 commented here. So what exactly that means? So this is a very important step. So 65 and 67 were commented, and inside those things you will find something called domain filter. So if you want to filter your domains, so currently I removed the domain filter or I commented it, which means this external DNS is applicable to all the hosted zones available in my AWS Route 53. So if you go back here and go to Route 53 service here, or let me go from here and go to Route 53, and you will find lot of domains available here for me in the hosted zones. So you can see here All Cloud Guru, DevOps in Cloud, Stack Simplify, Terraform Guru. So like this, there are multiple domains available here, and for all these domains, right, so this external DNS can update, delete, create inside that the DNS records. But if you want to do only for specific domains, so you can filter those domains and only provide those domains. Example, if you want to provide only for stacksimplify.com, then you can provide for stacksimplify.com like that. Okay, so matching provided domain, omit to process all available hosted zones. So I omitted it or commented it so that it will process all the available hosted zones for me. So I commented it. And in the same way, this is another important setting, which is policy upsert only, right? If you see here, policy upsert only. So when you enable this, right, what happens is it will be able to create the DNS, but it will not be able to delete the DNS. So would prevent external DNS from deleting any records. So omit to enable full synchronization. So which means if you comment this, then this part policy upsert only, when you comment it, which means whenever you create an ingress service and then there you have the external DNS annotation related DNS name, so it will go ahead and then create it. So whenever you delete that ingress service, then automatically the record inside Route 53 also will get deleted. So for full synchronization, comment this part. So accordingly, I have commented it. But if you want the external DNS to only create the DNSs, but it should not delete them at that point, uncomment this, right? And that is not going to be a full synchronization. And AWS zone type, only look at public hosted zones, and valid values are public, private, or no value for both. So these are the things available for us, additional setting for us. And registry type is txt owner ID is my hosted zone identifier, some identifier you can put it. So these are the things you need to pass to the external DNS pod as an arguments, so that it will take those things. And if you see here, it will take the source as a service or a source as a ingress, so which we have discussed here, right? So if you go back here and see this, right, So your source can be means like your ingress service your source can be means like the Kubernetes manifest can be an ingress service or a regular Kubernetes service of type load balancer, so that what happens is those can go ahead and then create the Route 53 record automatically by external DNS whenever you provide this respective annotation. So this is good. So now we have successfully reviewed this. And another important thing you will have something here is the image name. So get the latest Docker image name. So you can click on this and get a latest Docker image name available and use it. So as on today it is v0.10.02 available latest. So that's what we have updated here in our containers name, and then in image name we have updated this. So in our next lecture, we are going to go ahead and then deploy this external DNS. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. As part of step 5, we are going to deploy the external DNS. So let's go to our terminal here and we'll enter into the section 08 new ELB application load balancers. And inside that, we will go to 08070806. which is nothing but deploy external DNS, and we'll say kubectl, and if you want we can verify lslrta and kube manifest. You will find the 01 deploy external DNS.yaml. So I'll say kubectl apply -f and kube manifest. So this should create the or deploy the external DNS for us. So let's wait for it to complete. So we can see here the service account external DNS configured, cluster role and then cluster role binding created, and deployment external DNS also created. And this warning you can ignore, so that is fine. So now let's come back here and run the command kubectl get all from the new default namespace. So all the deployments and whatever the resources present in default namespace we are going to get here. So we can see here external DNS pod is running, and we can see external DNS related deployment and external DNS related replica set. And if we want, we can also list only the external DNS pod here. So get pods, right? And now you can see external DNS pod running. So if you want to verify the logs, so we can run this command to verify the external DNS pod logs here. And we can see if there are any errors or anything also, we can see here. All you can see is everything is working as expected and didn't see any errors here, right? So using in cluster config service token and created Kubernetes client, applying provider record filter, all are info messages. So all are info messages. So there are no errors inside this. So if any errors also, it will be continuously throwing and then we can easily find it, right? So this completes the deployment of our external DNS related things. So what we have done, so we have created a IAM policy and we have created a Kubernetes service account with IAM role and annotated that IAM's Kubernetes service account with the IAM role ARN. So all those things we have done using EKS create IAM service account command, and using that single command only for the, we have also associated the IAM policy to IAM role. After that, we have updated the external DNS default manifest, which will create the external DNS related service account and cluster role binding, and also it has created the deployment, which created the external DNS pod. So this Kubernetes manifest, whatever it has created, right, whatever it has provided is from the external DNS related documentation. Ideally, right, already we have created this part, so we really don't need to have this here. We can remove it if we don't want, but I took how the documentation is present, exactly how took it and then put it here. But that's the reason you can see this error also, whatever you are seeing, right, this warning message also came because it is saying that you already have the external DNS and then why you are trying to reconfigure it or something like that. But ideally we don't need this part, but it is given in the documentation. I have added it. So deploy external DNS related Kubernetes manifest. So we already using EKS CTL create IAM service account. We have created external DNS and we have also annotated that with this respect to IAM role, which means this part here is not needed. So this service account part, but anyway, so it is part of the documentation manifest, so that's the reason I have put it, and which is no harm for us, so that is fine for us, right? So now let's come back, and in our next section or in the next demo, we are going to focus on using this external DNS concepts and adding the annotation in our ingress service, and then test it whether our DNS records get automatically created in Route 53 hosted zones. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this demo, we are going to add the external DNS annotation for our Kubernetes ingress service, and then test it and then see that whether our DNS records got automatically created by external DNS in Route 53 hosted zones. So let's see the network design once before moving on. So in the ingress service, we are going to add the external DNS related annotations, and after that it is going to automatically add the DNS names in the AWS Route 53 hosted zones, and we will be able to test those DNS names by accessing them directly in the browser, right? So now let's go back to our GitHub repository and enter into the section 0807 use external DNS for Kubernetes ingress, right? And if you see here, update ingress manifest by adding external DNS annotation. So let's come back here to our Visual Studio Code and enter into the section 0807 use external DNS for Kubernetes ingress, and 010203 Kubernetes manifests for Nginx app1, app2, app3, no changes coming from the previous sections, and 04 ALB ingress SSL redirect with external DNS is the thing which we are going to update here, right? So in this, the name of the ingress service is going to be ingress external DNS demo, and load balancer name is external DNS ingress. And if you come down here, so this is the external DNS related annotation, and inside that we are providing comma separated two DNS names, DNS test 901.stacksimplify.com, DNS test 902.stacksimplify.com. So like this you can add multiple DNSs or multiple subdomains, or even we have provided currently we didn't comment this part, we commented this part so that all the hosted zones will be applicable here, which means I have something called DevOps in cloud. So I can say abc.devops in cloud. So one more DNS will be added with abc.devops in cloud inside the DevOps in cloud hosted zone. See, domain filter, we didn't provide any filter here. So which means all the applicable domains present in hosted zone can be added here, not only stacksimplify.com. So you can use other domains also, because you have commented that option here and said that all the hosted zones present are applicable here to add the DNS entries by external DNS. For now, we are going to test with the DNS test 901.stacksimplify.com and DNS test 902.stacksimplify.com. In addition to that, another important thing here is, so if you need to ensure that this should be yourdomain.com, and also ensure that here certificate ARN also updated with your own certificate ARN in this ingress manifest, right? From your account, whatever the ARN is there, that one you update it. So now let's go back to our GitHub repo and move on to the next step, which is deploy this Kubernetes manifest and then test it. So let's come back to terminal, clear, and come out of deploy external DNS related section, which is 0806, and go inside 0807 use external DNS for ingress Kubernetes, and let's say ls -lrta and kube manifest, just to check that we have all the files 01, 02, 03 and then 04, right? And we'll say kubectl apply -f kube manifest. So this should deploy the app1, app2, app3 related deployment and node port services, and also create the external DNS related ingress service, right? So now this is created. another important thing here is, the most important thing is, let's keep monitoring your external DNS logs, right? So that we'll get the clarity. Let's wait for it. So we can see here, created DNS 901.stacksimplify.com and 902.stacksimplify.com. This is our core goal, to verify that, right? So now let's go to Route 53 and go to stacksimplify.com. And if you see here, DNS test 901, DNS test 902. And if you see the values inside them, right? So this is the external DNS ingress related manifest load balancer service. So 144.863.844. So now let's come back here and go to the EC2 and find the same name here. So let's come back here and go to load balancers, and you should find the load balancer related DNS name, external DNS ingress 144.863.844. And here also you'll find the same thing, right? 144.863.844, which means the DNS name whatever you have created is associated with your external ingress related DNS name, a load balancer DNS name successfully. So now the next thing here is go and then do the NS lookup tests, right? So let's come back here. So you have verified your external DNS pod with the create. All the things are good. So let's come out and do a NS lookup test for DNS test 901, and it is resolving to the IP address, and also verify for 902 and it is resolving to the IP address. So that is good. And if you want, you can access the application DNS test 901 and then 902. So let me close this IAM, come back here, and DNS test 901 is good, and this is app1 is good, and app2 with the DNS test 901 is good, and also we'll access the root context also. So all redirected from HTTP to HTTPS, and everything is accessible with DNS test 901. So now close this tab, and if you want, you can also access with DNS test 902, right? You are accessing the HTTP URL and it should auto redirect to HTTPS, right? You can see the certificate lock symbol here, and app1 is good. And if you want, we can also access the app2 with 902, and that is good. And root context also we can access and then test it. So this completes the verification of using the external DNS with the ingress service, right? And another important thing here is, when you are testing it, this should be your domain name. And now we'll go ahead and then clean up this, and it should also delete the 901 and then 902 DNS records. Why? Because if you go back here, right? So if you go back to here, and if you see, you have commented this policy upsert only. So which means it should be in the full synchronization. Whenever you delete your ingress resource, automatically the DNS records updated inside that ingress service, right? Whatever is present inside that in the external DNS related annotation, so those should get automatically deleted. So let's go here and say kubectl delete -f and kube manifest. And once you delete it, immediately go ahead and then start monitoring your external DNS logs, right? So let it delete, right? Ingress service is getting deleted. So let's wait for the command line to come for us. We'll monitor the logs here, and let's wait for it. Wait for the logs. So you can see create logs you have seen. Let's wait for the delete logs in the external DNS logs for external DNS pod. In meantime, we can go here and then verify if our load balancer is successfully deleted. So this is good. So we need to always ensure that our application load balancer is successfully deleted. By any chance it is present, again it is going to add cost for us. See, now you are back to your external DNS pod logs, and you can see it is having the desired change, which is delete so and so DNSs, and it has deleted those DNSs and successfully updated that hosted zone. So now come back here and go to Route 53 and go back, and again go inside stacksimplify.com, and you should not find anything related to DNS test 901 or 902. So which means whenever you have created the ingress resource, it has automatically created those external DNS records in the Route 53 using external DNS. And whenever you have deleted or destroyed your ingress resource or you undeployed your ingress resource, automatically external DNS also removed your DNS entries from your Route 53 service. So this completes the external DNS with ingress service demo. In the next demo, we are going to do the external DNS with regular Kubernetes service demo. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this demo, we are going to use the Kubernetes service with external DNS. So which means Kubernetes service of type load balancer, we are going to add the external DNS annotation here. And we are going to provide the DNS name here, and the application whatever you are going to deploy with this respective load balancer service, so you are going to now access it directly with the custom DNS whatever we have created, right? So the Kubernetes service of type load balancer creates a classic load balancer in AWS, and its DNS name will be registered as alias in the Route 53 for the external DNS name whatever you have specified. And whenever you access external DNS K8s service demo.stacksimplify.com, request will come to classic load balancer, and from there you will be able to access your application pods load balanced under this respective load balancer, right? Let's go back to our GitHub repository and enter into the section 0808 use external DNS for Kubernetes service. And if you see here, we are going to create a Kubernetes service of type load balancer and annotate it with external DNS related annotation for a DNS name, right? So and then deploy and then verify the stuff. So let's go back here, and if you see in 0808 use external DNS for Kubernetes service, so you can see this 01 Nginx is a app1 deployment, right? And 02 Nginx is a load balancer service, which is like Kubernetes service of type load balancer. And here we have added the annotation here, external DNS K8s service demo 201.stacksimplify.com or some 101.stacksimplify.com, whatever it is, right? So now let's go back to GitHub repository and go to step 3, deploy and then verify. So let's go to the terminal here and enter into the section 0808 use external DNS for Kubernetes service and clear, and we'll say kube manifest. We should find the two files here and kubectl apply -f and kube manifest. So this should create the Nginx app1 deployment and Nginx app1 load balancer service for us. So let's wait for the deployment to get completed. So now let's go back here and go to load balancers here in EC2 and refresh it. So it is creating a classic load balancer for us. So let's wait for this to get created. Currently the status is 0 out of 2 instances is in service. So we'll wait for these things to come into service. In addition to that, we can go back and then verify our external DNS logs in parallel. So let's come here and verify those things. So let's wait for the logs to display. And you can see it has already created desired change, create external DNS K8s service demo 101.stacksimplify.com in so and so hosted zone. So now 2 records in zone stacksimplify.com were successfully updated. So now let's go back here and go to the Route 53 and go to stacksimplify.com related hosted zone, and you should find the external DNS K8s service demo 101.stacksimplify.com. And you can copy this and come here and run the ns lookup and provide the DNS name, and it is resolving to the IP address. So let's wait for this thing like it to come in service. So now it is in service. 2 out of 2 instances are in service. So now let's access this in the browser with this DNS name. So what is the DNS name? So this is the DNS name we have used. So let's take this and put it here and we are using the app1/index.html. So that is what, right? If you see here, ns lookup is done, and this is the DNS name /app1/index.html, and this is a HTTP URL, right? So simple thing, and your app1 is accessible. So which means we have used the external DNS with the Kubernetes service and it is successful. So now we can go ahead and then delete the kube manifest here. So I'll say kubectl delete -f kube manifest, and once it is deleted, we'll go ahead and also verify our external DNS logs here. So let me go here and get the external DNS logs related command, and let's run this command and wait for the logs. So automatically it need to delete the DNS record whatever it has created. So here you have seen the create related message. So let's wait for the delete related message now. We can see here we got the message delete external DNS, so and so, and 2 records in zone got updated now. So let's go back here to stacksimplify.com, and you should see there is no external DNS related DNS entry inside this, which we have created just now. And also verify if our load balancer, classic load balancer, got deleted successfully, right? So this completes the demo related to using external DNS for Kubernetes service. So I'll see you in the next demo. Until then, bye bye. Thank you. Welcome back. In this section, we are going to implement another important ingress concept called name-based virtual host or host header-based routing. And we are going to implement this concept on AWS application load balancer. So let's understand the network design for the same thing. As usual, we are going to use our 3 applications, app1, app2 and app3. So their 3 Kubernetes deployments and node port services are going to be as is. And in the ingress is the core thing. Inside ingress, we are going to make the changes for our rules. So we are going to define rules with host header based routing. So we are going to define 2 rules. One is app1.stacksimplify.com, which means when host equal to app1.stacksimplify.com, route the request to app1 node port service. From there it will go to that respective pod. And when the host equal to app2.stacksimplify.com, go to app2 node port service, and from there it will go to equivalent app2 pod. And for default.stacksimplify.com, and this is not a rule, so this is directly we will define this related to default backend with external DNS related annotation, and anything you access with default.stacksimplify.com, so it will go to app3 node port service, and from there it will go to app3 deployment related pod. So now next thing here is whenever you deploy this ingress resource, right? So when you define these host rules app1.stacksimplify.com, app2.stacksimplify.com, and whenever you deploy this ingress rules, and already if you have the external DNS related pods running in your EKS cluster, so then it is going to DNS register those domain names whatever you have specified in host also, in addition to whatever you have specified in your external DNS related annotation. So which means in the host rules also you have specified app1.stacksimplify.com and app2.stacksimplify.com. So these two also will get DNS registered in your Route 53 using external DNS. And whenever user accesses app1.stacksimplify.com/app1/index.html, so the request will come to our ingress and then go to the app1 node port service and that respective pod. In same line, whenever user accesses app2, so it comes to app2 related rule in ingress load balancer, and from there it will go to app2 node port service and reach the app2 related nginx pod. And whenever user accesses with default.stacksimplify.com, so request will go to the default backend. So this is called the host header based routing or name based virtual host routing in ingress. And let's see the templates how it is going to look for us. So these are the rules whatever we have discussed so far. So earlier the rules used to start with HTTP, and under HTTP you used to have paths, and you can define multiple paths. That is called context path based routing. And for host header based routing, so it will start with the host, and you will define your host whatever you want. Here we have defined app101.stacksimplify.com, and under that with root context whatever comes, go to app1 nginx node port service. So request with app101.stacksimplify.com will go to app1 node port service, and in same line for the requests with app201.stacksimplify.com, right, it goes to app2 nginx node port service. So these two are the rules we are going to have with this name based virtual host routing. And in addition to that, for the default backend you are seeing here, right, so for the default backend we can directly use our external DNS related annotation, wherein with the default 101.stacksimplify.com goes to our default backend, which is app3 node port service. So this completes the introductory part of Kubernetes Ingress name based virtual host routing or host header routing. In our next lecture we are going to go ahead and then practically implement this use case. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's go to our GitHub repository, and we are in section 0809 name based virtual host routing. And as part of introductory section, we already understood about what is this name based virtual host routing in Ingress. So as part of step 2, we are going to review the Ingress manifest for host header routing or name based virtual host routing. So let's go to our Visual Studio Code, and we are in section 0809 name based virtual host routing, and inside that we are in kube manifest folder. And 01, 02, 03 are going to be same from our previous sections, which is app1 deployment and node port service, app2 deployment and node port service, and app3 deployment and node port service. So this is 04 ALB Ingress host header routing. And inside this, so as usual, we will change the name of the Ingress service, which is Ingress name based virtual host demo, and the load balancer name also we will give name based vhost ingress, something like this, whatever relevant name for us when we run the kubectl get ingress. So we'll know the exact demo ingress service. And as usual, in your demo you need to ensure that your certificate ARN should be updated here. And when coming to external DNS related hostname related annotation, so I have provided default 101.stacksimplify.com for our default backend, which is app3 nginx node port service. And so if we go down here, these are the important things. So the default thing is completed here, and now we'll move on to the core rules. And under rules you have something called host, and in host you have defined app101.stacksimplify.com with root context anything comes app101.stacksimplify.com / it should go to app1 nginx node port service, and with app201.stacksimplify.com anything comes with the root context, then it should go to app2 nginx node port service. So these are the rules related to host header based routing or name based virtual host routing, which we have defined here. So now let's go back here and go to step 3, which is deploy all these kube manifests and then verify. So let's come back to our terminal here and enter into the section 08 new, which is new ELB application load balancers, and inside that we are entering into the section 0809 name based virtual host routing. And if we say here kube manifest ls-lrta kube manifest, so you will find all the 4 files. In the 4th file is 04 ALB ingress host header routing.yaml. So I'll clear this and run kubectl apply -f kube manifest, and this should create the app1 deployment and node port service, same for app2 and then app3. After that it should also create the ingress service for us, which is related to ingress name based virtual host demo. So let's say kubectl get pods, and it should display all the 3 pods for us, app1, app2 and app3. Those are running. And we'll also say kubectl get svc, and you can see here all the app1, app2 and app3 related node port services also created. And now we'll go to kubectl get ingress, right? And in get ingress you should see ingress name based virtual host demo, and in the hosts here you can see app101.stacksimplify.com and app201.stacksimplify.com. So for this ingress, in the hosts area you can see it has automatically updated its values. So whatever you have defined as hosts here, so which is this one and this one. In addition to that, you have the standard name based virtual host related ALB core DNS name, right, which is elb.amazonaws.com. So now let's go back here and also verify your load balancer listeners, rules and targets. And before that, also verify the external DNS logs. So let's wait for the logs to display, and these logs should show us that it is going to create 3 things for us. So let's wait. See, it is going to create a desired change saying app101.stacksimplify.com is added in the hosted zone as a record, and app201 also added, and default 101 also added. So total these 3 records were added successfully in our Route 53. Also verify that. So we'll go here and go to Route 53 and first verify the DNS records. After that we'll come back to load balancer and verify additional details. So let's go to hosted zones, and we need to go to the hosted zone stacksimplify.com, and in stacksimplify.com, so we can see here default 101 created, and in the same way app 101 and app 201 also created, and all those things will reference to the ingress service, right? So whatever it is created, so ingress service name based virtual host ingress service with some number 5299 starting with. So if you see here kubectl get ingress, so its name is name based virtual host ingress 5299 something, and we'll go back and also go to our load balancer here in EC2 in load balancers. So we will go ahead and then open this and go to listeners. So this load balancer is in active state, so we'll go to listeners here, and this is the default port 80 listener, which will directly redirect from 80 to 443, because we in our ingress we already have this SSL redirect related setting in the annotations of our ingress, and now we will see the 443 related rules here. And if you see here, you can see when your host is app101.stacksimplify.com, go to app1 nginx related target group, and if it is app201, go to app2 nginx target group. Anything default, go to app3. So now let's come back here and go to the target groups and see if they are healthy, right? So now let's refresh, and you can see app1, app2 and then app3. So app1, if you see, those were healthy, and if you go to app2, so those also should be healthy. And these target groups, you can see your EKS worker nodes were registered with node port services. So node port related information, with that the worker node related instances were registered here. So now let's come back, right, and verify the NS lookup. So the next step here is to access application using newly registered DNS name. So the first thing is verify with the NS lookup command. So let's come back here and do a NS lookup, and it is resolving to IP addresses, and this one also we will try, and it is resolving to IP addresses app101 also. and app201 also it is resolving to the IP addresses. IP addresses are going to be same here, and if you want you can also verify the DNS for your ingress related default DNS name, which is this one, right? So ns lookup and also provide the this one, and for all these things you can see the IP addresses are same. So now let's come back here and access your application. So app1 you are going to access with app101.stacksimplify.com, and see this is accessible, and app2 you are going to access with app201.stacksimplify.com. see app2 is accessible, and default application you are going to access with default 101.stacksimplify.com, and you can see default Kubernetes fundamental demo related application is accessible for us. And negative case is with app101 try to access app2 index.html and see what happens. So let's close these things, right, and access this, and 404. Why? Because in app101, which is nothing but your app1 node port service and app1 backend, you are proxying the complete root context, right? So which means in app101 or in app1 there is no app2 related context path with index.html. So from your app1 backend, right? So from your app1 backend you have got a 404 request when you accessed app1.stacksimplify.com with /app2 in the same line. So let's come back here and try for app2 also. App2 try with app1 and it should fail here also. Why? Because in app2 related pod you don't have any app1 related concept or context path, you can say simply. And now if you want you can also try with default 101 /app1 index.html and app2 index.html. see, and this is also failing. So everywhere it is the same thing. Only with this domain you can go to app2, and with this domain you can go to app1, and with this domain you can go to default pod as of now whatever we have configured. See, all these things are not working. So this completes the name based virtual host routing or host header based routing in Ingress. So now we are going to clean up whatever we have implemented. So let's come back here and we'll say kubectl delete -f kube manifest. So this should delete all the 3 application related deployments, node port services, and also the ingress service, and also the DNS records created. So to verify that we'll also put the log, right? So once those were deleted, we'll also let's verify the log now. So let me copy this and paste it here, and in external DNS log we should see all our 3 DNSs whatever registered in Route 53 should be in the delete state. So let's go down, it's opening the log. See, delete app101 and app201 and default 101. So now let's go back here and go to Route 53 and verify the same thing. So let me go here and go to stacksimplify.com, and you can see here there is no DNS related to app101 or app201 or default 101. So now let's come back here, and our ingress service whatever it has created the application load balancer also got deleted. So this completes the name based virtual host routing demo. And in our next lecture we are going to focus on SSL discovery related ingress concept. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section we are going to learn about the Kubernetes ingress concept, SSL discovery with host and TLS. So we are going to implement 2 demos as part of this concept. So now let's go and understand what exactly is this SSL certificate discovery, right? So if you see here, this is SSL certificate discovery using host. So if you see in the rules, earlier we have already implemented the host header based routing. So where you have seen the app101.stacksimplify.com and app201.stacksimplify.com were specified in the ingress rules with host as the argument. So here TLS certificates for ALB listeners can be automatically discovered with host names from ingress resources. So if the ALB ingress related certificate ARN is not specified. In simple terms, when you are using this host header based routing, right? So from these host values, you have given the DNS name here very clearly, app101.stacksimplify.com. So which means you really don't need to provide this certificate ARN related annotation and provide the ARN of your SSL certificate from your certificate manager. So by default, Ingress can directly take the available certificate for these names, which means if the name matches stacksimplify.com, so if you have something called star.stacksimplify.com, so that matches these domain names app101.stacksimplify.com and app201.stacksimplify.com. So automatically it will take that and then associate with your ingress service. So which is nothing but it will associate with your application load balancer. We explicitly don't need to define this certificate ARN annotation. So which is a very good thing that we don't need to go to our certificate manager and go to that respective certificate and get the ARN and hard code that ARN in the ingress service. We don't need to do all those tasks. So automatically it is going to take it with this SSL discovery with host option whenever you are using the host based rules. In addition to that, any other rules, not the host based rules, you are doing the context path based routing, right? So at that point of time, or you are using only a default backend or something. So at that point of time, so it can also use something called a TLS field. So in the next demo, we are going to see the TLS field related demo. So the controller will attempt to discover TLS certificates from the TLS field in the ingress and host field in the ingress rules. So this part you have seen, host field in the ingress rules, you already seen here. And in the next demo, we are going to, in the next slide, we are going to see the TLS field related thing too. And another important note here is you need to explicitly specify to use HTTPS listener with listen ports annotation. And anyway, we are going to do that. And we have already seen in our ingress resources also. So you can see we are already specifying the listen ports 443 for our SSL communication. So we have no issues with this important note. So now let's come back to this demo 2, which is SSL discovery with TLS. So here if you see your DNS name you have provided as sat discovery TLS 901.stacksimplify.com. You have something called your default backend, and here there is no host rules here. This is simple context path based routing related example, right? So at that point when you are using other than host, and then if you want to auto detect your SSL certificate and associate with your ingress service, which means it need to associate with your application load balancer, you can also use this TLS option and provide with TLS hosts and provide your host names here star.stacksimplify.com. So automatically this related certificate will be associated with your ingress resource or service. Which means whenever we are implementing these SSL certificate discovery in ingress using host or TLS options, we really don't need to have this annotation enabled. So you can go ahead and then comment this certificate ARN related annotation in your both demos. So this completes the introductory part of SSL discovery using host and TLS in ingress. In our next demo, in our next lecture, we are going to practically go ahead and then implement these things. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. Let's go to our GitHub repository and implement the demo 1 related to SSL discovery host. So we need to go here and we are in 08 new ELB application load balancers, and we are in 0810, right? Ingress SSL discovery host. And if you see here, as part of step 1, we already understood about what we are going to implement. So we are going to go to this respective ingress manifest and just comment this certificate ARN related annotation. So this annotation will be commented, and rest all is going to be as is from our previous section. And additionally, we are also going to change the DNS names a little bit so that we don't face any Route 53 caching issues. So let's go back to our Visual Studio Code here and go to the section 0810. And these cube manifests are a copy of the previous section, which is 0809 name-based virtual host routing. And as usual, we have the app 1, app 2, app 3 deployment and node port services. No changes in them. So here you will have something called, the name of your ingress service is going to be ingress sat discovery host demo. You can see here sat discovery host ingress. And now if you come down here, so this certificate ARN related annotation is commented here. So earlier it used to be this way, and now we have commented it. And rest all is going to be as is, but only thing is, earlier you have seen default 101, now you will see default 102. And here also you will see app 102 and app 202. So this is to avoid any Route 53 related cache issues, because that demo we implemented just now and deleted them, right? The previous demo. And now immediately we are implementing this demo. So if we use the same DNS names, sometimes due to Route 53 cache issues, you will not be able to access your application. So that's the reason we changed the naming convention a little bit. But as part of this SSL discovery host option, right? So whatever the host present here, it is using some domain name.stacksimplify.com and some domain name.stacksimplify.com. So it need to automatically associate the star.stacksimplify.com SSL certificate from certificate manager to our application load balancer whenever we deploy these manifests, right? So this is 04 ALB ingress certificate discovery host. So let's come here, and the next step here is, right? So the next step for us is to go ahead and then deploy these manifests and then test it. So we'll come out of 0809 and we'll enter into 0810, right? So 10, which is ingress SSL discovery host, and we'll say kubectl apply -f kube manifest, and let's wait for the Kubernetes to deploy these applications, which is app 1, app 2, app 3 deployment and node port service, and also ingress sat discovery host related ingress service. So as usual, we can verify get pods, and app 1, app 2, app 3 should be running, and we'll also see the SVC, which is services. Our 3 node port services should be created, and we'll also verify the ingress service, right? And our ingress service also displayed here. The important thing for this demo is to verify you didn't mention any certificate ARN annotation in your ingress service related Kubernetes manifest. And what we need to do, so we just need to go to our EC2 here and go to load balancers. In this sat discovery host ingress related load balancer, so we need to go to listeners, and you need to verify the certificate associated with it. See, this is the one, right? For the 443 listener port, UR edit certificate. So you can see it has successfully associated the star.stacksimplify.com related certificate. So which, if you want, you can go to ACM and also cross check the certificate. So which clearly states that without mentioning the certificate ARN related annotation with the SSL discovery host option, by default automatically it can check for that certificate present in certificate manager and associate for our application load balancer automatically from our ingress service, right? So now let's come back here. So we have successfully verified this thing, And if you want, you can also verify the logs. So again, these steps are same as our name-based virtual hosting. And if you want, you can also access our application and then verify. So you can see here. So let's wait for all the logs to display, and you can see app 102, app 202 and default 102 DNS records also created. And if you want, we can also do a NS lookup test, and that looks good. So app 102, it looks good, and also app 202, and it also looks good. And if you want, you can also access these things from browser, right? So I'll close the certificate manager here, and you can see app 102 with app 1 is accessible, and in the same way we can go here, and app 202 we should access the app 2, and it is accessible, and we'll also access the default 102, right? So this should display the default application, which is Kubernetes fundamentals demo. Now let's come back and destroy these manifests or delete these manifests. So this completes the SSL discovery host related things. So without mentioning the certificate ARN, so automatically Ingress can automatically discover the SSL certificate and associate it to the application load balancer using this host value, whatever the DNS name associated here or the host name associated here. So in our next lecture, we are going to learn about the SSL discovery TLS option. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this demo, we are going to implement SSL discovery TLS option in Ingress service. So now let's go back to our GitHub repository, and we are in 08 new ELB application load balancers, and we are entering into the section 0811 Ingress SSL discovery TLS, right? So as part of introductory section, we already know what is host and TLS from SSL discovery concept perspective in Ingress. So now we are going to go ahead and then review this Ingress manifest. So let's go back to our Visual Studio Code and enter into the section 0811 Kube manifest, and 010203 app 1, app 2, app 3 deployment node ports and node port services are going to be as is from our previous section. And if you come back here, right, 04, the name of this respective Ingress service is going to be Ingress Cert Discovery TLS demo, and here also the load balancer name is Cert Discovery TLS Ingress. And here, as usual, as part of previous demo also, we have commented the certificate ARN because we are testing the SSL discovery concept here. So we need to comment this, and if you come back here, the external DNS related host name is going to be, the DNS name is going to be Cert Discovery TLS 101.stacksimplify.com, and the rules, we are using the context path based rules here. So when the request comes with /app1, go to app1 nginx node port service, and when it comes to /app2, go to app2 nginx node port service, and default backend is app3 nginx node port service. So all these things you are going to access using the DNS hostname Cert Discovery TLS 101.stacksimplify.com. But as you have not specified the certificate ARN here, so automatically how it need to associate the SSL certificate is using this option. So TLS and hosts is a list item, and you can define multiple things here if you want, right? So but here we have the star.stacksimplify.com is associated here now. So automatically our stacksimplify.com related SSL certificate, which is wildcard certificate we have created, is going to be associated to this Ingress service. So let's go back here and deploy these manifests and then test it. So let's go to 0811 Ingress SSL discovery TLS and say kubectl apply -f kube manifest. So this should create the app 1, app 2, app 3 node port and deployments for those applications, and also create a Ingress Cert Discovery TLS demo Ingress service. So I'll run the command kubectl get pods and services just to check those were created or not. And also SVC. And you can see app 1, app 2, app 3 Nginx pods are running, and also equivalent node port services created. And I'll say kubectl get ingress to verify our ingress service got created. And you can see sat discovery TLS, this is the address of our ingress service, and it is also listening on ports 80 and then 443, and it belongs to the ingress class, my AWS ingress class. So now let's come back here and verify the same thing with certificate. So let's come back and sat discovery TLS ingress, and we need to go to our HTTPS 443 listener and verify if our certificate is associated successfully. star.stacksimplify.com is associated successfully to our application load balancer. So which means the demo whatever we are implementing, SSL discovery using TLS option in ingress service should associate the SSL certificate from the certificate manager whatever we have created to the application load balancer, right? And it is successfully associated. So let me close these things, right? And let's come back here. And if we want, we can also do a NS lookup test for our cert discovery TLS 101 related DNS. And what is the DNS we have used here? 101. So this is the one, right? So sometimes this is the problem with the thing. NS lookup, and you can see can't find cert discovery TLS, no answer. Why? Maybe let's verify the logs here and also verify the route 53 here, right? So let's go out and go to the hosted zone stacksimplify.com, and you can see cert discovery is created. So this is the problem. Usually sometimes we face this, so that's the reason I usually give different names. So I'll put 102 and kubectl apply -f kube manifest, and let's see what happens. And we'll go here. We have changed the DNS name from 101 to 102, maybe some route 53 caching issues. So I'll try to do a NS lookup now. So 101 is deleted and automatically 102 is created. So now let's copy this and do a NS lookup and then see what happens, right? And this is resolving. So this is what is the thing. Usually I always put the different name whenever I am testing it for the demos, right? So now let's come back here and access it in the browser. Cert discovery TLS 102.stacksimplify.com/app1.index.html. So it should automatically redirect to HTTPS, right? So the log symbol you can see, right? And if you go here and see the certificate, so star.stacksimplify.com certificate is associated here. And we'll also check the app2, right? app2/index.html, and we'll also verify the root context. See, lock is present here, automatically redirected to SSL, and we'll also verify the root context, and app3 is also successful. So app1, app2 and our app3, all three are successful. And we'll go ahead and then clean up these things. So kubectl delete -f and kube manifest. So this should clean up all the things whatever we have created. So now let's go back here and verify if our ingress service is deleted, and it is deleted. Now let's go to route 53 and verify if our hosted zone related to cert discovery TLS 102 is deleted, and it's still waiting. So let's wait for it to delete, or we can also go back here and verify the logs. So let's come up here and go to terminal and verify the cert discovery related external DNS. We can see here cert discovery TLS 102 is deleted. So we can go here and then cross check the same thing in route 53. So go to hosted zones and go to stacksimplify.com and go down, and you will not find any cert discovery TLS 102 related DNS. So this completes the SSL cert discovery related both demos, which is host and then TLS. So in our next section, we are going to understand about one more ingress concept. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section, we are going to learn about ingress groups and also implement a practical demo for ingress groups. So without ingress groups, we used to define our configurations in a single ingress resource. So let's understand what is the drawbacks of not using ingress groups in a larger configurations. So example, like in our current use cases, we have app 1, app 2 and then app 3 applications, and we have their own deployment and then node port service Kubernetes manifest. And for all these three apps, we used to have a single ingress resource. Maybe my apps is the ingress resource name, and for these three apps, the routing rules we have defined in a single file. So single ingress resource for all three apps we have created so far. And any changes to any of these apps, you need to go into that respective ingress resource. For all the three apps, you have only one ingress resource, and you need to go inside that ingress resource, update that, and then deploy those changes. And the important thing here is, if you have three apps, it is fine. But if we have 50 apps or 100 apps, and all these 100 apps needs different rules embedded in your application load balancer, and those rules need to be managed in a single ingress Kubernetes manifest. So if that is the case, then maintaining that single file becomes tedious and also confusing. So the ingress groups concepts helps us in segregating the config in different files with the different ingress resource names, but you can merge them together to create a single application load balancer. So with ingress groups, we can simplify our Kubernetes ingress manifest when dealing with multiple apps requiring a single application load balancer. So with ingress groups, what happens is, so you can see you have app 1, app 2 and app 3 related deployment and node port service related Kubernetes manifest. So for app 1, you will create the app 1 ingress resource, and you will define the app 1 related rules only inside that. And for app 2, you will define the app 2 ingress resource, and you will define the app 2 related rules inside that. And for app 3 also, you will do the same thing. So these three are three different Kubernetes manifests. And now all together, right, using the ingress groups concept and using the ingress group annotation, so you will group them together with my apps dot whatever the name you want. So these ingress resources from web or whatever it is, right? So I just gave the name as my apps dot web for my group. So which means I'm going to have a ingress group annotation in ingress service app 1 ingress, app 2 ingress and app 3 ingress, and I'm going to say all these three ingress belong to my apps.web ingress group. And in addition to that, I am also going to define the priority for these ingress rules. So I'm going to say app 1 ingress is going to have priority 10, app 2 ingress is going to have priority 20, and app 3 is going to have priority 30. So at this point, what happens is, in the application load balancer, it is going to put the rules in that same order. And in addition to that, so you are calling from application load balancer perspective this as a priority. But from ingress perspective, you call it as ingress group order, right? So you need to define the ingress group order as 10, ingress group order as 20, and ingress group order as 30. And in ALB terms, you call it as a rule priority number. And if you see here, so the ingress load balancer name for all these three things is going to be same, ingress groups demo. So which means this load balancer name related annotation will be there in all three files, and you will have the name as ingress groups demo. But the name of your ingress service, right, in the metadata you provide the name, right? So that can be app1 ingress or app2 ingress or app3 ingress, whatever, based on your ingress service name. But all these things will be connected to a single load balancer, which is ingress groups demo. And all these three things will have a same ingress group, which is myapps.web. So now let's move on to next thing. So let's understand a little bit theory. Ingress group feature enables you to group multiple ingress resources together. So the controller will automatically merge ingress rules for all ingresses within ingress group and support them with a single application load balancer. And very important note here is, in addition, most annotations defined on an ingress only applies to the paths defined by that ingress. And finally, so this is the sample. So for the ingress groups, you are going to use the group.name and also group.order. In every ingress resource, you are going to add these two annotations and provide that ingress resource belongs to which group and also what is the priority of that ingress resource. So in our case, in 0812 ingress group section, we are in Kubernetes-Manifest, we are going to have app1 folder, app2 folder and app3 folder. And in app1 folder, you will have the 01 nginx app1 deployment and node port service, and it's 02 app1 ingress.yaml. Same for app2, 01 nginx app2 deployment and node port service and 02 app2 ingress. So in app1 ingress, you will have only app1 related rules, and in app2 ingress, you will have only app2 related rules, and in app3 you will have only app3 related rules. So 3 ingress Kubernetes manifest creates 3 ingress resources in Kubernetes, and all 3 will be merged to create a single AWS application load balancer. That's what is the core concept here. This completes the introductory part of ingress groups. In our next lecture, we are going to go ahead and then review these Kube manifests and then practically implement the use case. So I'll see you in the next lecture. Until then, bye. Thank you. Welcome back. Let's go to the GitHub repository now and go into the section 0812 ingress groups. And in ingress groups, as part of introductory section, we already understood what we are going to implement as part of this section. So let's go to step 2, which is review app1 ingress manifest. So let's go back to our Visual Studio Code here, and in 0812 in ingress groups, you have a Kube manifest folder, and inside that you have app1, app2 and then app3. So we'll start with app1, and in app1, 01 nginx app1 deployment and node port service. So no changes in this, as usual from the previous sections. And for 02 app1 ingress, right? So if you see here in 02 app1 ingress, the first thing changes name of my ingress resource. It is app1 ingress, and my load balancer name is going to be ingress groups demo. And now let's come down here, and these are the ingress groups we are going to define. So 2 annotations for ingress group, which is group.name and group.order. And in the group.name, we are giving the myapps.web, and group.order I am giving the 10 as the number. And I am only providing one rule here, which is /app1. So in this ingress, I have only one rule. But in this app1 application, you have 100 rules. So define all your 100 rules related to your application and implement them here, right? So this is only for my app1. And now let's go to app2. And no changes in app2 deployment and node port service. As usual, the same content. And for 02 app2 ingress, so if you see here on the top, so the name of my ingress resource is app2 ingress. But the load balancer name, as usual, it is the same thing from app1 ingress also, ingress groups demo. Why? Because it is going to create a single application load balancer for us, and its name is going to be ingress groups demo. And all these things you need to group with group name, ingress group name, myapps.web. And this is a app2, and its rule priority is port 20. And you have the path as /app2 for this respective application, which goes to app2 nginx node port service. And now let's go to app3 here. And 01 nginx app3 deployment and node port service, no changes in it. We'll leave as is, and we'll go to app3 here. And you see the name is app3 ingress, and ALB ingress load balancer name same as previous app1 and app2, which is ingress groups demo, and this also belongs to my apps.web ingress group, and the group order is 30, and here you have the default backend. So now let's go back here and go to the next step, which is deploy apps with these two or three ingress resources and then verify. So this should be 3, so that's fine. So kubectl apply -r -f. So what this -R does is, so whatever the subfolders present in kube manifest, right? So kube manifest present inside the folders of kube manifest also will be deployed, which means all these subfolders app1, app2, app3. So recursive folders, whatever is there, from them also the Kubernetes YAML files will be deployed. So let's go to the terminal here and go into the section 0812. So we are in 08 new ELB application load balancers, and we are into CD 0812 ingress groups. And I'm going to say kubectl apply -f and -r, and I'm going to provide the kube manifest. Or you can just say, this is one way of doing it, or you can remove kubectl apply -f kube manifest app1, and once this is deployed app2, and that is deployed after that app3. So like this also you can try. So we will go with kubectl apply -f and -r kube manifest, so that all the things will be deployed. So we'll start with kubectl apply -r -f kube manifest. What happened? Space kubectl space apply -r -f kube manifest. Good. So this should deploy all the things for us. So now let's go back here, and for all these things, another common thing you can see here is external DNS name. So ingress groups demo 601stacksimplify.com in app1 ingress, and in app2 ingress also you will see the same name, right? In app3 ingress also you can see it's the same name. So now let's come out of this, right? Minimize these things, close, and come back here to the terminal, and you can see app1, app2, app3 related deployment and node port service created, and also app1, app2 and app3, app1 ingress created, app2 ingress created, and app3 ingress created. So now if you say kubectl get pods, should say that all app1, app2, app3 pods you can see here running, and also you can see the services app1, app2, app3 node port services also you can see. Let's clear this. Now the important thing is, very important command is kubectl get ingress, and under this whatever you see is the very important thing. So it has created 3 resources, app1 ingress, app2 ingress, and app3 ingress. So it created 3 ingress resources, but if you see here, it is referencing to a single, right? Single address here, ingress groups demo 163610478. So this is same for all 3 things, which means it is referencing to a single application load balancer. So now let's come back here and verify. So we have verified 3 ingresses resources will be created with same address value. We have verified that. So 3 ingress resources are merged to create a single application load balancer. So now go to the load balancer and verify the same thing. So we'll refresh here in the EC2 load balancer section, and now if you see ingress groups demo, a single load balancer is created and it is currently in the provisioning state. So let's wait for it to provision, and in meantime we can go here and verify our external DNS, whatever it has registered here. So it should be something related to ingress groups demo 601.stacksimplify.com. So that is good. So I can copy this and I can come back here and verify the NS lookup for that, right? And it is authoritative, so it is working. So now let me clear this and wait for the load balancer to be in the active state. So we can see here our load balancer is in active state. We'll go to listeners and we'll go to the 443 related listeners and then click on view or edit rules. So you can see it has created a rule 1 which is /app1. so which goes to the default app1 Nginx related node port service, which is nothing but it created a target group app1 Nginx related. And for app2, it is app2 Nginx related target group created. And default backend, it is going to app3 Nginx. So all three rules created with priority 1, 2, and this one is at the last. And now let's come back here, and if you want, we can go and then access the same thing via browser. So we are just implemented the ingress groups concept, and we have created 3 ingress resources, and from 3 ingress resources also all those things, right, get ingress, and all those things merge it together to create a single application load balancer, and we are testing that if it is going to work as expected or not. So we accessed ingress groups demo 601.stacksimplify.com. app1 is accessible, and we'll also access app2, and also app2 is accessible, and finally we'll access the default one, which is Kubernetes fundamentals demo application version v1. So all 3 apps are accessible, and our ingress groups demo is successful. So let's go there and then clean up the stuff now. So I'll say kubectl delete -r-f kube manifest. So all app1, app2, and then app3 related Kubernetes manifest will be undeployed. So let's wait for it to undeploy. We can see here all the resources got deleted. So let's go back here and refresh, and our ingress resources should go away, and also we'll see the hosted zone stacksimplify.com, and anything related to ingress groups demo is not present now. So this completes the ingress groups demo. I'll see you in the next section with another ingress concept. Until then, bye bye. Thank you. Welcome back. In this section, we are going to learn about Kubernetes ingress concept name target type equal to IP. So let's understand what is ALB ingress Kubernetes target type annotation first. So this target type annotation specifies how to route traffic to your pods, which is nothing but your Kubernetes pods, from your application load balancer. And we have 2 ways to do that in our ALB ingress target types. One is instance mode and another one is IP mode. And let's understand the instance mode first, and then we will move to the IP mode. So instance mode will route traffic to all EC2 instances within cluster on node port opened for your service. So which means, if you remember our previous examples also, we have created a app1, app2, app3 deployment, and we also created a app1, app2, app3 node port service. So the request coming to your application load balancer will go to that Kubernetes node port service, and from that Kubernetes node port service, it is going to your application pod. And this Kubernetes node port service will have your worker node IP : port from your that respective node. And this service must be of type node port or load balancer to use the instance mode. That's clear. We have implemented the node port service for our previous examples. And default target type is instance mode in our ingress resources. So which means we don't need to define this annotation in ingress. By default, it takes instance mode. So if you see our ingress templates defined previous to this demo, so nowhere we have defined ALB ingress Kubernetes IO target type instance. So why we don't need to define that? Because the default target type is instance mode and we don't need to define this. Now let's understand what is this target type IP mode. IP mode will route traffic directly to the pod, which means when the request comes from the internet to your application load balancer, so from there the request will directly go to your Kubernetes pod. So there is no middleman like Kubernetes node port service involved here. And IP mode is required for sticky sessions to work with application load balancer. So that is the core reason for implementing the IP mode when you are using the EC2 worker nodes. But when you are using the Fargate, definitely you only need to use IP mode. And when we are implementing or learning the Fargate concepts, we'll also know more about IP mode there. And also their only option for you whenever if you want to use AWS Fargate serverless, at that point of time, you need to use IP mode only. And need to define the annotation explicitly as target type equal to IP. This completes the introductory part of target type equal to IP. So in our next lecture, we are going to practically implement this concept and understand about it. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. Let's go to our GitHub repository, and we are in 08 new ELB application load balancers section, and we are entering into the section here 0813 ingress target type IP. So as part of the introductory section, we already understood about what is a target type and what is instance mode and then IP mode. So now we are moving on to step 02, which is ingress manifest. So let's go back here to Visual Studio Code, and we are in 0813 ingress target type IP, and we are entering into the section kube manifest folder, right? And inside that you can see 01 Nginx app1, app2 and app3 deployment, and you see here the cluster IP service instead of the node port service. So we'll discuss that. First we'll go back here and then complete our 04 ALB ingress target type IP and come back here. So now let's go here, and if you see, the name of my ingress service is going to be ingress target type IP demo, and the load balancer name is target type IP ingress. And now if you see here, I also commented the certificate ARN here and ensured that I added the TLS host star.stacksimplify.com, so that you really don't need to hard code your certificate ARN here. So this we already learned about the SSL discovery TLS demo. There we already learned it. And another important thing here is, so if your domain name is different for your certificate, it might be some yourdomain.com. So that domain name you need to provide here for your certificates, or you can comment this part and then enable the certificate ARN related annotation and provide your certificate ARN here. Anything is fine. And if you see, this is a simple context path based routing use case wherein you have the /app1 rules and /app2 rules and also default backend, wherein default backend goes to app3 and /app1 goes to app1 and /app2 goes to app2 related Nginx cluster IP services. Okay, so app1 go to app1 Nginx cluster IP service, app2 go to app2 Nginx cluster IP service, and app3 go to app3 Nginx cluster IP service. And if you see here, target type is IP. So this is the core thing which we need to define in this respective use case. So you have provided the target type as IP mode here. So now let's come back and understand why we defined cluster IP service, right? So there is no specific reason. So you can have it as node port or cluster IP. So both are same. Just want to show you that we really don't need to open our or use the node port here. Why? Because the request coming to our application load balancer will directly go to this pod IP created as part of this respective deployment. So which means even though if you open the node related port, it is of no use. So if that is the case, then we can use the cluster IP, right? And now here comes another question. So if the request coming to my load balancer is directly going to this respective pod created by this deployment, so then why do I need a service itself? That's a different thing here. You need service to have the ingress created target group and register the targets inside that. So which means the core concept here is either the ingress of either the service of type node port or cluster IP you need to definitely define. So then only ingress can create a target group in your application load balancer. And this is of your choice. If you want to use node port, that is fine for this use case also, instance type IP mode. So in our forget we have used node port only. Just for an additional option, so just to test, I have used cluster IP and it works without any issues. So all the naming conventions instead of node port has been changed for all these three services to cluster IP. And all the custom changes, which means like per service any custom related changes like health check paths or any other settings, so you can provide in this respective service related annotation. So like if you see app3 health check path is /index.html and app2 is /app2index.html and app1 is /app1index.html. So it is the same context path based routing use case, but here instead of node port service, you are using the cluster IP service and providing those names inside this ALB ingress target type. So you can use node port service also, no issues. So whatever the service we use here, node port or cluster IP, the request comes to our load balancer, directly goes to our pod. How? Why? Because so as you have used it inside the ingress target type is IP, so it is going to register in the target types, right? In your application load balancer target types. So this setup is going to get the pod IP and then directly register that as your target inside your target group. So now let's go back here and deploy these things and then review those things and get to understand more about it by seeing it on the EC2 management console. So let's go to our terminal here, and we are in 08 new ELB application load balancers, and we will enter into the section 0813 ingress target type IP, and I'll say kubectl apply -f and kube manifest. So this should create the app1, app2, app3 deployments and app1, app2, app3 cluster IP services, and also should create the target type IP ingress service for us. So I'll say kubectl and I'll say get pods, should provide us the app1, app2, app3 pods for us, right? And I'll also say SVC services, and it should provide the cluster IP 3 cluster IP services it has created for us. And you can see the cluster IP IPs 10, 100, 99, 251, some IP addresses, just remember them, right? So now I'll also say kubectl get ingress, and it should create the ingress service for us, target type IP ingress. And now very important thing, I'll say kubectl get pods -o wide, and see the IP addresses of your pods here. So that's important thing. See, app1 pod is something like this 92.27, and app2 pod is 118.58, and app3 pod is 107.238. So we'll go to our application load balancer here first, right? So, and then I will refresh this, and application load balancer is provisioning. And if you go here, right, in and verify the rules here, right? See, app1 goes to app1 target group, app2 goes to app2 related target group, and default goes to app3 related target group. So rules are created, no issue. And you can also verify the certificate, star.stacksimplify.com certificate also associated, no issues. This is good. So now let's go to target groups. For this demo, the core checking we need to do is the target groups. Why? Because from the application load balancer, the request will directly go to the target group related pod IP, and that pod IP need to be present as a target inside these target groups. So let's first open this default app1 nginx related target group, and you can see total targets is 1. Still it is not healthy, it is registering currently. And if you see the value 192.168.92.27, so this is the app1 nginx related target group, and this is 92.27. So now let's go here, and if you see app1 nginx deployment related pod, so this is the pod and it is running, and its IP address is 192.168.92.27. So you can see in our application load balancer target groups, the target registered is directly the pod IP. So there is no indication of your service, the cluster IP service, whatever we have created here, right? So it's nothing. It's not there here. 10, 100 something, that is not there. So directly the pod IP is registered as a target in your application load balancer, and you can see that is healthy also now. So now app1 is done. So now let's go to app2 here, right? And app2, and it is healthy and it is registered and successful, and see the IP address 192.168.11.118.58. So you can see here it is the same thing. For the app2, you are seeing 192.168.118.58 matching with your pod IP. You said kubectl get pods -o wide, and verifying your pod IP is matching with your target type, whatever the targets registered in your target groups of your application load balancer. So now let's go to the default app3 nginx, right? here you see 107.238 and it is healthy. So let's compare here, it is 107.238. So now we have successfully verified the target groups which contains the pod IPs instead of worker node IP with node ports. So now the next thing is, we really don't need to do all these DNS logs checkings. Earlier we have already seen those things. So we will come back here and do the NS lookup and target type related thing. And you can see the DNS is successful. So we can access this application via browser and then test it. So here there is a space. I need to remove that. So I'll remove that. See, this space I will remove, and you can see target type IP 501stacksimplify.com. It is accessible. And we'll also access app2, and here some space is there. Let me remove, and app2 is accessible. So the request is going from our application load balancer directly to our pod IP. And this is the third application. So let's also access that app3, right? And it is also successful. And this completes the demonstration of ingress concept target type equal to IP mode. So let's go ahead and then delete these things. kubectl delete -f kube manifest. So as usual, this should destroy our app1, app2, app3 deployment, cluster IP service, and also our ingress service. So in our next lecture or in our next section, we are going to focus on ingress internal load balancer concept. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section, we are going to create the internal application load balancer using Kubernetes ingress manifest. To do so, we are going to use the scheme annotation as internal. So if you remember, so for the internet facing related load balancer to create, we have provided the scheme as internet facing. So now we will comment that part and add the scheme as internal so that it will create the ingress ALB internal load balancer. And to test this internal load balancer, right? So we cannot connect to internal LB directly from internet to test it. So to do that, we will deploy a curl pod in EKS cluster. So we can connect to curl pod in EKS cluster and test the internal LB endpoint using this curl command. And these are the series of commands we are going to use for curl testing. So first we will deploy the curl pod, and using the kubectl exec command, we will connect to that respective curl pod, and from curl pod we will be able to run the curl commands. So we will run the curl command for our default backend related use case, and also for app1 curl test and also app2 curl test we are going to run it. In the next lecture, we are going to practically implement this and test it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's go to our GitHub repository, and we are in 08 new ELB application load balancers, and we are entering into the section 0814 ingress internal ALB. And inside that you will find two folders. One is kube manifest and kube manifest curl, which is nothing but we are going to deploy the curl pod, and curl pod related kube manifest we have put it separate. So as part of introductory section, we already understood about we are going to create an internal application load balancer using Kubernetes ingress manifest and also test it with the curl pod. So we'll go to our Visual Studio Code and review the Kubernetes manifest. So let's go back to our Visual Studio Code here, and we are in 0814 ingress internal LB. And if you see the kube manifest, so 01, 02, 03, you will have the app1, app2, app3 deployment and node port services. And 04, you will have the ALB ingress internal LB. So the name of the ingress resource is going to be ingress internal LB demo, and name of the load balancer is going to be ingress internal LB. And if you see here, we don't have any other things. This is a plain context path based routing use case which we have taken from that demo. So there is no SSL and there is nothing else. So we have added the create internal application load balancer. So we commented the internet facing scheme and then we have added internal. And these are health check settings. That's all, right? So there is nothing else. Very simple. Load balancer name and the scheme is internal, and health check settings and then ingress class name, and as usual the default backend for app3 Nginx node port service, and for app1 it is going to be /app1 related rules, and for /app2 related rules. So now let's also review the curl pod ones, right? So in the curl pod, this is just, it is going to directly create a pod for us. See, API version of kind pod, and it is going to create a curl pod for us. So it will download the curl pod and run it. So now let's come back here and go back to our GitHub repository and go ahead and then deploy the kube manifest. So we'll say here 0, 8 and 14 ingress internal load balancer. So we already discussed about this. So whenever you have the scheme as internal, it is going to create the internal load balancer for us. So I'll say kubectl apply -f and kube manifest. So this should create the app1, app2, app3 application deployments and also the 3 node port services. In addition to that, it should create an ingress service with internal load balancer. So if I say kubectl get pods, Nginx pods 1, 2, 3 should be displayed here. And we'll also say kubectl get svc, and Nginx related app1, app2, app3 related node port services should be displayed. And now we will run the command kubectl get ingress, and you should see the ingress service created with internal. See, this is our ingress internal LB is the name, but also ingress ensured that it also appended with internal hyphen. So if you come back here and verify, your load balancer name is ingress internal LB. So only till here, right? But it also appended with internal hyphen to tell us that it is creating a internal load balancer for us for the address, right? So in this one, as usual, the name became same, ingress internal LB demo. So this is the one, right? So that is good. So now let's come back here, right? And verify the listeners and ports and all those things. So let's go to load balancers here. Ingress internal LB is getting created. And if you see on port 80, there is no 443 related annotations here, or any 443 related SSL annotations, and all those things were removed. It is a plain simple load balancer with port 80. And port 80 is a default setting. You really don't need to specify the listen ports for that. So now let's come back here and go to this view or edit rules for port 80, and you can see /app1 should go to app1 target group, app2 should go to app2 target group, and default should go to app3 target group. And also if you see here, this is the load balancer DNS name. So let's copy and do a NS lookup for that, right? So it should have a internal name, right? So 192.168.110.94, 192.168.77.250. So this is from internal cluster internal related subnet space, but not the external internet edge subnet space for us. So which means this one we cannot access it. So if I say curl, so it is not accessible for us from the internet. So that's about it. So now let's come back here, and if we want, we can also verify our target groups also. There is no change in node port service or deployments, so obviously those are going to be same, which means it will have the, if you take the app1 Nginx related target group, so 2 nodes were registered here with those respective node ports, and those are healthy, right? Why? Because we have used the node port service here, right? So the instance type or the target type is node port by default, so automatically all the worker nodes registered here. So now let's come back here and go to the curl pod to do the testing, right? So we have reviewed this. We'll go back here and then deploy the curl pod. So let's come back here and kubectl apply -f kube manifest curl. So this should create the curl pod for us. So it has created. If I say kubectl get pods, curl pod should be running for us. See, curl pod is running. So now we will connect to this curl pod, right? Kubectl exec -t curl pod name and --sh. And if you see here, this is, we are inside the curl pod now. You see the terminal here, right? So we are in the curl pod. Or I'll exit, and first I'll clear this, right? And clear, and we'll come from the top. Let's wait for it. and we'll connect to the curl pod now. And if I say host name, we are in the curl pod, right? So now let's come back here, and if you want, you can say curl, and our outbound is open from our EKS cluster via NAT gateways for the private subnet. So which means if I say google.com also, it should be allowed for us. See, 301 mode, it is accessible for us. So now we will use this one to access our application. So this is our DNS name of my internal pod, internal load balancer. So I'll say curl, and this should get me the default page, which is Kubernetes fundamentals demo, which is the root context or the app3 nginx, right? So now if I say /app1/index.html, so it should give me the app1, right? See, the application name app1, it has been successful. And we'll also test the app2 related thing with the same curl command. So you can see app2 is successful. So you have successfully created the internal load balancer, and you have deployed a curl pod in the EKS cluster, and from that EKS cluster, because this internal load balancer is from the internal networks of EKS cluster, so obviously you are able to access that and do the curl from this respective curl pod. So this is also successful for us. So now let's go back here and then clean up the stuff. So for cleaning up, we'll say kubectl delete -f kube manifest, and also delete -f curl pod. So all our app1, app2, app3 and then ingress related Kubernetes objects were deleted. So we'll also delete the kubectl and delete and -f and kube manifest -curl, so that whatever the curl pod we have deployed also will be removed. So this completes the ingress internal load balancer demo. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to get a very high level introduction about what are Fargate profiles and what is Fargate, and then what is this Fargate serverless. So as part of this section, we are going to add our new feature to our EKS cluster, which is Fargate profiles. So let's move on and understand on a very high level what is Fargate. So Fargate is a serverless compute platform for containers on AWS. So Fargate provides on-demand right-sized compute capacity for our containers. So EKS integrates Kubernetes with Fargate by using the controllers that are built by AWS using the upstream extensible model provided by Kubernetes. So these controllers run as part of EKS managed Kubernetes control plane and are responsible for scheduling native Kubernetes pods onto Fargate. So the Fargate controllers include a new scheduler that runs alongside the default Kubernetes scheduler, in addition to several mutating and then validating admission controllers. So these 4 points are very important on a Kubernetes perspective on EKS in relation with Fargate. So these 4 points I directly took it from documentation and then pasted here. So the reason is like, so when we want to understand how Kubernetes is scheduling the pods on Fargate related serverless infrastructure, the answer is we have the Fargate controllers created by AWS using this upstream extensible model, and due to that it is able to schedule the pods on the Fargate serverless platform. So when we start a pod that meets the criteria for running on Fargate, the Fargate controllers running in the cluster recognize, update and then schedule the pods on the Fargate. So that's about the Fargate on a very high level. But the key point in this slide is we are going to have Fargate controllers inside our EKS managed control plane, which is built using upstream extensible model provided by Kubernetes for scheduling the pods on Fargate. So that's the key point here. Moving on, so AWS EKS on Fargate. So let's understand what we are going to get using that. Okay, so we can directly bring our existing pods and then deploy to Fargate without any hassle. So we don't need to change our existing pods. So Fargate works with existing workflows and services that run on Kubernetes. No changes. Straight away you can bring and then deploy here. But there is one condition. The last slide of this lecture will have something called considerations. So very, very important thing. So when we are running things on Fargate, so how we say bring and then run as easily, at the same time there are some architectural decisions and then what it supports and then what it doesn't support also provided by AWS, and that is a big list. Okay, so that one also we need to see. Those are called Fargate considerations. So we also need to have a knowledge on those things if we want to bring our applications to run on Fargate. So next thing is they are production ready. So now EKS Fargate is production ready. So we can launch pods easily to Fargate, and it runs pods across availability zones for high availability, and each pod runs in an isolated compute environment. So this is a very important point from Fargate perspective. We will multiple times stress this point in our course in the next upcoming hands-on lectures, stating that one pod is equal to one EC2 Fargate instance in our EKS. So whenever we launch a pod, it is going to generate a EC2 Fargate instance automatically in the background. And whenever you say kubectl get nodes, whenever you have deployed 5 Fargate pods, then you will get 5 EC2 Fargate worker nodes available for you. And then you can see that using kubectl get nodes. And next thing is right sized and then integrated. So this is something like how much you need, use that much only. So if my pod needs these many resources, then use that much only. So only pay for resources you need to run your pods. So it also includes, means like Fargate also includes AWS integrations for networking and then security. So networking and security is not compromised by using Fargate on EKS. Moreover, your security is doubled only, we can say, not reduced. Okay. So now EKS deployment options available for us. Okay, when we bring Fargate into the picture, so what all deployment options EKS is available, if we take a look on a very high level, that looks great. Okay, so that's the reason I have put this slide. Okay, so we can have only EC2 node groups which are managed or unmanaged, or we can have a mixed deployment with the EC2 managed node groups, EC2 unmanaged node groups, and then Fargate, or only Fargate cluster, means like only a cluster, EKS cluster control plane with Fargate profiles can be created. So you can see EC2 node groups with managed EC2 and then unmanaged EC2 nodes. And if you see overall, our entire this course will be dependent on managed EC2 nodes and Fargate profiles. So we really didn't do anything related to unmanaged EC2 nodes, wherein you need to bring your own AMI and then your own AMI, and then you need to manage it using EKS control plane. And this is legacy, and then this is the trend which is running now, which is managed EC2 nodes. So we focused on this one primarily, but as this option is available, so I just put it here. Okay, so now the next thing is managed nodes, unmanaged nodes, and then Fargate nodes in the mixed mode. And in Fargate you can only have Fargate nodes. In simple terms, Fargate serverless. Okay, so you don't even need to say nodes here. Okay, and next thing is in deployment options, when you have EC2 node groups. Okay, primarily we are focusing on managed node groups only. Wherever I say node groups, it is going to be managed node groups. Okay, so in a AWS cloud, whenever you create a EKS cluster, it is also going to create a VPC. And when we create a managed node group, as part of that, so you can create your managed node group in public subnet, or you can create in private subnet. So this flexibility we have when we are dealing with EC2 instances. So you can have your managed node groups created in both public and then private subnets and then handle that. So but when we go to Fargate, you'll have a restriction there. So we'll go there and then see it. So in only Fargate mode, so we are going to have our respective Fargate profiles get created only inside private subnet. So pods running on Fargate are only supported on private subnets. In that case, whenever you have a EKS cluster and then whenever you want to deploy your loads on Fargate, in your cluster, at least one private subnet should be there to create your Fargate profiles. And moving on, so how the mixed mode deployment looks like, okay? So you can see that in mixed mode, so you will have the EC2 instances in private and then public subnets, and then you can create your public and then private managed node groups there. And then for Fargate, you definitely need to force yourself to create your EKS Fargate profiles in your private subnets. And moving on, EKS Fargate versus managed versus unmanaged nodes. So this is one thing which AWS highly portrays, and this simple thing makes us understand many stuff here, okay? So one is units of work, okay? So in units of work for Fargate, it is just only a pod. So it is concerned with only a pod. So whenever you deploy a pod, it is going to create a new underlying Fargate EC2 instance, but it concerns about only a pod. But in managed nodes, we first create EC2 instances and then we deploy our pods in them. And in unmanaged nodes also, it is the same thing. And units of charge means like how the billing happens, okay? So here in Fargate, it is going to be pods. So when you are dealing with multi-tenancy environments and then you want to charge for specific clients per pod, means like they have few pods running and then for them you want to charge, this is one good option for us, okay? And in the charging perspective in managed nodes is going to be based on the number of EC2 worker nodes. In unmanaged also, it's the same. And host life cycle, okay? So there is no visibility of the host from Fargate perspective. So visibility in the sense, you will not be able to connect to that host. Visible in the sense, if you say kubectl get nodes, so this Fargate nodes also will be visible for us. Per pod, it is going to span one node, right? So, but ideally, we don't have access to that nodes, okay? So they can terminate and then recreate, or what is happening inside that node is not our business. Only our business is what I'm going to deploy from pod perspective in Fargate. But in managed nodes, so we'll have the AWS SSH is allowed in the managed nodes. So whenever we are creating the cluster also, we are giving a tag there to provide SSH allow and then access and then key pair information also in our node group creation command, whatever we have seen so far. And in unmanaged nodes, so the host life cycle is customer dependent. Okay, so we really don't care here, okay? So which means AWS really don't care about what you are going to use and then how you are going to handle your authentication authorization about your host. And in host AMI perspective, so we really don't have any visibility about the host AMI in our Fargate because we are not even able to log in or we are not controlling that, okay? But in managed nodes, it is AWS vetted AMIs will be provided for us and then they will be patched, auto updated from AWS for us, okay? So that's the reason that is called managed nodes. And from unmanaged nodes perspective, customer bring your own thing, okay? So which means including the OS also you need to bring and then just use the EKS cluster control plane with that. So lot of hard work we need to do. But why do you use unmanaged nodes, right? So that's based on, means like it's a legacy and then recently they introduced the managed nodes and then we can start using managed nodes. So now host to pods relation. So this is very, very important for us to make a note from Fargate perspective. So one Fargate host is equal to one pod. So if you span 10 pods, then it is 10 Fargate hosts, okay? But in managed nodes, you can have 2 instances and then you can span many pods based on the CPU and then memory resources available in those nodes. It's the same case, one to many in unmanaged nodes. So that's about the Fargate versus managed versus unmanaged nodes. And next thing is Fargate considerations, okay? So these are very big. So what we need to do is, we need to take this documentation link and then review them. So there are many considerations we need to be aware of before we decide our Kubernetes workloads to run on Fargate, okay? So that's very important here. So let me copy this link and then go here and paste it, okay? And if you see here, the considerations, right? So let me make it bigger, right? This looks good, okay? So these are the Fargate considerations we need to worry about when we are dealing with it, okay? So when you see here, the first thing itself is the thing, classic load balancer and network load balancer are not supported on Fargate. Only application load balancer with ALB ingress is supported. With the minimum version, it should have this one. This is one thing. And like this, there are many things. Okay, daemon sets are not supported. So you can go through all this stuff here. So as we have documentation link, whenever you are deciding your real production workloads planning to run on Fargate, so you need to go through all these things. Currently GPU is also not available, and privileged containers you cannot run, and daemon sets are not supported. So like this, there are many things. Pods running on Fargate need to only run on private subnets. Okay, you can use the vertical pod autoscaler to initially right size the CPU and memory for your Fargate pods, and then use the horizontal pod autoscaler. Okay, so stateful applications are not recommended for pods running on Fargate as on today. Okay, they doesn't have a persistent database. Okay, persistent disk. So for that purpose, these are not allowed. Okay, so like this, many things are there here, so which you need to go through and then understand, and then based on that only decide if your workloads can run here, your production workloads can run on Fargate or not. So that's about the overall Fargate introduction. Okay, so we'll continue to the hands-on section in our next lecture. So I'll see you in the next lecture. Until then, bye-bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Welcome back. In this lecture, we are going to understand about Fargate profile basics, right? So far we have learned about classic load balancers, network load balancers, application load balancers, and then certificate manager, Route 53, Elastic Block Store, and then RDS in combination with Kubernetes and with the Elastic Kubernetes service on AWS. So now we are going to start with Fargate profiles. So it is going to be divided into multiple sections, so that we start with basics and then move on to advanced sections of Fargate profiles. So if we go here in our 0901 Fargate profile basics, so as a step 1, we are going to understand what we are going to learn as part of basics. So assumptions here are, we already have a EKS cluster whose name is EKS demo 1, and then we already have a managed node group running there with EC2 instances. So now we are going to add additional Fargate profile here. So which means we are going to run the cluster with a mixed mode, in the sense like we are going to have managed node groups, and also we are going to have Fargate profiles. So we are going to create a Fargate profile using our tool CLI named EKS CTL. So we are going to deploy a simple workload with Nginx app1 as the application, and then its equivalent node port service will get created. And for creating the load balancer, we are going to use ingress service, and in addition to that, we are also going to DNS register that using external DNS in Route 53. So in addition to that, we are also going to learn about new annotation for ingress, which is target type IP. Okay, so why we are going to learn about that is because Fargate doesn't have a dedicated worker nodes, so that dedicated EC2 type of worker nodes, which we can leverage for node port services, which we have used for application load balancers earlier, right? So for that purpose, we are going to directly use the pod IP to be registered to the load balancer target types. So we'll see more in detail when we go inside. But so let's go back to our presentation once, and then if you see, we already discussed about mixed mode in our introductory section, but we'll see the picture one more time. So we have a EKS managed node group with 2 instances in a private subnet currently. Okay, so but the depiction here we are also showing with the public subnet, because managed node groups which we can create on EC2 instances, we can create in both public and then private subnets. But when coming to Fargate case, so we are going to specifically tell that, so we can only create Fargate profiles in private subnets. So Fargate profiles can be deployed to EKS clusters only, at least we have in our EKS cluster 1 private subnet. So these cannot be deployed to the public subnets. So that is very important point which we should be aware of. So we already said that in private subnet, we already have managed node groups running, right? So let's go ahead and then see that. So for that, kubectl get nodes -o wide. Okay. And if you see, we should have 2 nodes running here, and their internal IPs is 110.114 and then 85.8. But you can see there are no external IPs for these nodes because so those are deployed to this private subnets. So now we are going to create this respective forget profile and then run the stuff here. Moving on. So let's see what we are going to do, right? So as part of EKS cluster, already NAT gateways and then public subnets and then private subnets are created in respective availability zones, right? So now we are going to create a forget profile fpdev with the namespace also fpdev, right? And then going to deploy a application named app1nginx. So we have deployed it and then it created a replica set. So once it starts creating the pods, those pods will be scheduled by automatically creating the forget nodes. So forget nodes will get created and then these pods will be scheduled on those respective nodes. So we have given in our manifest replica as 2. So it is going to create 2 forget nodes. So here one thing we need to understand here is in forget, so the number of hosts is directly proportional to number of pods. So if you give 10 pods in your replicas in your deployment, so obviously you are going to get created 10 forget nodes. So now moving on, we are going to also automatically have a outbound connection to the EKS cluster plane for these forget nodes via NAT gateways. The next thing is its equivalent node port service also will get created. So when we are doing the complete mixed mode with multiple applications, few on worker nodes and then few on forget, then these node port services will be very helpful, where we are going to define target type :IP as the annotation at the service level also as and when required. So now we are going to create the ingress service, means like whatever the manifest we created, it is going to create a ingress service with SSL redirect, external DNS, everything, and then it will also associate the SSL certificate created here and enable the SSL redirect and also DNS register the fpdev.kubeoncloud.com for using external DNS. And then whenever user tries to access fpdev kubeoncloud.com/app1/index.html, so it comes to application load balancer, and for the /star it is directly going to the pods. So there is no node port service in between. So from application load balancer target types, it is going to directly go to the respective pods whenever we use the target type annotation with IP. By default, it is going to have target type is equal to instance, which we really don't need to define because it is default. So now let's go back to our GitHub repo. So and then move on with the prerequisite steps. So one thing we need to understand in prerequisites here is EKS-CTL CLI. So this is very important thing. So EKS-CTL will have continuous releases with new feature additions every 15-20 days. So it's a very high evolving space nowadays in AWS, means like EKS-CTL and also forget related stuff. So that is the case, even though means like whenever you have started and then implemented this, so you might have installed some version here in our 01 EKS create cluster using EKS-CTL. And now whenever you are doing maybe 15 days over and then again you are trying with different things in your course, go ahead and then update your EKS-CTL. So every 17 to 20 days they have upgrades to the EKS-CTL with lot of new features coming into the place. So always it is recommended to use latest version. And then this is the releases page where you can browse to see latest version. And EKS-CTL version will provide you the exact information about what is the current version. I've also updated the report to check your version, and then accordingly you can cross check in the EKS-CTL releases what is the latest version and then update it. So this is only a prerequisite and then cautionary step for you. Okay. And now moving on, prerequisite check about ALB ingress controller and then external DNS, right? So now if we go back to our PowerPoint here, so whatever you deploy in these private subnets, whatever the workloads you deploy, how are you going to expose it to the internet to test your application, right? So because this forget nodes doesn't have any concept of node port service, so even though if you create the node port service, So that node port information is not there because it doesn't have a static node which supports these node port things, right? So even if you define a cluster IP service, it will be restricted to your cluster, but you cannot access at the internet level. So that's the reason you need to have the user or whatever the related load balancer created here. Okay, so I am just saying here user management load balancer only because anything is fine, right? Manifest things I am not going to change too much because upcoming again next lectures anyway we are going to add the user management stuff. Okay, so but some load balancer we are going to get created here for our app one, right? So whatever we are getting created here, those needs a few prerequisite services, right? Example, if you want to create a application load balancer via Kubernetes, you need to have the ALB ingress controller installed. In the same way, if you want to register your DNS to Route 53, you need external DNS should be available. So we need to ensure that those are available for us on our current worker node. As part of previous sections, we are anyway continuing the same cluster EKS demo 1. Those should be available for us. So we have verified kubectl get nodes -o void. So we are going to verify kubectl get pods -n kube system to see that our ALB ingress controller pod is running, right? So our ALB ingress controller pod is running, no issues. So we'll also verify get pods in default namespace where our external DNS pod is running. So if these two are there, then only our this respective load balancer, whatever we are going to create for this app we are deploying in Fargate, is going to get created and then DNS registered in Route 53 successfully. So we verified all our prerequisite steps also. In our next lecture, we'll focus on creating Fargate profile and then deploying the stuff and then testing it. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to create a Fargate profile on our EKS cluster EKS demo 1, right? So before that, we are going to verify any Fargate profiles exist. So EKSCTL get Fargate profile in cluster EKS demo 1. So let's go ahead and then verify that now, right? So I'll go back here and then I'll say clear and I'll paste it, right? So if any Fargate profiles are there, it is going to list for us. No Fargate profiles found. So we are going to create a Fargate profile. So the template is -- cluster EKSCTL create Fargate profile and cluster name and the Fargate profile name if we want to use and the namespace whatever we want to use, right? So namespace is the core thing here, which is nothing but if our application is deployed with this namespace, automatically that respective application's pods are going to get scheduled under this Fargate profile. So what we are going to do is we are going to copy this and then paste it, right? So the namespace tag whatever we provide is the critical. So if our application deployments have a namespace reference to fpdev, means like our deployment related manifest has fpdev, then that respective pods inside the deployment are going to reference and then deploy on this respective Fargate profile. So as soon as Fargate profile is created, so there will not be any instances present there. Only when we deploy the workload, which means the deployments, then only the Fargate instances will get created. Okay, so let's wait for this profile to get created. So we can see that Fargate profile got created. So one important thing here is when you are going to create this Fargate profile first time, right, in your respective EKS cluster where you already have existing managed node groups running, right? So at that point, it is also going to create a Fargate pod execution role also. So at that time, you are going to see this type of output. So already this is created when I am testing for different things. So this output you didn't see now. Okay, so you said you have seen that it tried to create it and then finally created it. Okay, so that's all. But ideally, it also will create a Fargate pod execution role as part of whenever you create your first Fargate profile inside your cluster, right? So now let's move on and then review the manifests as part of whatever we are going to deploy to our Fargate profile, right? So we are going to deploy a simple Nginx app1 with ingress load balancer. So we cannot use worker node ports for forget parts for two reasons, right? Forget parts are created in private subnets, so no access to internet to access them. So forget parts are created on random worker nodes whose information is unknown to us to create a node port service. That is also another important thing. But in our case, when we are doing the mixed mode environment with node groups and then forget, if we create a node port service with ingress load balancer and then there is no target type of IP related annotation, still things are going to work, because the node port service whatever you have created is going to also present on managed node groups also. As part of that, you will get the worker node ports from managed node groups. So that is not a good option, and always it is recommended for forget loads to use target type is equal to IP as the annotation at the ingress manifest level, or if we have a mixed mode multiple applications deploying, for that respective application who needs IP related target type on our application load balancer, you can use IP. So now the first thing is to create a namespace manifest for us. Okay, so we usually give 01 or 00 for our namespace manifest, and namespace is the mandatory one for our respective applications. We need to map to that respective namespace, then only they can be deployed or scheduled to that forget profile. So now we are going to create a API version v1 kind namespace, and the name is fpdev. So let's go back here, and if you see the namespace 01 namespace, in 09 01 forget profile basics, you can see 01 namespace. So this is there. And the second one is update all other manifests with the namespace whatever we are creating. So one is Nginx app1. So if you see it here in its deployment manifest, under the metadata you can see namespace fpdev is added. In the same way, its equivalent node port service also under the metadata namespace fpdev is added. So rest all health check URL, all those things we are not changing, which is coming from previous examples only. Okay, so only namespace added with fpdev. One more is ALB ingress SSL redirect with the external DNS whatever we have implemented earlier, right? So in our previous section the same thing, and here also under metadata section for ingress service we have added namespace fpdev. In addition to that, we are also going to add for our deployment manifest, right? So we are going to add resources section. So why this resources section? So this is another important thing. So in Fargate, it is super highly recommended to provide the resources.requests and then resources.limits about our CPU and memory in our deployment manifest. So almost you can make it as mandatory. Okay, so 100% we need to use this. That is the good option. Okay, so this will help Fargate to schedule a Fargate host accordingly. Means like the Fargate host, whatever it is going to create for that pod to be hosted there. So how much resources that Fargate host need to have will be decided based on how much you provide inside this request section. So it's not going to use whatever you provide here. More than this only it is going to allocate, but there will be some calculation here. Okay, so it will take this much. Example, you take memory 128 MB you are giving, and it is also going to allocate plus 256 MB for its kubelet and then Kubernetes related core things to run on the worker nodes, right? So for kubelet and other things, and then accordingly it will decide the value and then provide the memory for our Fargate host. So in addition to that, as Fargate follows 1:1 ratio host to pod, 1 pod per host concept, we defining resource section in pod template, right? So deployment pod template spec should be our mandatory option. Even if we forget to define resources in our deployment template, low memory using pods like Nginx will come up and then keep running. Okay, so those will not have any issue most of the time. But high memory using apps like Spring Boot, REST APIs or anything, it will be in the continuous restart mode in your Fargate profile. So which is not good. So always recommended to use resources section. So let's go back to our Nginx app1 deployment section. And you can see we have added the, even it is Nginx, I have added it right in the pod template spec. So under containers, and then for this you are adding the respective resources for this container. For this container, it needs this much information of resources to be allocated, or it requests for this much information and it can go for this limit whenever it needs. So that's about it. So in addition to that, update ingress manifest with ALB ingress Kubernetes target type is IP. So as we already discussed multiple times about this one, as we are running our pods on Fargate serverless, we need to change our target type to IP, because we really don't have any dedicated worker nodes here. Okay, so now in addition to that, we'll also update our DNS name to fpdev.kubencloud.com. So let's go to ingress manifest, and you can see here this is already added. And external DNS name also I'm going to say fpdev.kubencloud.com. So one thing important here we need to note is like this can be defined even at the service level here. Okay, so you can even define it at the service level based on our set of applications. So in this ingress you have few applications with EC2 worker nodes, and then you want to go with node port service for them, and few applications with Fargate and the same ingress service you are planning to use. So few with worker node port, and then few with the instance IP if you want to use, then you should not define this here. Okay, so for all the Fargate deployment related things, we can take this IP and then put it in our respective node port service annotations, and we can leave the default, which is target type as instance for other related worker node stuff. Okay, so that for deployments related to which we are going to host on managed node groups, they directly get the node port related stuff automatically. Okay, so this completes the review of our manifest, and also about creation of our all these Fargate profile. So in our next lecture, we'll focus on deploying these things and then testing. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to deploy our manifests and then verify whether they are scheduled on Fargate, and we are also going to test it using the URL. So let's go back to our command line and then go to 09 and 0901 section, right? And we have the kube manifests here. Okay, so I am going to say kubectl apply -f and then kube manifests, right? And all the manifests present in that should be created. So we have the fpdev created, app1 nginx deployment got created, node port, and then ingress got created. So right, so first we will verify our get namespaces, which is ns, and our fpdev namespace got created. So we are also going to verify get pods, right? And then -n, which is nothing but in fpdev namespace, and -o wide, so that it will also provide the node information. So it is trying to get 2 pods related to it, and then nominated node, still we didn't get the name of the node, but that's fine. It will take a while to get the name. So it's currently in the pending status. So once the node is ready, then it will go ahead and then schedule immediately, right? So we can go back here and then get nodes -o wide. So let's see how many nodes are there in our cluster now. So earlier you have seen only 2 nodes which are starting with IP, right? With internal, these 2 nodes, okay, 110.114 and then 85.8. So they start with IP hyphen, but Fargate nodes start with Fargate-IP. So we have the 2 replicas created as part of this deployment, which means we said that 2 replicas. So 2 Fargate nodes got created. So let me clear this, and I'm going to verify the pods one more time. kubectl get pods -n fpdev -o wide, right? So these are scheduled inside this and then running, right? So I'm going to say kubectl get ingress from namespace fpdev, right? So it got created, means like if this address field is having the value, which means it got created, means like there is no issues related to it. So let's go back to our AWS management console and go to EC2 service, right? And let's go to load balancers, right? And in load balancers, so we have that application type load balancer is getting created. And if you go to listeners in port 80, we can see that the redirect thing will be there, which standard which we have seen earlier also, HTTP to HTTPS. And in port 443 for /* you should have a /*. Why? Because in ingress we have defined /* only, right? So why? Because this is app one, only one app, right? So I said /* here. So it is going to one target group. So I can directly click here to go to the target group, or I can go back and go to target groups here, and then I can open the target group here. So before opening it, you can see target type is not instance here, it is IP, because we have used the target type as IP, which means it is directly going to the pod IP. So I'll open this, and this is the HTTP related health check path, and this is the target, and they are healthy from the both nodes. You can see 158 and then 107, right? So I'll say kubectl get pods -n fpdev, right, -o void, right? So you can see that our pod IP and our node IP in the Fargate is going to be same. You can see 107 and then 158 related IPs. You can see here them. Okay, so that's about creating it. So now if our let's verify also the Route 53 stuff, right? So fpdev got successfully registered or not. Code on cloud.com. So let me close this, go to hosted zones, and you can go to code on cloud, and if you see it, we have the fpdev.kubeoncloud.com got created. Okay, so I'll also do ns lookup to verify fpdev.kubeoncloud.com, right? So it's working. So let's go back and then access the URL and then test it, right? So I'll go to browser and I'll say this, and it's working as expected, right? So everything is working. So now let's go ahead and then delete our Fargate cluster. So I'm not doing anything related to application is running here, and then I went and then deleted the Fargate cluster. So let's see what happens. So first list the Fargate cluster, right, and then get the name and then delete it. So already we know that our Fargate profile name is fpdemo. I can directly say EKS delete Fargate profile from cluster EKS demo 1, and the Fargate profile name is fpdemo, and then also provide wait statement. Okay, so wait statement will allow us our command line to wait here until the deletion is completed. So it is nothing but fpdemo. We can see the name here, right? So and inside that the selector namespace is going to be fpdev. So I'm saying EKSCTL delete Fargate profile cluster EKS demo 1, and the name of the Fargate profile is fpdemo, and then wait, right? So it will take 2 to 3 minutes to delete it. Until then I'm going to pause the video. So it took close to 4 minutes to delete the Fargate profile. So let's verify, means like earlier our app nginx related deployment pods are present on Fargate nodes, right? So now kubectl get pods -n fpdev, which is nothing but in namespace fpdev, and then -o void, right? So let's see what happened to them, right? So now if you see, those are still present and then scheduled on your regular worker nodes, which is nothing but your EC2 private node group. So they got scheduled on our if we go back here, so it got scheduled on these things, right? So it got scheduled to this private subnet. So when you deleted this Fargate profile, automatically those got scheduled here. So that's about it. So which means like it didn't delete the application or anything, only the Fargate profile got deleted and the application came back to our original EC2 worker nodes. So now if we want, we can even access the application and then it should be running, no issues. So I'm saying enter one more time, no issues. So I'll take it and then put it on file, new private window, and then access one more time, right? Just for safe side. So everything is working fine. So this completes this respective section, which is basics. And in addition to that, if you want additional information, there is a references section here. Okay, so eksctl.io usage forget support. So here also you will have good information to follow. In addition to that, you will also have Amazon documentation, and for ALB ingress controller related annotations related to target type, right? So you can find here. Okay, so this is the from last third one here. Okay, so you can even have it with instance or IP, and instance is the default, and you can have them on ingress or service. So let's go ahead and then clean up the stuff whatever we have created so far, right? So kubectl delete -f kube manifest. Okay, so I can copy this and let's go here in 0901 forget profile basic, delete whatever we have created, so that all the ingress manifest, load balancers, everything will go away, and then it will not cost us any money for us. Welcome back. In this lecture, we are going to understand about forget profiles creation with YAML. So let's see what we are going to learn all in all. So we are going into inside 0902 forget profiles advanced YAML. So as part of this, what are we going to learn is, so we are going to deploy 3 apps in a mixed mode deployment. So which means one app to our EKS managed node group, which is with EC2, and 2 apps we are going to deploy to 2 different forget profiles. So as part of that, to create those 2 forget profiles, we need to write the YAML and then create those 2 forget profiles at a time. Earlier, we have used the command to create it in our 0901. So to create a forget profile, so we have used the command. So like this, if you want to create 10 profiles, so you need to run 10 times the command. Instead of that, we are going to do that using a YAML file. So like this. So we'll discuss about this later, but for now, we'll go back and then understand what are the 3 apps and then how we are going to deploy the detailed architecture. Let's see what are those 3 apps and then how we are going to deploy in a visual manner, right? So in AWS Cloud, we have a VPC, and inside VPC, we are going to have both the EKS managed node groups and then EKS forget profiles. So in a EKS cluster, we are going to have both forget profiles and then managed node groups together. So that is nothing but we call it as mixed mode, right? So what happens here is like, as usual, we'll have our availability zones and then subnets, right? So from forget perspective, it only supports private subnets. So if you see here we have only private subnets, and managed node groups can be created in both private and public subnets. But as part of this section, we have already an existing private subnet related EKS managed node group. So that's the reason I have rounded it to only this part. And in this public subnets, we are going to deploy our ingress related services. So now what happens is, as part of forget, whenever we bring the forget into the picture, so the organization of apps is going to be with the namespaces, right? So how we are going to organize is with namespaces. So for this EKS managed node group, whatever the application NS app1 means, like app1, whatever we are going to deploy, for that we have created a namespace NS app1. In the same way, for app2, we are going to create a namespace app2. And then for application UMS, which is user management microservice, so we are going to have the namespace as NS UMS. So now NS app2 will be part of one forget profile, NS UMS will be part of another forget profile, and NS app1 is going to be for managed node groups. Means like these namespaces are not tied to anything specifically. So but high level, if we have that namespace tied to forget profile, so those apps will be scheduled to that respective forget profile. So it's the other way around. But whatever may be the case, so now if we take my app1, right? So app1 related pods I have deployed on the EC2 worker nodes here. So, and it will have its own node port service and its own app1 ingress service. Okay, and in the same way for app2 we'll have a forget profile with app2, and then inside that we'll deploy our app2 application, and it also will have its own separate app2 ingress service. So why we are having separate set of services, we'll see in the next slide. Means like why we are going to have separate ingress services here. Okay, so we have seen the concepts of context path based routing in ALB, but why we are not using here when we are using this mixed mode deployments. Okay, so there is a reason for that, so we'll see in the next slide. Okay, so now another thing is UMS. UMS is nothing but user management microservice. Its ingress service need to be deployed, and UMS pod, which is nothing but UMS deployment, will be deployed, and its node port service and its external name service, and this external name service is going to connect to the RDS database, right? So whatever we have created. So if this RDS database is not up and running from previous sections, whatever we have created, right? So if it is down, and then if you want to start it, you can start it up. Okay, why? Because whenever you deploy UMS, if this is not up, then this pod keeps failing. So now the next thing is, as soon as these things are created, one more thing will be there, which is external DNS to register the DNS names, and also associate for SSL certificate, certificate manager related certificate will be associated in our ingress service. Okay, so now it will register 3 DNS names: app1.kubeoncloud.com, app2.kubeoncloud.com, and then ums.kubeoncloud.com. So now as a user, so if I am using, means like if I am using app1kubeoncloud.com, and then if I access the application, I come to app1 ingress, and then from there I'll go to app1 node port service, and then from there it will be load balancer to app1 pods. Okay, using node port service stuff. Okay, so now if we go to app2kubeoncloud.com, it will go to app2 ingress here, and then we directly go to the pod, because we are going to use for forget pods, we are going to use target type IP in our manifest. In the same way for UMS kubeoncloud.com, so we are going to access it, and the request comes to UMS pod, and if the request is health status, then directly from here it will be served. But if the request is going to be something like list users or something, which is /users, so then the request will go to external name service, and then it will go back to RDS database, and then serve it back to the user. So this is the mixed mode with 3 apps, whatever we are going to deploy. Mixed mode, again I am going to reiterate, nothing but in a same EKS cluster we are going to have both forget profiles and then EKS managed EC2 nodes also in the same cluster. Okay, so that is nothing but the mixed mode. So moving on, so we have discussed about why can't we use the app only one ingress for all these things, right? So means like one ingress for app1 UMS and also for app2, and then route it. If it comes to app1 ingress, and then if it is /app1, go here, and then if it is UMS, go this way, and then app2 go this way. So why can't we do that? Okay, so which is nothing but ingress with cross namespaces, you call it as. Why? Because you created a ingress, and then this ingress, whatever you are going to create, right? So if you go back to the previous picture, right? So this ingress, whatever the app1 ingress, even though we are not specifying here in the picture, app1 ingress will be part of NS app1 namespace. Okay, and UMS ingress will be part of NS UMS namespace, and app2 ingress will be part of NS app2 namespace. Now if you see here, this one app1, this respective ingress, if it is not part of any namespaces, or if it need to go across namespaces to send the traffic, so that's not possible as on today, which means like ingress with cross namespaces is not supported as on today. Even there is a GitHub open bug from 2015 onwards, but till date that is not resolved as on today. So not only in ALB ingress, this is not supported as on today. So now, which means this concept is not applicable here. So always if we are dealing with multiple namespaces, then always it is like each namespace one ingress should be there, and inside this namespace you have 10 apps, then 10 context path based routing or host header based routing, whatever the routing you want to implement. you can implement inside that namespace. But outside of namespace, which means across cross namespaces with single ingress, we will not be able to do the context path based routing or any host header based routing or any ingress related concepts with single ingress to multiple namespaces. So with that said, we have completed our introductory section, and then we'll move on to advanced forget profile with YAML in our next lecture. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create forget profiles in advanced mode using YAML files. So in YAML, we'll be able to create multiple forget profiles at a time if we are in need of creating them. So let's go back to our Visual Studio Code, and in 0902 forget profiles advanced YAML, you can see kube manifest, and then you will find under kube manifest two folders, forget advanced profiles and then 02 applications. So so I'm going to use forget advanced profiles, and inside that you can find forget profiles.yml. And if you see it here, API version, kind and metadata are standard stuff. And this API version is nothing but it is EKS CTL, which is EKS CTL command line CLIs related configuration which we are performing now. So which is V1 alpha 5 version as on today. So if you want this template to be as is, if you want to find it, so then you can go to EKSCTL.io, and any latest changes you can find here, right? So you can go to usage and you can go to EKS forget support, and any latest changes, whatever happens here, V1 alpha 5, V1 alpha 4 or whatever comes in, you will be able to find those information here, because the documentation keeps updating every time whenever the new release comes into the picture, right? So now, so API version is this one, and then kind is cluster config, and the metadata, this is another important thing. So it is not just like normal metadata, but this metadata will have something called name in the sense the name of the cluster where we want to create these forget profiles. So our cluster name is EKS demo 1, and where our cluster is located is US East 1. And now under forget profiles tag, you can have a list of forget profiles you can create. So name of my profile is FP app2, which is nothing but forget profile app2. And selectors are nothing but under selectors you can define namespaces and also labels. So all workloads in the NS app2 namespace in Kubernetes will be scheduled onto this respective forget profile. So whenever you deploy the workload, all the workloads which has the namespace ns-app2 will be scheduled to this forget profile. So that's what is the selector mean here. Okay, so it's going to check for if I have the namespace ns-app2 for any of the deployed nodes, and then it is going to schedule accordingly. In the same way for FP-UMS also. So the forget profile name is FP-UMS, and under selectors, in addition to namespaces, we also have labels. So I'm saying labels run on forget. So in NS-UMS, in addition to NS-UMS namespace, so the workload also should have a label named run on forget. So if only these two matches, only those workloads will be run on FP-UMS forget profile. So let's go back to our GitHub repo and then go ahead and then create this forget profile. So we will go here and then we'll go to 09 EKS workloads on forget, and we'll go to 0902, and then we'll go ahead and then create the forget profile, right? Create forget profile from YAML file, which is -f kube manifest /01 forget advanced profile /01 forget profiles. Okay, so the entire path we have provided. So it will take a while to create it. So in the meantime, we can go ahead and then move on with discussing about manifests. Okay, so once it is created, we'll come back and then list the profiles. But for now, we'll move on and then discuss app1, app2, and then UMS manifest. So let's go back to our Visual Studio Code and come here, and I'll close this one. In kube manifest, I'll close 01 forget. You can see you will have 02 applications where you will have 3 namespaces. 01 ns app1 means like app1 application, app2 application, and then user management microservice application, right? 01, 02, 03. So each related manifest will be available inside them. So let's talk about app1. So first thing is we need to create ns app1 namespace. So API version kind and metadata standard namespace, which we have seen in our namespace section also. So apps deployed in this namespace will run on EC2 managed node group. Why? Because we didn't create any Fargate profile for ns app1 related namespace. Only for ns app2 and then ns UMS we are creating the Fargate profiles. So for ns app1, as we didn't create anything related to Fargate profiles, it is going to by default run on EC2 managed node groups, provided if we have node groups. If not, the pods are going to be in the pending state. Next thing is Nginx app1 deployment and then node port service. So these deployment and node port services which we have written on our own earlier, so those are standard ones, nothing changed inside them, deployment and then node port service. Only one thing changes here is we are going to add the namespace in the metadata. In the metadata, just child item is namespace, and this deployment belongs to ns app1. In the same way, I'm going to say here this service app1 Nginx node port service belongs to namespace ns app1. That's all. And now I'm also going to have a separate ingress for this ns app1 because of it is going to be in separate namespace. So this ns app1 is going to be on separate namespace. So already we have seen there is a limitation. It should have a separate ingress service, right? So what we are going to achieve is we are trying to see that mixed mode with multiple deployments, everything is working as expected, right? So let me come back here, and in ALB ingress also the standard thing is under metadata you have the namespace and then ns app1. So this ingress will get created under ns app1 namespace, and here there is no Fargate related target type IP. But even if you want this one also to be with the target IP only, which means instead of node port service, if you want to route it directly to your pod IP, you can even these also supports that, and if you want you can put it. And DNS name I am giving here as app1kubeoncloud.com, and the path /* will go to app1 Nginx node port service. That's all. So this is app1, and app2 is also going to be same way, ns app2. And the changes here will be only the namespace for deployment and another namespace for service. Okay, it's like namespace information. And ALB ingress also will have app2 ingress service will be the name, and namespace it will be tied to ns app2. And here you will have the for Fargate you will say that because this is ns app2 will be part of our Fargate profile, right? ns app2. So that's the reason you are going to have the target type as IP, and as usual /* goes to app2 Nginx node port service. Okay, so let me close this, and one more you are going to have ns UMS. UMS is nothing but user management microservice, right? So namespace is going to be ns UMS, and you will have something called MySQL external name service. So we need to ensure that our RDS database, whatever we have created as part of this section, right? EKS storage with RDS database. We are continuing that example here because in our next sections, we are going to have microservices with user management microservice and notification microservice. And we are going to do many examples there. So as part of that, so this database should be continued with us. Okay. So if it is not in use, you can even stop it, right? So RDS, and so I'll say RDS and go there. No, it went somewhere else. Okay, come on. So this is the RDS, and let's cross check our database is up and running and the endpoint is same. So I went to database and it is running available, and it starts with the cxojy is my endpoint here information, right? cxojy user mgmtdb.cxojy. So user mgmt.cxojy. This looks good for me. So I'll move on with user management microservice deployment service, which is nothing but namespace is going to be ns UMS here. This is deployment. And as usual for all the deployments, you need to ensure that you have the resources section for the Fargate things, okay, wherever you are deploying. So earlier in our previous section, we already discussed it here in our 0901, but just cross check, okay. and this is secrets, and then here also you will see the labels, right? So now one important thing here is in external name also you have seen that labels run on forget, and then here also we are putting everything. So to follow the standard, okay? So which means why to go into confusion that I didn't put here, right? So user management microservices, so for deployment object also you have run on forget, and then it's a template metadata also you have run on forget. Primarily it is required here. Why? Because this pod template means like this is the pod template, right? In a deployment here run on forget is required under labels, but we have followed the standard where for deployment also run on forget, here we have given, and in Kubernetes secrets also labels we have given run on forget, and also namespace also we have given ns-ums, right? And in addition to that, user management node port service also you will have namespace ns-ums, and under labels you will have run on forget, okay? And in addition to that, ALB ingress also you will have labels and then run on forget and namespace ns-ums. And again this is going to run on forget, you are going to have target type as IP, and path is /star, and the service name is user management rest app node port service, right? So that is the name here, user management rest app node port service, and 8095, and my name here it is going to be ums.kubeoncloud.com, and for app2 also name is going to be app2.kubeoncloud.com. So this is about the review of our entire thing whatever we discussed. This is app1, app2 and ums manifest. So now let's go back and then see what happened with our profiles. So our profiles got created. So let's list those profiles once, right? Get forget profile cluster EKS demo1, right? And once listed, so if you want to see our respective forget profiles in YAML format also we can see, but that is fine. So here are the lists. So we have something called FP app2 forget profile and FP UMS forget profile. And selector namespace for FP app2 is NS app2, and selector namespace for FP UMS is NS UMS. Okay. So now in our next lecture, we'll go ahead and then deploy these things and then test it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to deploy all the three apps, whatever is present here, 01, 02 and then 03 at a time using kubectl apply -r-f kube manifest 02 applications, right? And then verify those things. So before that, we already verified if RDSDB is up and running. So for UMS service to be functional, okay? So now let me copy this kubectl apply -r, right? So let me go here and then clear the stuff, and I am in 0902 forget profiles advanced YAML. So kubectl apply -r-f so that all recursively all whatever the folders inside that YAML files are there, those things going to get created. So namespace ns app1 created, and inside the deployment service ingress created, and namespace ns app2 created, and inside the deployment service and ingress created. Same for ns ums also. Okay. So now once it is created, we need to go ahead and then verify the stuff, right? So I'll say clear kubectl get ingress and all namespaces. So we'll see that in all namespaces ingress got created or not. So app1 ingress service got created, and this is the address for it. App2 got created, this is the address. UMS ingress service got created, and this is the address. Okay, so that's good thing. So the next thing is, so we need to verify how the pods are coming up. Okay, so let me clear, and then I'll say kubectl get pods, and then if you want to see from specific namespace, you can say -n, and then I'll say ns app1, and then if I want, I can even say -o wide for seeing the forget nodes, whatever it is going to schedule, right? But ns app1 belongs to our specific EC2 worker nodes. So that's the reason if I say ns app1 and -o, it is running on managed node group. So this doesn't have any forget profile. But if I go here and then verify for app2, so it should be running on a forget node. In the same way for ns ums, right? Get pods for ns ums. Again, it should be showing for forget nodes only. So if we want, we can even see all at a time using kubectl get pods, all namespaces and -o void. So even we'll get the kube system and then default namespaces, but that's fine. Okay, so you can find 4 forget nodes. So ns app2 related app2 and then user management microservice, these are running with forget. So another important thing is, so we already know that 1:1 ratio, how many forget nodes how many pods you are going to schedule, that many forget nodes gets created. So if we go here and then verify nginx app2 is going to be scheduled on forget, so its replicas are 2. In the same way, user management microservice deployment also replicas are 2. So which means get nodes -o void, so you should have 6 nodes here, right? So 4 for forget, 1, 2, 3, 4 for forget, and 2 for our regular EKS managed node groups. So that's good thing. So we verified all these things. Now let's go ahead and then verify ALB and then target groups. So verify ALB listeners and then rules. So let's go to EC2 and go to load balancers, right? So we went to load balancers and we have 3 ingress services, which are 3 load balancers getting created now. And if you see here, its equivalent rules are also getting created. Okay, so and now we'll go to target groups. 3 target groups created, out of which you can see one is with instance, because we configured it to be created with instance. Okay, and if you see it here, so it's coming up and then it's already showing healthy. Okay, and because that is app1, nginx will come faster, right? So that's the thing. And this is going to be app2 and this is also healthy, and mostly this also healthy or not, we'll cross check. Okay, it will take time for our UMS because we have the liveness and readiness probes inside that, right? So but anyway, we'll cross check how that pod is coming up. Okay, so -n ns-ums, right, and see what's going on there. So it's up. Okay, so no issues, no restarts, everything is good. So if you want, we can even see logs -f, kubectl logs -f, and the pod name is this one, right? And I am going to say -n ns-ums. Okay, so to see that logs also good, right? So started user management application, JVM is running. Okay, from 51 means within 51 seconds it took to create it. Okay, so initializing the Spring Dispatcher, everything looks good for our UMS application also. It might take a while for us, so let me do a refresh here, all target groups refresh, and go back here, and then these are also healthy, good. So that's good. So now the next thing here is target groups verified and then load balancers verified. So now we are going to verify the Route 53, right? So we'll go and then verify Route 53. All the new domains got created. So go to hosted zones, right? And then we will go inside kubeoncloud.com, right? Kubeoncloud. Okay. And if you see here, we should have something called app1, app2, and then UMS. Those looks good. So one thing we can even cross check is NS lookup for ensuring. Why? Because sometimes it takes DNS changes takes time, or when we are rewriting the stuff, we are doing it for the first time, nothing will happen. But same manifest, if you delete and then recreate, sometimes you are going to have Route 53 issues. Okay, so that's the reason always good to verify, right? So app1, and we'll also verify for app2, and then we'll also verify for UMS. Okay, so in addition to this, you also need to cross check this with the DNS names here. Ideally, if you feel like there are issues with your application access, so you need to go here and go to EC2 and go to load balancer. So what you are going to do is ns lookup ums kubeoncloud.com got 2 IPs here, right? 3.3 and then 18.95. So now I'll go to the load balancers here. The way I check it, cross check it, any Route 53 caching issues is happening or not is this way. Okay, so go to tags, and this is app1 ingress service, and the next one is app2, and this is UMS ingress service. From tags I found that. Okay, so I'll go to description and I'll copy this DNS name, and then I'll say ns lookup, right, and then I'll paste it here. Okay, and now if you see it here, 3.3 from my load balancer DNS name, I'm getting 3.3, and then this 3.3, whatever it matches for me. So which clearly, and even 95, and 95, which clearly confirms that I am good in. Now I can go ahead and then access my applications. Okay, so sometimes when you are rewriting the stuff and then redeploying, ideally there will be Route 53 cache related issues. So that's the reason cross-checking like this, or waiting for half an hour, 30 minutes, and then again coming back and redeploying usually fixes the stuff. Okay, now let's go back and then access the applications. Okay, so we have 3 applications to access. So this is app1 application, open link in new tab, right? So it's working, right? app1.kubeoncloud.com is up and running. So this should be app2. I need to correct it. Okay, so I will correct it. Okay, so I have fixed it, app2 kubeoncloud/app2.index.html. Okay, so now app2 also with different color it is available. Now user management microservice health status I am cross checking. Okay, it's up and running. So if you want to list users directly on browser, you will get them, right? So these are the users we have in this application. We can see it here. Or you can go ahead and then add in our Postman project the environment and then test it, which we have done already multiple times. Okay, so we can go ahead and then now delete these things and then clear the stuff. Okay, so I'll go here and then delete this. Okay, so now we have completed all the work and then testing. So we are going to delete all our 02 applications. Okay, so I'll say kubectl delete -r -f cube manifest and then 02 applications. So whatever we have created, everything should get deleted now. So once deleted, we should not see anything here. So let me close these things, right? And these things. Okay, and here in ingress services, nothing should be there, all should go away, right? It's going away, it will take a while. So target groups, it's going down. So let's wait for a while to get these things deleted. One thing we need to know about Fargate profiles is whenever you deploy the pod inside, whenever you schedule your workloads on Fargate, what happens is it will take a little bit of time to create a Fargate node and then schedule the pod inside that. So why? Because we really don't have a node. It need to create a node and then it need to install the kubelet inside that, and then using that kubelet it need to register to our EKS cluster control plane and then check for our respective scheduler and then get the data and then schedule, means like get that respective pod and then schedule on that Fargate node. So it will take a little bit of time. Example, it takes only less than 2 seconds or 3 seconds to complete a scheduling of a pod on EC2 managed nodes. Then it might take 10 seconds to get scheduled on Fargate, something like that. Okay, so there will be a delay. Even for delay also, means like deletion also, you can see it will be a delay. So on managed node group, it has deleted immediately, but on Fargate, it took a little bit of time, right? So that's about, I'm trying to clarify here, difference between that. Okay, this is only the difference from scheduling perspective, not on performance perspective. Okay, so now we have deleted that. So let's go back here to our GitHub and then delete the profiles, right? So we are going to delete the profiles, the names app2 and UMS only, -profile is not there. I am going to fix that. This looks good now. EKS CTL delete Fargate profile from cluster EKS demo1, name is FP app2 and then wait. Okay, so wait, what it does is it will, EKS CTL will wait till this profile is deleted. And one thing you need to remember here is like only one after the one Fargate profile only we can delete it. So you can remove wait and then if you want to execute 2 commands, it is not going to delete. So only one Fargate profile will be deleted first and then next you can delete the second one. Okay, so in an orderly manner we need to delete these things. It will take close to 3 to 5 minutes to delete these profiles. So once deleted, everything will be clear from Fargate profiles perspective for us. When we go back to our GitHub repo, so if you see here, so there is a reference GitHub issue for ALB ingress with cross namespaces. So the issue and then those related information and then discussions about from 2015 onwards about these cross namespaces you can find here, about workarounds and then all those things. So whatever we have discussed here, right? So whatever is not possible here, it's related current ongoing in GitHub issue, you can find the information here. So this completes the Fargate related two important sections. One is Fargate Profile Basic and then Fargate Profile Advanced. Okay, so in our next lectures we'll focus on another topic, maybe like microservices or DevOps. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a star freelancer.